Здравствуйте, laptop.
Hello, sir. Good morning. Good morning, everyone.
Ma'am, very good morning, ma'am. Very good morning.
Good morning.
Can we start with the session, ma'am, if you could permit?
Yes. Please go ahead.
Friends, good morning once again. I extend my warm welcome on behalf of Malvi Mission Teacher Training Center, St. Gadge Baba, Amravati University, to our esteemed and scholarly expert, Professor Divya ma'am, to this refresher course and particular to this session. Also extend my warm welcome to all the learned participants, those who have gathered from the across country for this refresher course. Friends, today is the 9th day of our refresher course. And in the very first session, we have with us a very distinguished and scholarly personality, Professor Divya ma'am, from the University of Pune, Savitribai Phule University of Pune. So, first of all, now may I request Dr. Payal ma'am to please introduce our guest in brief, and then we'll start with the session. Yes, Dr. Payal madam, please.
Yes, sir. So, thank you so much to all the organizers for giving me this privilege of introducing our today's distinguished resource person, Professor Otu Divya Praveen ma'am, who's a professor in Department of Chemistry, Savitribai Phule University, Pune. Professor Divya Praveen completed her PhD in Analytical Chemistry from the prestigious Indian Institute of Technology, Madras, in 2008. She also earned her MSc in Chemistry from IIT Madras and graduated with outstanding academic distinction from the University of Calicut, where she secured the university's second rank in BSc Chemistry. She has more than 22 years of research experience and 17 years of teaching experience. She is currently serving as a professor in the Department of Chemistry at Savitribai Phule, Pune University, after serving as assistant professor and associate professor in the same department. Her research expertise spans fluorescence-based optical sensors, analytical spectroscopy, chemometrics, biomolecular interactions, carbon nanomaterials, and polymeric hydrogels for controlled drug delivery. Her research has significantly contributed to the development of advanced optical sensing technologies and smart functional materials. Professor Divya has successfully completed several externally funded research projects supported by SUB-DST, UGC, and Savitribai Phule University, Pune, serving as the principal investigator in all of them. She has impressive research record with more than 41 publications in reputed international journals, including Analytica Chemica Acta, Talenta, Sensors and Actuators B. ACS Applied Nanomaterials, Journal of Molecular Liquids, Spectrochemica Acta, and several other high-impact journals. She has also authored 3 book chapters, and her work has earned an H-index of 17. Under her guidance, 7 scholars have successfully completed their PhD, while 3 research scholars are currently pursuing doctoral research under her supervision, which reflects her strong commitment to research mentoring. Her academic excellence has been recognized through several prestigious distinctions, including the Best PhD Thesis Award from IIT Madras, qualification in CSIR JRF and UGC NET, an outstanding 97 percentile in GATE, and the prestigious Shire Visiting Research Fellowship, under which she was visiting researcher at Newcastle University, United Kingdom in 2023. She has delivered numerous invited lectures at national and international conferences and has served as a resource person in several UGC HRDC refresher courses, sharing her expertise with faculty members across the country. We are indeed fortunate to have such an accomplished researcher, inspiring teacher, and eminent academician with us today. On behalf of the organizers and all the participants, I extend a warm and heartful welcome to Professor Otto Divya Pravin Madam. We are grateful for your presence and eagerly look forward for your enlightening lecture. Welcome, ma'am. Over to you.
Thank you so much, Payal Madam, for the nice introduction. And I would like to thank Amravati University, UGC Malavia Mission Teacher Training Center for inviting me for today's lecture. I hope my voice is audible and my screen is also visible.
Yes,
Yes, ma'am.
yes, ma'am.
Yes, madam.
Yes, yes, ma'am.
Thank you so much. So we can start the session now. So I'm going to talk about fluorescence spectroscopy, the fundamentals and application. So, 1 second. I'm trying to hide the bar. Okay, so I'm not very sure how many of you already like extensively working on fluorescence, or some of you may be familiarized with this particular topic, or some of you may not be using this as a tool for your day-to-day research work. So what I have, because of vast variety of audience we have, I thought of taking a very basic of fluorescence spectroscopy and what are the problems we generally face while doing fluorescence. And if you are a new person to fluorescence, maybe how can you incorporate fluorescence spectroscopy for your research work? Because what I have observed is that many organic chemists, they synthesize very nice molecules which will show very good fluorescence. But rather than taking it for a particular application, maybe some biological application like anti-cancer, antibacterial studies may be required actually for a publication. But at the same time, as an application, like using this molecule as a sensing probe or using them for understanding its interaction with biomolecules, these type of work can be very nicely done by fluorescence spectroscopy. So that is why I have selected fundamentals and some applications which we can all, like as you are all maybe in the first few years of your teaching, maybe incorporate fluorescence in your research applications. So as you know, fluorescence has got various applications. The first one, which I would like to tell you about the application with respect to interaction with biomolecules, like protein, DNA, etc. So the interaction of maybe you have synthesized a new molecule which can have a potential as a drug. So drug interaction with biomolecule is very important, and we can study it in a molecular level by using fluorescence. And the fluorescent molecule, they have a particular characteristics. The characteristic is that they will sense their immediate environment. For example, you put a fluorescent molecule in ethanol, or you put the fluorescence molecule in glycerol. Their behavior will be different. Not all molecules, but certain molecules which have this viscosity sensing property, they will show different property in ethanol and glycerol. Same way, some fluorescent molecule behave like highly fluorescent in low pH and maybe non-fluorescent in a neutral pH. Or they may give a different species in acidic pH. So these type of information will give us an idea about what's the pH of the medium, what is the micro viscosity, micro polarity. Even oxygen content detection is very important, especially when cancer treatment, the tumor cell recognition and tumor cells understanding is involved. The understanding of the oxygen level is also important, and temperature also plays a very big role in many of the cellular level application. So understanding if there is a change in temperature, change in the viscosity, change in pH by using fluorescent molecule as a probe, that has got a lot of importance, and people have been working for in this particular topic for many years, and still it is a very, you can say, very hot topic of research using fluorescence in these applications. The third one, where I'm also mostly focused, is the sensing application. Like, you know that a molecule can become fluorescent by interactions also. So fluorescent turn on or fluorescent turn off, or there could be two peaks that can be formed in a molecule by interaction with an analyte. All these processes can be tracked. So that comes under the category of sensing. You can use the normal chemical sensing for sensing pollutants, antibiotics, and things like that. Also, we can use for the sensing of certain important biomarker. Biomarker means a particular component which is present in our body, which tells the disease state of our body. For example, glucose, simple example. Glucose, the amount of glucose will give an idea about diabetes problems. So if you are able to sense glucose in a more accurate level, already we have several glucose-based sensors, but more similar to glucose, there are several other biomolecules. So sensing them is extremely important, and fluorescence can do a very good job over there. Now, the next is bioimaging and microscopy. Nowadays, you must have heard about fluorescence microscopy, confocal microscopy, etc. So the fluorescent molecule can be easily tracked by using this microscopic method, which are very advanced recently. And if you have a particular fluorescent molecule, organic molecule, this molecule, when it is interacting with the cell, it can either, whether how it is getting inside the cell, and sometimes it gets inside the cell, it may be present in the cytoplasm, sometimes it will concentrate on mitochondria, sometimes it will concentrate on the nucleus. Based on where this particular fluorescent molecule goes and sits, we can understand, for example, if it is in mitochondria, we can understand like many processes, mitochondrial dysfunction and energy storage mechanism, and all these things more clearly we can understand. So there is a organelle targeted fluorescent molecule. For example, mitochondria targeted molecules generally will be cationic in nature, because the membrane potential, negative membrane potential of mitochondria will be having more affinity for a cationic type of fluorescent molecule. So that study is also extremely important. And recently, not recently, maybe 10, 15 years, this live cell imaging has become very important. It actually helps in different health conditions to give an idea about the real monitoring of the cell functions, the tracking of that, and metabolism properties can be tracked by live cell imaging by using microscopic method. So since we have, these are only few applications, I have noted it down here, but there are n number of applications. And if you are like thinking of utilizing your molecule for this application, you can think about any of these applications. So with this, let me start with the introduction. So I have arranged my talk in this way. First, I'll give an introduction to fluorescence and parameters which are like important in fluorescence and photophysical properties, little bit about instrumentation and the common errors we generally come across in handling fluorescence, and application. And I thought maybe if some of you are teaching postgraduate students, maybe we can introduce certain practicals. So which we are doing in our department for the master's analytical and inorganic students, we are actually started a few practicals based on fluorescence. So I thought of sharing that also. So first, let me start from the basic. What is fluorescence spectroscopy, or what is the, in general, you know that spectroscopy is nothing but light matter interaction. So when a molecule is excited by a photon of a particular energy, due to the resonance, there could be absorption that can happen, and the electron is get excited to another level. So the molecule now becomes an excited molecule, where the electron movement means electronic transition has happened. So obviously, compared to the ground state, this is the ground state, the excited state will be having a higher dipole moment. Dipole moment means it's charge separation. So when the photon interacts with the molecule, the electronic transition happens, which give rise to a dipole moment. Now, all the molecule will not experience a higher dipole moment based on the type of the molecule, whether the molecule is highly nonpolar or slightly nonpolar or polar. Based on that, the change in the dipole moment will be different. Now, in the excited state, this molecule stays for some time, like for example, nanosecond time scale, it stays in the excited state. During that time, the molecule get modified by the environment. For example, solvent molecule. So imagine you have a slightly polar molecule. There is a charge separation and there is ethanol solvent. So ethanol is also polar in nature. So the ethanol molecule surrounds this particular molecule. So there is an energy minimization happen because there is a stabilization in the structure. Energy minimization happens. So slight energy change, decrease will happen to that particular molecule. Finally, it will come back to ground state because of anyway it has higher energy. It comes back to ground state with the emission of photon. So this is the process of fluorescence where photon is emitted from the excited molecule. Now, when you go to a little bit more about that, like we know, most of you must have heard about the term luminescence. So luminescence is nothing but emission of light. Now, I have used one more word here, that is spontaneous emission of light. This is very important because you generally hear the emission is not stimulated by anything. It is spontaneously occurring. For example, you must have heard about in laser. Laser, it is a stimulated emission. So stimulated emission and spontaneous emission are different. Now, luminescence is categorized under spontaneous emission of light. This obviously occurs from the electronically excited state. You must have heard about electroluminescence, cathodoluminescence, thermal luminescence, like different forms of luminescence are there. In all these processes, emission happens and a photon is generated. But the process of excitation, like absorption of light, will be different. For example, in cathodoluminescence, it is energized electrons are responsible for excitation. In thermal luminescence, heating is the responsible factor for excitation. But emission happens and you will be able to see the photon, that is fluorescence is observed. Again, the luminescence is categorized to two types, fluorescence and phosphorescence. They are depending on from which stage the emission happens. So the person who is like widely responsible for this understanding of the various processes involved in absorption and various vibronic relaxation and finally fluorescence is Professor Alexander Jablonski. He is known as the father of fluorescence spectroscopy. So he very beautifully explained this by using Jablonski diagram. So this is the important Jablonski diagram which I have taken from the net. The reference is given over here. So the diagram looks a little bit complicated, but it is actually very simple. You have a ground state and the ground state comprises of different vibrational levels as denoted here. And absorption happens like when the photon of suitable frequency approaches the molecule absorbs that energy and goes to any of these excited state. It could be the first excited state or second excited state, depends on the energy of the excitation. This process is known as absorption. As you all know, the green line represents absorption. And the absorption, it happens in femtosecond time scale. That means very fast, 10 to the power minus 15 seconds it happens. During this absorption process, the nucleus is not aware about this electronic transition. Electron moves so fast before the nucleus recognizes such a change. It's very fast process. Once it reaches the excited state, let it be the first excited state or second excited state, immediately the relaxation will happen. See, these yellow lines represents the relaxation. It is a vibronic relaxation, or it could be an internal conversion between the two excited energy levels. It comes back to this lowest vibrational state of the first excited state. It comes over here. Why it is coming like this? Because the internal conversion or vibrational relaxations are in the time scale of picoseconds or 10 power minus 11 to minus 14 seconds, generally in picosecond time scale. So this happens fast compared to the fluorescence because fluorescence happens in nanosecond time scale. So the electronic excitation happens, they get some time in the excited state. During that time, some relaxation process will happen and the electron comes back to this ground vibrational level of the first excited state. From there, the spontaneous emission, as I told you before, happens and this red line represents the fluorescence. Now, in some cases, what can happen is this particular excited state undergoes certain reactions, or maybe the emission happens not by the emission of a photon, just by a thermal emission it can happen. So these are known as the inter-system cross, it means these are also the internal conversion, which is, you can say, non-radiative relaxation. That means you will not observe any photon, any radiation, but these are fluorescence. And in some case, you must have heard about the triplet state because of certain process known as spin orbit coupling. Yes, spin orbit coupling, what happens is that, I will explain in the next slide about the spin. Due to spin orbit coupling, the electron spin changes and goes to the triplet state. In the triplet state is actually, it's a spin forbidden transition. Singlet to triplet is a spin forbidden. It's not normally happen, but under certain conditions, like based on the structure of the molecule, this type of transition is possible. And from here, the relaxation happens by two ways, either non-radiative or radiative. If it is a radiative transition, it is known as phosphorescence. Otherwise, it's just a relaxation. So phosphorescence is a bit long-lived. For example, it is a millisecond time scale, milli to, in some cases, microsecond time scale, this phosphorescence can happen. So this spin forbidden transition happens not for all molecule, but they are at very slow rate also. So this already I have explained. So this is what I wanted to just explain to you regarding the singlet and triplet state. And I hope most of you are aware about the singlet and triplet state, how to calculate the spin multiplicity. So in this case, this represents the molecule in the ground state. After excitation, as I told you, the electronic excitations are very fast as per the Franck-Condon principle. The spin will remain the same. That means it is paired with the electron in the ground state. So total spin, again 0, spin multiplicity is 1. So during the spin orbit coupling, there could be a possibility that the spin can be reversed. And now the total spin is 1. So because of that, the spin multiplicity is 3. That is why the state is the triplet state. Now, for this electron to come back to the state, it needs to reverse the spin and come, and that will take time. And that is why the triplet states are long-lived. Now, there is a disadvantage for a state to be long-lived. When it is long-lived, it can get attacked by oxygen. It can get attacked by different other reactions. So you can say that the luminescence will be less in case of triplet state. So that is why, in order to observe phosphorescence, we need to provide certain conditions, like we need to provide a nitrogen atmosphere, or we need to freeze the system so that other vibrational relaxation or internal conversions doesn't take place. So I hope you are able to follow. If you have any questions in between, please stop me. You can ask me questions in between. Okay, so this represents the normal spectrum. As you are aware about the absorption spectrum, we generally take absorbance along the y-axis and the lambda in wavelength in nanometers along the x-axis. In case of fluorescence also, we generally, the x-axis will be wavelength, but y-axis will be fluorescence intensity of the fluorescence. Now, one more thing you must have observed here, the fluorescence is redshifted to that of the absorbance. So absorbance have a higher energy compared to that of the fluorescence. That is always, some people makes this particular mistake. They may, even though the absorption happens at 350, they may tell that the emission happens at 340. That is not possible. Only after the energy of the fluorescence always will be less compared to that of the absorption. That means the wavelength will be always redshifted to that of the absorbance. So this, whatever I have just told you, that the rules, there are certain rules to be followed in fluorescence emission, and that are given by Kasha's rule, Stokes shift, and mirror image rule. Now, let me tell you, many of you may be working on nanomaterials and lanthanides, and they may be showing fluorescence. But if you see nanomaterials, they may not behave just similar to an organic fluorophore, because in that case, size-dependent properties are more predominant. But in this case of organic fluorophore, they follow a pattern, and which is like very less number of exceptions you can see. Most of the molecule follows this 3 rules. So the first is the Kasha's rule. This is Michael Kasha. He's an American molecular spectroscopist. What he proposed is that wherever you excite, imagine this is your excitation spectrum, and I also wanted to, I hope you people know about this excitation spectrum and emission spectrum. So excitation spectrum is almost similar to an absorption spectrum, but we don't consider it in the absorbance spectrophotometer. Spectrofluorimeter itself is able to give us an emission spectrum also, an excitation spectrum also. So if you get an excitation spectrum like this, which is almost similar to an absorption spectrum, you excite the molecule at here or here or here, any point you excite, you get the same lambda max, same emission wavelength. The intensity will be different. So intensity depends on the transition probability. For example, this is our lambda max. So obviously fluorescence maximum intensity you will be getting here. But what I wanted to tell you is that the lambda max remain unchanged, irrespective of the excitation wavelength. That is proposed by Kasha. So why this is happening, why it is irrespective of the excitation wavelength. So what happens is that after absorption, I told you all these internal conversion, vibrational relaxation, all happens. Finally, the electron comes to this ground vibrational level, that is the 0th vibrational level of the first excited state. And the emission always happens from here. So when emission happens from here, the 0th level, wherever you are exciting, like you are exciting, the emission will happen always from this particular level. That is why this particular rule, Kasha's rule, is applied. So as per the Kasha, he has written in the paper in 1950, the emitting level of a given multiplicity is the lowest excited level of that multiplicity. So multiplicity, for example, this S1 state, here the lowest excited level is this. From there only the emission happens. That is proven, and that is applied to all fluorescent molecules. Now Stokes shift, it is nothing but the difference between, for example, this is your excitation spectrum or absorption spectrum, and this is your emission spectrum. As I told you, emission will be always redshifted, and the difference between this lambda max, maybe you can either express in terms of wavelength or wave number. The difference between this is known as the Stokes shift. This was first identified by Sir G.G. Stokes in 1852 at the University of Cambridge. And this typically also tells that the low fluorescence generally occurs at the lower wavelength. For example, you consider these two molecules. One is rhodamine 6G. I don't know if you can see the structure. This is the structure of rhodamine 6G. This is DCM. It is dicyanomethyl methyl dimethyl aminosteryl pyrene molecule. So this is that particular molecule. In this case, you can see a very small, about 21 nanometer Stokes shift. But in this particular molecule, you can see a Stokes shift of 163. So getting such a molecule which has a very high Stokes shift, we need reasons why it is showing this type of a trend. So the first reason is that rhodamine 6G is mostly a planar type of a molecule, and it is not that much affected by the solvent around it. But in the case of this molecule, they have a very good electron donating group and very good electron withdrawing group. So they behaves like a push-pull type of a molecule, and there is a charge separation in this type of a molecule. Because of that, that molecule interact with the solvent very efficiently. So when it interact with the solvent, there is a relaxation happens to it. So whatever emission happens, it happens with lower energy. So a longer wavelength is observed. So that is the reason. So understanding this of why a Stokes shift is observed in that particular molecule, maybe this particular molecule may show different Stokes shift in different solvents. So that will give an idea, or you can use that particular molecule for different applications. Now, also in some cases, you must have seen this type of structured emission. Structured emission means, for example, here you have seen there is only one peak, one Gaussian curve, very smooth curve you can see. But in this particular molecule, you can see a structured emission. The structured emission arises because of the distinct vibrational levels involved in that particular molecule during this process. So now mostly you will see this type of structured emission in highly nonpolar molecule like pyrene, perylene, anthracene, and things like that. So from the structure itself, you know that they are highly nonpolar. They will be unaffected by the medium solvent, or they mostly are planar in nature. So that also responsible for this type of a structured emission. Now you can see here in this particular case, perylene, the fourth band is more intense. And in this case, the third, I think the fourth and fifth band are intense. So which band is intense? That is actually governed by Frank-Condon principle. So first I'll come to this Frank-Condon principle, this very familiar energy level diagram. Here you can see that this y-axis represents energy, and this represents the internuclear distance, the nuclear separation. Now, these are the various vibrational levels, and you can see that the red curves, they are the wave function of the quantized vibrational levels. Now, the strongest absorption, for example, absorption probability, if you see transition probability, when you see the strongest absorption transition will be where there is a greatest wave function overlap. For example, in this case, you see this is the maximum amplitude for this wave function here. It overlaps with this particular one. Because nu equal to 0, it is passing through the minimum. Nu 1 also passing through not the maximum, and here it passes through the maximum. So the maximum transition probability will be 0 to 2 transition. From S0 to S1 state, nu 0 to nu 2 transition is the most probable type of transition. So I will just show you with an example. Like in this particular example, there are two molecules. 1 second. Yeah, in the first case, you can see from nu 0 to nu 0 of the excited state transition shows maximum probability. That is the reason 0-0 transition is more probable transition. But in the case of this molecule, nu equal to 0 to nu equal to 2 transition is more probable, not the 0 or the 1 transition. So that is the reason the third peak shows the maximum probability. So there are two things we have to understand here. First is that the structured emission arises because of the distinct vibrational levels involved in that electronic transition. In some molecule, you will get a smooth Gaussian curve. The vibrational levels are not distinct. This is mainly because that molecules will not be highly nonpolar. They may not be having a planar structure, so they will interact much more vigorously with the solvents. Now, the second part is that which of the transition probability has the maximum intensity, that is determined by this wave function overlap. So these explanation only I have written over here. Like, for example, y-axis is the energy of the molecule. This is the internuclear separation. And these are the wave functions of each vibrational level. So this is actually governed by the Frank-Condon principle. It states that electronic transition occurs without change in the position of the nuclei. So it is a fundamental rule in spectroscopy and quantum chemistry that explain these type of intensity of the vibronic transitions. So that is the reason we are getting structured emissions. In some cases it's just a simple Gaussian curve. Now, the third important rule of fluorescence spectroscopy is the mirror image rule. It tells you that same vibrational levels are involved for the absorption also and the emission also. For example, this is 0 to 2 transition, 0 to 1 and 0 to 0. While emitting also, it happens from this lowest vibrational level. It should be from here to 0, from here to 1 and here to 2. So that is why this will be exact mirror image. Also, it is redshifted. This is redshifted because always emission, some relaxation happens, some loss in energy happens, and final emission happens from this state. So that's why it is always redshifted. Now, if you see this particular case, this is perylene and this is quinine sulfate. So perylene shows a very good mirror image. Perylene, the absorption spectrum, exact mirror image of the emission spectrum. This is because the perylene molecule, as I told you, it's highly nonpolar, it's planar, and it doesn't interact with the surrounding solvents. So you will be getting such a good mirror image here. But in case of quinine sulfate, you can see there are two bands in the absorption, but emission has only one band. And this emission, this particular band is a mirror image of this particular band, 340 band. This is actually arises due to S0 to S2 transition. And we cannot see S0 to S2, S2 to S0 transition emission, as all the emission happens from the S1 state. So this will not exactly follow a mirror image rule. But mirror image is completely observed in perylene molecule. Now, there are exceptions in the mirror image rule. For example, if a fluorophore is pH sensitive, so the pK changes in the excited state, especially a highly nonpolar, means polar type of molecule, this mirror image rule does not work exactly. And if there are excited state reaction or there is a dimer formation in the excited state, in those cases also this rule is not followed. So these are the important characteristics. Now we'll come to the different type of fluorophores. Like when you...
Excuse me, ma'am.
Yes, please.
Can you explain why it is not following that mirror image rule, ma'am? In some cases only we are seeing this, right, ma'am?
Yes, is very
Why it
good.
is so, ma'am? Many possible reasons are there.
Yeah, see, mirror image rule, first of all, in case of quinine sulfate, I told you it will not follow the mirror image rule because it has both S0 to S2 and S0 to S1 transition. But I told you emission happens only from the lowest exciter, that is the S1 state only. So we will be able to see only S1 to S0. Here we are able to see S0 to S2 and S0 to S1. This happens only S1 to S0. The second reason is that I told you pH plays a role. For example, perylene does not have much influence with pH because it's highly nonpolar in nature. But some molecule, especially when they are slightly polar in nature, they get immediately influenced by the pH and solvent, etc. So when there is a pH change happens to that, the excited state is modified. When excited state modify, a new species will form. For example, in the low pH, protonation happens. Now there is a NH2 group get protonated. That means a new species is formed. So new species, I'm expecting an emission here, but new species will not emit here. It may emit somewhere here. In that case, I may get a dual type of a band. That means it will not follow mirror image rule. So pKa plays a role, and this molecule itself, the molecule's charge or the polarity of that particular molecule, again polarity of the solvent, and the pKa. These plays an important role in determining whether the molecules shows a mirror image or not. Okay, so
okay, ma'am. Ma'am, if I'm right that if this perylene is in benzene, perylene is dissolved in benzene, solution of benzene, whereas this quinine is in acidic medium.
Yes.
So this could have be the reason, right, ma'am?
Yeah, that means in the acidic, see, perylene will not be able to interact with the solvent that much because both are non-polar in nature. But in case of quinine sulfate, we have H plus ions, the acid. Even in quinine sulfate, in normal, means non-polar solvents will not, for example, it will not dissolve in non-polar solvents, first case quinine sulfate. Quinine sulfate water is sparingly soluble. So the best medium for its solubility to get high fluorescence is sulfuric acid. But sulfuric acid is not the exact reason of its fluorescence. Even in water also sparingly soluble, it shows fluorescence. But that's what I told you. There are several things we have to consider. The structure of the molecule, the polarity of the molecule, the acidity of the environment, the solvent, all plays the role in determining that. In case of, as you told is correct, quinine sulfate, we dissolve in sulfuric acid, but in water also it shows a similar peak.
Okay, thank you, ma'am. Thank you.
Ma'am, does we have to consider symmetry of the molecule in this case? Symmetry of the molecule.
Yes. The symmetry also plays. See, symmetry. That will be an other topic. For example, anthracene, naphthalene, perylene, and all. They show the structured emission because of their geometry also. So that topic I have not covered here.
Ma'am, again, one question is that how that hydrogen bonding affects the solvent that modifies the fluorescent intensity.
Yeah, hydrogen bonding
shape is also changed.
Yes. Hydrogen bonding affects the fluorescence a lot. Again, I'm telling you, hydrogen bonding, it can happen because of the solvent also. For example, I have some examples later, like in the presence of ethanol, there is a hydrogen bonding takes place, and because of that, redshift is observed. So this is known as a specific solvent effect. Sometimes the hydrogen bonding will be happening, intramolecular hydrogen bonding can be possible in certain molecule. So that is not possible in the ground state. But when it goes to excited state, the hydrogen bonding charge transfer are possible. Again, which will lead to a new species, a new red emission is possible in those cases. Okay, so I'll come back to the hydrogen bonding example. I will show you that.
Okay, ma'am. Thank you.
Okay. So now coming to the type of fluorescent molecule, we have wide variety of fluorescent molecules. These are like a standard molecules like quinine, acridine orange, fluorescein, rhodamine, pyridine, etc. are excellent molecule. Nowadays also, if you see the literature, you can see that several of these molecules are modified to get a better sensing or better target for the different organelles. For example, rhodamin B is widely used nowadays also because of its excellent fluorescent properties. So most of these have an extent of conjugation. Several pi bonds are present. So that could be the first reason why a molecule can be fluorescent. For example, if you take the example of butadiene and diphenylbutadiene, butadiene absorption is something like 210 nanometer and very less actually. But when you have a phenyl group over here, that means you are introducing more a pi system, conjugation increases. Because of that, there will be a homo-lumo gap, decrease will happen. So energy decrease, that means the wavelength is getting increased to this. Also, the molecule become more fluorescent in nature. One second. Yeah. So this molecule, butadiene, is non-fluorescent, and diphenylbutadiene shows highly fluorescent. So mostly aromatic molecules shows fluorescent property. The conditions are that they should have a rigid framework, because if they have loosely bound substituents and all, the vibrational energy can flow through that and it will not become highly fluorescent. Also, they should have low energy pi-pi star transitions. That are the main condition, and they should have extent of conjugation also in the molecule. For example, if you take these cases, naphthalene, anthracene, naphthacene, pentacene, as the conjugation increases, the absorption and the fluorescence will be shifting to the longer wavelength because of homo-lumo gap decreases. And also the quantum yield will be very high. Compared to naphthalene, anthracene shows a better fluorescence efficiency. Now you take the case of an electron donating substituent, acridine, almost like non-fluorescent, but when acridine is having this dimethyl amino group, both sides, they are highly electron donating group, the donates electron. So because of that large number of electron, the homo-lumo gap decreases and the molecule become more fluorescent in nature. So electron donating group increases the transition probability and increases the fluorescence quantum yield. Now, if you take a very good example of terephthalic acid is non-fluorescent. But immediately, if you have an amino group or hydroxy group in this particular molecule, in this position, NH2 group, amino terephthalic acid or hydroxy terephthalic acid, they become highly fluorescent in nature. That is because you have an electron donating group that donates electrons to the system, but at the same time, they will work as a push-pull type of mechanism. Like amino group will be donating electron, carboxyl group will be withdrawing electron. Because of that extent of conjugation, the fluorescence intensity increases. So nowadays, you can see terephthalic acid is widely used in several sensing systems, especially when there is a hydroxy free radical generation and all. So hydroxy radical causes the terephthalic acid to fluoresce because of this particular reason. Now we have various another compounds also, especially aromatic aldehydes and ketones, but they mostly have a problem. They have N-pi star level also. So most cases, N-pi star will be the lowest energy level. So what will happen? N-pi star transition, as you know, it is not having very good quantum yield. Probability is very less for that. So depends on the solvent, the quantum yield changes. For example, when you increase the polarity of the solvent, more polar solvent we are using, pi star will become the lowest energy level. So pi star transition will happen, and because of that reason, fluorescence quantum yield increases. The same thing happens with these heterocyclic compounds also, pyridine, quinoline, acridine, etc. Most of this simple basic molecule I have given. There are several modifications of this molecule. These will have, especially with protic solvents, there is a possibility of hydrogen bond formation, nitrogen atom in the solvent molecule. Because of that, N electrons are not available because it's already bonded with hydrogen. So there is an inversion of the lowest lying N-pi star to pi star. Now the lowest low-lying state is the pi star in case of protic solvents. So they will have more probability of transition, so the quantum yield increases. That means if you see the acridine itself is not highly fluorescent, you need to have the electron donating group there, but these groups also will be fluorescent mostly in the protic solvent. Non-protic solvents, because the hydrogen bonding probability is not there, they still have the N-pi star transition as the maximum lowest lying transition. So fluorescence intensity will be less in those cases. So these are the certain things you need to understand. Sometimes we prepare a very good molecule. There is extent of conjugation. We expect that the molecule will behave like a very good fluorescent molecule. But when we take the fluorescence, we observe that very negligible fluorescence. So you need to understand these consequences. Maybe you change the solvent, maybe you change the pH, maybe you will be able to get some fluorescence, or try to understand why this molecule is not showing fluorescence, whether rigidity is lost, or vibronic energy is flowing through other pathways, or any other reason is there why this molecule. So we can rectify that and use them for better applications. Now, coming to the important parameters, whenever we get a fluorescence spectra, imagine you synthesized a compound, you wanted to, for example, understand the parameters. First, you will take an absorbance spectrum. Absorbance spectrum, you understand the molecule absorbs at particular wavelength. The next step is you will do a fluorescence spectrum. Now, when you get a fluorescence spectrum, there are a few things that you have to remember. Intensity of the fluorescence is very important. Emission maximum, lambda max, is very important. And also one parameter is which is known as the fluorescence quantum yield, which is a parameter to identify how good my molecule is with respect to fluorescence. So if fluorescence quantum yield is good, that means the molecule is very highly fluorescent in nature. Sometimes you can use that particular fluorescent molecule, maybe having a low quantum yield, very low quantum yield molecule. Still, you can use them for certain application by changing the instrumental parameters. So I'll come to that. And the another instrument which will give us an idea about the how much time, average time, the molecule stays in the excited state, that is a fluorescence lifetime, but the instrument is entirely different from normal instrument. So there are mainly two types of instrument. One is steady state fluorescence instrument, spectrophotometer, which measures intensity versus lambda. You can get information related to intensity, lambda max, even you can get information related to the quantum yield. You can also understand a parameter known as anisotropy. These are possible from a steady state spectrophotometer. Now there is something else that is a lifetime instrument, that is time correlator, single photon counting instrument is there, which will measure the lifetime. So I mainly is going to focus on the steady state fluorescence. So the first is fluorescence intensity. As you all know, absorbance is directly proportional to concentration, also epsilon, and the path length. Same way, intensity of the fluorescence is also related to that. That means if the absorbance increases, emission also ideally increases. That means the concentration change increases, intensity increases. Other than that, there are two more parameters which are very important in case of fluorescence. That is quantum yield, I told you already. Some molecule will have very high quantum yield, some molecule will not have. Again, depends on the structure of the molecule, depends on the solvent we are using, and various parameters, the quantum yield will be different. Another important parameter is the intensity of the incident light. See, in absorbance, this is never important, intensity of the incident light. But in fluorescence, it is important. For example, you use 150 watt lamp for your experiment, you may get 10,000 as a maximum intensity. But instead of 150 watt, you use 450 watt lamp, then intensity may go up to 1 lakh also. So intensity of the light emitted depends on all these parameters: absorbance, intensity of the excitation light, as well as the quantum yield. Now, one more important thing that you need to remember is that the sensitivity of this instrument, or you can say detection limit. Absorbance spectrophotometer, we can measure the concentration, maybe micromolar solutions. Less than micromolar, 10 power minus 6 molar solution, it is very difficult to get any absorbance. Maybe it is negligible or almost like zero absorbance you will get. But in fluorescence, even if you go up to nanomolar concentration, you will get some signal by playing around with intensity of the incident light or concentration and certain instrumental parameters like slit width and sensitivity, etc. You can get the detection limit much better to absorbance. So absorbance spectrophotometer, whatever sensitivity you are getting or limit of detection you are getting, you can get 1,000 times better in case of fluorescence. So greater limit of detection is possible in case of fluorescence. Now, I told this particular term called quantum yield. It is nothing but a ratio of how many molecules you have absorbed. If all the molecules are emitting, that means the quantum yield is 1. So it may not be 1. Ideal cases only you will be getting 1. It's very difficult to achieve because vibrational relaxation and many other oxygen mostly act as a quencher. So because of this reason, you may not get always a high quantum yield. So number of molecules emitting fluorescence by number of molecules like absorbing fluorescence, that ratio is known as the quantum yield. So lifetime is another important parameter which will give us an idea about how much time, average time the fluorophore sits in the excited state. Now the importance of lifetime comes in this way. For example, you have a protein molecule, and the protein molecule have two different type of tryptophan. As you know, protein, the main fluorescent species of protein is the amino acid tryptophan. Tyrosine and phenylalanine also are fluorescent in nature, but their quantum yield is either very less or they are not having a very good lifetime. But tryptophan is a amino acid which is the, you can say it's a luck for the protein for the study, because tryptophan is highly fluorescent. Not only that, it senses the environment, the polarity and the viscosity, everything of the environment. That means with respect to the change in the environment, tryptophan's fluorescence will change. So the lifetime is one of the important method for understanding the protein and how the protein folding and unfolding happens and how its interaction happens. So this slide I am just skipping. Now you see in this case, this particular molecule. This is an eosin molecule when X, this X is bromine, and when X is iodine, this is erythrosin B molecule. The structure, everything is same. The only difference is that instead of bromine, we have iodine. But by changing this particular atom, the fluorescence intensity decreases enormously. That means the quantum yield shift from 0.6 to 0.1 almost. Lifetime also changes. This is because iodine is a heavy atom. And this heavy atom presence causes most of the spin orbit coupling. So due to this heavy spin orbit coupling, the electron immediately go to the triplet state. And I told you triplet state is like easily accessible by quenchers or other molecules. So the fluorescence ability of that particular molecule is lost. That is why we are getting a very low, you can say, quantum yield in the lifetime. So this was a very wonderful observation in the beginning. And from there only, they have understood the role of iodine in different fluorescence related experiments.
Excuse me, ma'am.
Yeah.
Ma'am, if this erythrosin goes to the triplet state, will it
Yes.
not be, showing the phosphorescence, ma'am?
No, again, there is a case like it goes to triplet state. But I told you triplet state is long-lived. 10 power minus 3 seconds, it is staying in the excited state. During that time, it can again come back to the singlet state, showing delayed fluorescence. So those type of things are also possible. And the overall, what happens is that there is type of quenching happens. So the heavy atom quenching is one of the phenomena where especially iodine, and in some cases even chlorine also, in case of bromine and sulfates and all, what happens is that there is this reduction in the fluorescence intensity because they interact with the molecule very heavily. So the fluorescent property, like, phosphorescence is not easy to see. Phosphorescence may be happening, but we will not be able to see that. One thing. Another thing is that during that lifetime, the molecule undergo different transitions. So the probability, this represents the S1 to S0 transition only. What I'm telling is that some of the energy is lost to the triplet state, and from the triplet state is completely gone. Okay. In some cases, what happens? Delayed fluorescence happen. Eosin, there is a molecule called eosin. Eosin shows delayed fluorescence. But erythrosin B, the delayed fluorescence possibility is less. But what happens to erythrosin molecule is that because of the presence of iodine, imagine you have 100 energy, 75 energy is gone to triplet state. Only 25 energy is there in the 25 excited states are present. So only from there the emission happens. So this is fluorescence only. It is not phosphorescence. Fluorescence happens, but most of the molecules would have gone into the triplet state, and they are like quenched. That means that is not happening. So that is why this is emitting with less probability, with less quantum yield.
Ma'am, excuse me. So why there is iodine results in shorter lifetimes?
Yeah, because now see, whichever affect the excited state, whichever molecule, if see the from the ground state, imagine we have 100 molecules. 100 molecules, 75 gone to the excited state. Now, lifetime gives an information about the excited state. So the 75 molecules which are in the excited state in the beginning in case of eosin, they all come back and they have a lifetime of 0.65. Now what happened out of 75, 50 gone to the triplet state. Now only 25 is remaining in the singlet state. So their lifetime, that means because most of them has already gone to the triplet state, the quantum yield also reduces. You see in the last, this one I did not tell you, this lifetime is directly proportional to this parameter. Now, what is this parameter? This is the rate of non-radiative decay. That means other processes. This is the rate of radiative decay. Now, if this is higher, what will happen? If this becomes higher, this becomes smaller, right?
Yes, yes,
So
yes.
that is what happens here. In case of iodine, this process is maximum. When this maximum, this becomes less. That's the reason why
So can I say that average, average lifetime what we get this type of experiments like TCS PCR like this. So
yes.
this average lifetime, this lifetime value is also dependent on the number of molecules in the excited state.
No, it is not dependent on the number of molecules. See, I have given you that example of 100, 25, 75.
No, I understand this equation, but just physically I want to understand.
No, it does not depend on the, actually lifetime does not depend on the concentration. Okay.
Yeah, it should be like that, yes.
Yeah, fluorescence intensity depends on the but this is not. But for you to understand that, I have used that particular terminology. It's exactly. Okay. Yeah.
Ma'am, is it true that always fluorescence is important in visible region only?
No, but mostly what happens, for example, if depends on the case. For example, in case of protein, tryptophan, excitation is in the UV range, but emission happens like something like 360, almost near to the visible range. So it's not important. There are species which are emitting in the near about UV range. For example, 340 to 360 also emission is. It's not important, but depends again for the application. For example, you wanted to do bioimaging application. So you want to see a green fluorescent light. So you cannot expect to have a UV emitting type of this one. So based on your application, or you want to do a naked eye detection of something like color change or something. In that case also, it is not possible to have that. But there are certain molecules which will emit in that near visible range also.
Thank you.
Now, this quantum yield is that parameter which generally nowadays there is absolute quantum yield measurement instruments also, but they are a bit costly, but nobody means very less people favors that. But mostly we use a comparative method which is proposed by William et al. So in comparative method of quantum yield, we have a standard molecule with a known quantum yield. And we measure the fluorescence intensity of our sample along with the standard sample under the same absorbance and under the same conditions. And also one condition is that both your standard as well as the reference should have almost similar excitation wavelength. With this particular condition, we measure the fluorescence of standard and sample, absorbance of standard and sample. Ideally, absorbance should be same. And using this equation, this is the quantum yield of the standard, intensity of the fluorescence of your compound, fluorescence of the standard. Ideally, this parameter will be 1. You can calculate the quantum yield of the molecule. This is how ideally we calculate. And this has been given in certain references by fluorescence books by Parker and all, which emission range for, these are some of the compounds which are used as standard compound, and we calculate the quantum yield based on that. Now, coming to the some advantages of fluorescence, as you know, fluorescence from my talk, I'm just telling that it is a very easy method, and also it's very simple method actually. You don't need a particular expert for taking the spectrum. Actually, just like absorbance spectrum, you can take the fluorescence spectrum. And the thing is, these two words are very important: selective and sensitive. They are highly sensitive. Even you can go nowadays less than nanomolar levels also you can go for the determination of the analyte. And it's highly selective also, because maybe two molecules have same absorption, but they may not have the same fluorescence. Now imagine both are fluorescing at the same wavelength, but they may not have the same absorption wavelength. That means the excitation wavelength. So that selectivity is there, and instrument overall the cost nowadays is about 10 lakh or something, but in general, if you are applying for like to a particular center for fluorescence measurement, maybe 100 per sample or 150 per sample only it will cost. And the rapid diagnosis ability is there. Now, some disadvantages is that all molecules are not fluorescent, as I told you, and there is problem of photostability in many cases. So nowadays people are making quantum dot and other things to overcome this problem of photostability. And even sometimes some organic molecules causes this problem of biotoxicity also, so cannot be used for that type of application. But there are alternatives that are coming by to overcome that. And also, as I told you, most of the organic molecule, they're susceptible to the change in the pH and oxygen level. So that's why short lifespan of fluorophore, that also causes as a disadvantage. Now, some of the important photophysical property I will discuss. Maybe I'll go a little bit fast. If you have any doubt, you can just ask me. The first is solvent effect. That means the effect of solvent, which I have discussed many times, and fluorescence quenching, energy transfer, Excimer exciplex formation, charge transfer, proton transfer, etc. So first, the solvent effect. So imagine this is our molecule in the ground state. Upon absorption, it goes to the excited state. And I told you electronic transition happens, means there is a change in the dipole moment. There is a charge separation. That is dipole moment. Now imagine this molecule is not non-polar. That is why this possibility is there. So charge separation happens. These are our solvent molecule. So solvent, imagine you have a solvent which is again not non-polar. It is a polar solvent. It will try to orient around this particular molecule. Okay, the positively charged one will attract the negative end and vice versa. So you can see here an organized way you can see. So whenever there is an organization, there is a lessening of energy. Energy minimizes, stabilization happens. So this is the first state where it gets excited. It comes to this state. But because of the relaxation, because the energy is minimized in this structure, it comes to this state. This is not triplet state. Huh? This is not triplet state is here somewhere, which we are not discussing right now. That means the spin has not yet flipped. Spin is in that state, but it just relaxes. Energy slightly decreases. Okay, it is different from the vibrational relaxation. It is because of the solvent this is happening. Now the emission happens to a new state, because still after emitting also, still the solvents are surrounding the molecule. So molecule not completely relaxed. After coming back here, it slowly relaxes. Solvent move away from the molecule and it comes back to this state after coming here. So what you can observe is that in a polar solvent, where there is this orientation is maximum, you will be getting a red-shifted peak. When you are using a slightly non-polar, you will be getting the normal or the blue peak. For example, you take this case, DNS is a wonderful probe, dimethyl amino nitrostilbene. It has this dimethyl amino group as the electron donor, and there is a nitro group, which is an electron acceptor. So obviously they will be able to form this type of arrangement that can be surrounded by the solvent. Now you take butanol. In case of butanol, if you see the dotted line represents the absorption spectrum. In cyclohexane and in, hexane and butanol, there is not much change in the absorption. There is a slight shift is there. But if you observe fluorescence, the hexane fluorescence is here, butanol fluorescence is here. Almost like 200 nanometers Stokes shift is observed. So somebody asked me about that Stokes shift change. This is the reason, like one reason, that is the solvent effect. Like there is a large shift happening because of this solvent. So all the molecule will not show this. Molecule which will be able to do this particular, like the solvents can reorient around that. Also, the molecule should have a comparably good lifetime. If the molecule come back very faster, it will not get enough time for solvent relaxation. But solvent relaxation process, that process happens in picosecond time scale. So before the nanosecond fluorescence happens, this process would have happened. So that's why you are getting the emission from the almost like very much redshifted state, relaxed state. So this is one important aspect. It is known as solvatochromism. This has been widely studied by Lippert. There is Lippert equation, Lippert-Metaga equation for calculating the polarity experienced by the probe. So that is why I told you, if the probe is put it in ethanol, probe is put it in something like acetonitrile, it will behave differently. Behavior is different because of the solvent effect also. So that is the solvatochromism. So other than this one, hydrogen bonding, which will also make the molecule relaxes much, even charge shift, which will be happening in the molecule, conformational changes, probe interaction, these all processes will result in redshift of the emission. Now, this is what somebody asked me about the hydrogen bonding interaction. For example, this anilinonaphthalene in cyclohexane, we have taken that. It is showing this blue emission. Now, you add a little bit of ethanol to it, you can observe that there is a shift in the emission. And with 100% ethanol, almost like this different peak we are observing. So this is not a general solvent effect, which I have told you before, where the relaxation happens. It is not like that. This is especially because of the hydrogen bonding interaction between this nitrogen and the ethanol proton, or vice versa. That hydrogen bonding interaction is responsible for this effect, and that is why this is known as a specific solvent effect. Okay, the other one is known as the general solvent effect. The specific solvent effect is due to hydrogen bonding interaction. Now, the next topic is fluorescence quenching. So quenching means decrease in fluorescence intensity. That is, the intensity of that fluorescent molecule is decreased in the presence of another molecule. So there are several reasons why quenching is observed, like energy transfer, electron transfer, or some complex that are formed in the ground state, or various reasons are there. Widely, I can classify them in this way. There could be static quenching, collisional or dynamic quenching, chemical quenching, or concentration quenching. So collisional quenching and static quenching, we generally use this in protein molecule interaction. So collisional quenching is an excited state phenomena. That means the molecule goes to the excited state, and in the excited state, it meets the quencher molecule, any analyte molecule, let it be oxygen or any other molecule. It loses its fluorescence. That means it is not showing fluorescence because this energy is transferred to a quencher molecule. So this is by quinine sulfate quenching by chloride, tryptophan quenching by iodide. They all show this dynamic quenching or the collisional quenching property. It happens in the excited state. In static quenching, what happens? The fluorophore forms a complex in the ground state itself. Before getting excited itself, it forms a complex. And once it forms a complex, with the radiation coming, it will not be able to absorb. So it doesn't go to the excited state. Since it doesn't go to the excited state, there are no fluorescence. So without quencher, it shows fluorescence, excitation, and fluorescence. With quencher, it should not show the excitation and fluorescence. So caffeine, xanthine, and purine, they reduces the intensity of this riboflavin by the static mechanism. Now, mostly they follow an equation known as Stern-Volmer equation, where F naught by F is plotted against quencher concentration. Intercept will be 1 and slope will be K. K is nothing but KQ tau naught. So F naught is the fluorescence intensity in the absence of any quencher molecule, maximum intensity. F is in the presence of quencher. So this ratio is directly proportional to the quencher concentration. So when you plot a plot, you will be getting a straight line. So this type of lines you will get. Now, how do you identify whether the quenching, okay, you got a decrease in intensity, but we don't know whether it is static or dynamic. To understand that, we can do a temperature dependent experiment. So when the temperature increases, dynamic quenching increases, because in the excited state, when the temperature increases, more collision results. More collision means more interaction with the fluorophore and quencher. So the quenching increases, so slope also will be increasing. But in static quenching, temperature when you increase, the complex which is formed get broken down. When the complex is broken down, your fluorophore is free. When fluorophore is free, it will fluoresce. That means the quenching decreases, and higher temperature you get a low quenching. So that is the first experiment we do to confirm whether it is static quenching or dynamic quenching. And another is fluorescence lifetime. I told you dynamic quenching is excited state phenomena, static quenching is ground state phenomena. So ground state phenomena is unaffected by lifetime. Lifetime will be same. But in the dynamic quenching, if it is there, there will be a change in lifetime. That is another second experiment which we do to understand what type of quenching is there. Also, you can get a little bit idea from the absorbance measurement also. Sometimes in proteins and all, you must have seen combined static and dynamic quenching will be observed. So you will be getting a not a linear relation. You will be getting something like that, upward curvature. So that also shows there is a possibility of two types of quenching that is happening. Now, I would like to just tell you two examples. This particular probe, Hoesch 33258, this is readily quenched by iodide. That means in the presence of iodide, it will not show any fluorescence. But this molecule, when it interacts with DNA, what happens? It is an intercalator. From the size also you can understand. It intercalates inside the DNA pair and DNA double helix. So what happens is that it is protected. So when iodide ions are added, iodide ions are not able to distinguish that. So there is no quenching happens. So when HOIST is alone in a solution, it is quenched by iodide. But when it is interacted with DNA, it is not quenched by iodine. So from this experiment, we can understand what type of interaction this molecule has with DNA, whether it is an intercalator or a groove binder or electrostatic interaction is happening. One of the experiment which you can do is this iodine experiment. There are several experiments, but one of this is this. And in another example, you see this is a protein. This particular, sorry, this is a protein, you can say that receptor protein for cyclic adenosine monophosphate. So this is receptor protein. This is the area where our molecule binds. And this protein has two tryptophan. One is here in the periphery, one is embedded inside. So when the protein is having in this secondary and tertiary structure, this is inside. It is unaffected by any quencher. But this is free. So this is easily quenched by acrylamide. So that is shown like that. In the absence of this particular molecule, this protein's tryptophan shows this type of a trend. But when this molecule binds to this cavity, it is a receptor, right? A cavity, the protein conformation changes. The conformation, when it changes, this will become exposed. That means both the tryptophan molecule are now exposed to acrylamide. So acrylamide can attack both of this tryptophan, which will show more quenching, and the line shows like that. This is in the presence of this C map when it is added to this molecule. So you can understand the change in the secondary structure of this protein on addition of this molecule by understanding its fluorescence or the quenching property by using acrylamide. So these are some simple experiments to understand how fluorescence can be used for the studying of these interactions. Now, in one of our paper, we also have done in this similar way. We worked on rosiglitazone drug. This rosiglitazone drug is a anti-diabetic drug. And this drug has got a lot of controversy because it was many times removed from the market because of the side effects. Actually, there is a problem in diabetic patients known as microalbuminuria. That means albumin will be present in the urine in more than specified amount. So those patients who were exhibiting microalbuminuria, they were not showing that when they were taking this rosiglitazone drug. But there was other side effects which were observed. So there was one more report that in the presence of an antihypertensive drug, this molecule will not exhibit such a problem. So we wanted to study that. We individually studied the serum albumin rosiglitazone interaction, serum albumin valsartan interaction. What we observed by using the CV, circular dichroism also, there is appreciable change in the BSA structure. We did DLS, this is the temperature dependent study. We observed that the stoichiometry of the complex is changing. That means there is a more probability of the interaction of the drug with BSA. We did DLS also. DLS, the size of the BSA was found to be increased. We did docking study also. From these studies, what we have understood is that rosiglitazone, little bit higher concentration, causes the oligomerization of BSA. So BSA molecules will become bit higher. So they will not be coming into the glomerular filtration. That means albumin will be retained. So that is why in the urine, albumin was not observed. It was observed that rosiglitazone was able to treat. But in the presence of valsartan, this oligomerization was not happening. So this type of understanding is possible with fluorescence, how the interaction is happening. Now, this is one of the important, I think I have only 10 minutes, so I'll go a little bit fast. This is inner filter effect, the concentration quenching. That means, absorbance also many of you must have done. You always use the concentration, the micromolar. Higher concentration means higher absorbance. That means actually absorbance means what? After transmittance, you are actually measuring the transmitted light. If there is a heavy absorption, that means the transmittance you are not measuring with high accuracy. So for absorbance also, we use a dilute solution. We're supposed to use a dilute solution. In the same way, fluorescence also, we should use a dilute solution, because after a particular concentration, the fluorescence intensity decreases or you get a distorted spectra. There is concentration, linearity is there only up to a particular concentration. So the thumb's rule is that always measure absorbance. Make sure that absorbance is not above 0.5, then only you should do fluorescence. Okay, otherwise it will cause the problems of inner filter effect. What happens here is that, okay, light comes. If all the absorption happens here, the light is not even coming to the middle of the cuvette where we are observing. The detector observes this window only, this blue window only, detector observes. So since the light absorption is so strong because of the high concentration, light doesn't enter here, we won't be able to get the signal. So we, whatever, with respect to concentration we are measuring fluorescence, that will be an error. For example, here you see, in this case, the source is here, light is passing properly. Here also it is okay. But in this case, highly concentrated solution, all the light is absorbed here. So middle, you are not able to see any light or fluorescence or anything. So this can be a problem. So always make sure concentration is less. Actually, nowadays, inner filter effect is used for understanding certain mechanism also. For example, in one of our work, we have used a chromium sensor. And we use that carbon dots for the imaging applications also. Though the carbon dots are highly fluorescent and they show a very good fluorescence quenching with chromium. So in order to understand the mechanism is that chromium has an absorption spectrum which overlaps with the excitation and emission spectrum of the fluorophore, that is a carbon dot. That means it takes up some of the excitation light, some of the emission light, thereby the quenching happens. So inner filter effect, this particular inner filter is known as a secondary inner filter effect. The one which I explained due to the concentration is the primary inner filter effect. But you may think that when you search in the literature, inner filter effect, some people would have used for explaining the mechanism. But inner filter effect is a problem also in fluorescence. So you need to understand primary inner filter effect is mainly because of the concentration, higher concentration problem. And this is mainly because the absorption spectrum overlaps with the excitation and emission spectrum, thereby the energy is lost. That's the reason for the quenching. So I will come to the chemical quenching. So as I already told you, sometimes like iodides, heavy metals, oxygen and all can cause quenching. That is mainly because of the spin orbit coupling mechanism, whereby some has gone to the triplet state and it loses the fluorescence. Now, FRET is one phenomena where imagine you have a fluorescent molecule where a donor or acceptor is there, or you have two molecules. One is acting as a donor, other is acting as an acceptor. So when there is an overlap of the donor emission spectrum and acceptor absorbance spectrum, that means the acceptor absorbs some of the emission of the donor. So donor emission, we are expecting here, but we are getting it less because that much energy is lost by the acceptor. So this also is termed as one of the important means in order to explain certain mechanism, they use the FRET. But here there are certain conditions. The distance between the donor and acceptor is important. The overlap of how much overlap is there between the donor and absorbance acceptor is also important. This is completely excited state phenomena, this FRET. Now, excimer formation like excited dimer. Now, we know that pyrene, they cannot form a dimer in the ground state, but pyrene shows a dimer formation in the excited state. So if pyrene is like monomer, it will show this monomer emission. But when pyrene forms a dimer because of the interaction between the pi electron cloud, it will form an excimer band, which is highly red shifted. So this type of formation of the excited, generally pyrene, anthracene, this type of molecule only shows this property. So as you can see that in the ground state, they are not able to form a dimer molecule. But in the excited state, the two molecules come together and forms a molecule over here. So this results in the excimer formation. And there are various reasons why the excimer is forming. So this will show two different bands, the structured band of the monomer and non-structured band of the excimer. Same way, Xi plus also can be formed. Xi plus is like, example is like anthracene and dimethyl Xi plus. So it will form a complex and a new band will appear in the longer wavelength side. This is because of the formation of the Xi plus. So anthracene band is here, but when anthracene forms an Xi plus, with that a new band is generated. Now, there is a process known as internal charge transfer. So charge transfer maybe I can explain you with an example. Electron donating and electron accepting group should be there. In that case, what happens is that there will be a pull of the electron density towards the electron accepting group, thereby a new band will be formed. For example, in this particular molecule, we can see in hexane only one band, but in acetonitrile, you will be getting a two band. So acetonitrile helps in the formation of a different molecule because of the intramolecular energy transfer that is happening in this particular molecule. So I'll leave this to step one. So we have done an experiment with this particular molecule. This is a pyridyl thiazole molecule. This particular molecule has a pyridyl moiety. On protonation, what happens to the molecule is that on protonation, it behaves like a highly electron withdrawing group and withdraws the electron density towards this side. That means a charge transfer that is happening here, which is result in a charge transfer band. Normally, the molecule exhibits a peak here, but under acidic condition, it shows a new band. So this band, new band is observed, and this is also observed in case of sodium dordacyl sulfate surfactant. So we use this for understanding the sensing of different amino acids. What we have observed is that except aspartic and glutamic, no other amino acid was sensing this particular can be used for sensing of that that molecule cannot be used for any other amino acid except aspartic and glutamic, because aspartic and glutamic have an isoelectric point of 2.98 to 3.08. So the H+ ion released from acrylic acid protonate our molecule and causes electron withdrawing effect, thereby a charge transfer band is formed. So this type of experiments we can very nicely do with understanding of fluorescence. Now I'll firstly go to the instrumentation. Here, only one thing I would like to tell you, the position of your detector. So this is xenon lamp. Xenon arc lamp is generally used as a source. There are two monochromata, excitation monochromata for selection of excitation wavelength, emission monochromata for selection of emission wavelength. There is a detector and readout device. Now, you must have understood that it is a 90-degree geometry. We are not keeping a 180-degree geometry. The detector is not here. Why we are not keeping the detector here? Because if we keep the detector here, the excitation light will come, transmitted light will come, fluorescence also will come. So it's a mixture of many light. But when you keep the detector here, transmitted light will not come. It will pass like this. Excitation light also will pass because they are monochromatic in nature. But fluorescence is in all direction. I can keep the detector anywhere around the cuvette to get the fluorescence. It's in all direction. But I prefer to keep at 90 degree because there were several reports that 90 degrees found to be the best geometry. It can completely eliminate the transmitted light and the excited light. So ideal spectrofluorometer should have the very good light source. Light source, what happens? It should give constant photon output. Now, xenon lamp after maybe 400 hours or 800 hours, performance will decrease because it will not provide constant output. So our results also may vary. So that time when you are not getting the result, you should understand whether my xenon lamp is working properly or not with the reference samples. And monochromator also should pass all the photons with equal efficiency. And photomultiplier tube, which is the detector, also should select the photons of all wavelengths with equal efficiency. Now I'm going to talk about the common errors in sample preparation. Some already I have explained you, for example, concentration. So concentration, you have to make sure that not very high. It should be optimum for a good fluorescence spectrum you need to get. Other problems are impurity. For example, this is the red one is the impurity. Now, if the fluorophore is contaminated with that impurity, you get this type of a spectrum. But you don't know whether the solvent is or there is an impurity present in that. You will try to interpret this spectrum. That will be wrong because this is due to the impurity. So impurity concentration may be very, very less. Maybe in the bottle 99.5% purity you have observed. Still impurity will be there because fluorescence, as I told you, nanomolar concentration is also enough to show fluorescence. So if impurity present in nanomolar concentration also will give some signal. So that is one drawback. Not drawback, it would be some cases it is a saving point also because impurity which we cannot detect in NMR and all can be detected by fluorescence. Now another problem with fluorescence is the Rayleigh scattering and Raman scattering. Rayleigh scattering is an elastic scattering. Wherever you are exciting, there itself you will get an emission. That means this type, imagine you are exciting, you get a strong signal here. Many papers, research papers also reported such Rayleigh scattering as fluorescence, but they are not fluorescence. For that only, I have told you, fluorescence will be always redshifted. You have to always remember where you are exciting. Imagine you are exciting at 350. You will never get 350 emission. If you are getting at 350, it is due to scattering, Rayleigh elastic scattering. Now, sometimes Raman scattering also will be observed. Raman scattering will not be at the time point of excitation, maybe plus 40 nanometer or something. Why Raman scattering is happening? Because, see, Rayleigh scattering, why it is happening? When light comes, light briefly polarizes the molecule. So there is a dipole created. That dipole will interact with the incoming light and instantaneously they emit. That is why they are happening at the same wavelength. But in Raman scatter, that will interact with some vibrational levels of the molecule, especially water is a solvent. So always 350, if you're exciting 390, you will get a small peak. That is not fluorescence, that is Raman peak. To understand if it is Raman or not, it is easy. What you need to do, just follow the Kasha's rule. You excite a different wavelength. If your Raman is shifting with excitation wavelength, it means that it is a Raman peak. Because I told you as the excitation wavelength changes, emission will never change, emission wavelength. That will be constant. If it is constant, it is fluorescence. If it is shifting with respect to excitation wavelength, it is Raman. For example, I did 350, 360, 370, 380. So 390, 400, 410, 420, if I'm getting like that, it is Raman, otherwise it is not. Now, imagine in fluorescence, particles should not be there. You should filter it completely because if it is not filtered, the noise and other things will come and it will give you a negative result. So that is to be very carefully understand. So this is the water Raman peak, which I have told you. It will happen mostly in water plus 40 nanometer, it will happen. Now you see the impurity one, which I was telling you, actually there's coumarin. Coumarin 102 molecule shows a very good spectrum like this. But when there is coumarin 153 also is present, you get coumarin 153 small impurity present, you get another peak. So overall your peak will look like this red. Now you start interpreting this as coumarin 102, everything will go wrong. So need to understand this case, what you need to do, keep on exciting at different wavelength and check the emission spectra, which will give you an information about whether your compound is pure or not pure. So there are various factors which will affect concentration is important, temperature, pH, inner filter effect, quenching, all these parameters you need to understand when you are going for fluorescence related studies. So I don't think so I'll have much time here. Maybe you can ask questions. So we, yeah, one second, I will explain you this practical courses. So there are certain practical courses which you can undertake if you are interested, like riboflavin. Riboflavin vitamin C, it is present. So many of you will be taking that riboflavin multivitamin tablets and all, it is present. So you can make sure the student, if you have a spectrophlorimeter, student can understand how to take an excitation spectrum, emission spectrum, how to calculate quantum yield, how to develop a calibration curve. In analytical chemistry, we teach standard addition method, external standard method and all. So by doing that, you can develop a calibration curve, or riboflavin content in a tablet. We can measure by using a real sample, we can do that. Now, quinine sulfate, that is also, these riboflavin quinine sulfate are very cheap chemicals, means you can buy it for laboratory purposes also. The quenching phenomena you can understand very well by iodide experiment and understanding the Stern-Walmer plot, etc. Third practical, which I would suggest, is the interaction of small molecule with serum albumin and DNA. Even the bovine serum albumin is very cheap compared to the human serum albumin. You can buy that, and bovine serum albumin, understanding of the interaction, we can study binding constant, binding number, and even autodoc also. Some college, means universities will have autodoc program to understand the binding of molecule with the albumin. Now, there are some sensing experiment also you can plan, like metal ion, especially heavy metal ion sensing, anions, fluoride and all sensing, very important, biomolecules, some biomarkers, explosive, etc. Also, you can understand the effect of organized media. For example, fluorescence can be used for determining the CMC, critical micellar concentration of this SDS, CTAB and things like that. So those experiments can be incorporated. Now there is something like polarity viscosity probe. Like for example, you put the same probe in different solvents, you get different emission. That's the polarity probe. You put the probe in ethanol and glycerol. In glycerol, you will get more viscosity, different result. That can be a viscosity probe. So these type of practical courses, if you wish to do, you can do. Now, there is only 5 more minutes remaining, so I thought I should give some time for the question answer. So finally, I would like to acknowledge UGC Malavia Mission Teaching Training Center of Amravati University for giving me this opportunity for presenting this talk. Also, I'm very grateful to Professor Manisha Kodape, my friend, for inviting me for this program. I'm thankful to Department of Chemistry, Savitribai Phule Pune University for providing the necessary arrangements, instruments, etc. My PhD students for helping me for the work. Some of the work I could not show, and participants of the refresher course for interacting. And thank you so much. So now you can ask me if you have any questions.
Thank you, ma'am.
Thank you, ma'am. Thank you so much.
Yeah, ma'am. Thank you, ma'am.
Audible, ma'am? May I audible?
Yes, tell me, please.
We will take the one by one question. Yes, Dr. First, Dr. Rohan sir, please.
Yes. Ma'am, I just wanted to ask, suppose I am preparing the carbon quantum dots, which are showing the fluorescence. So
Yes.
what is the steps or procedure to calculate its quantum yield?
See, first you have to take the absorbance and you have to take the fluorescence. Now you will understand where the excitation wavelength is, where the emission wavelength is. Then you go to any reference book, for example, Lakovich, Joseph Lakovich or Parker, and identify a standard molecule. For example, if your emission is something like, excitation is at 360 or something, better reference is quinine sulfate. Take quinine sulfate because both should have almost similar excitation wavelength. That means 360 pe both should excite and both should give the emission. Some emission should be there. 1 second now. Okay, so you will select the quinine sulfate as the probe. And after that, 2 things you have to do. First, you have to match the absorbance value. Absorbance value of your molecule as well as the quinine sulfate, make it to 0.1. Okay, so dono ka absorbance is 0.1. Then you take the fluorescence for both. So you get the intensity for both. Surely both will be different. And the intensity, you can either put it in the equation or the area under the curve of the fluorescence spectrum. You can use it in the equation and calculate it. So first you have to select the suitable standard, and mostly the solvent also should be same. If quinine sulfate is in 0.1 molar sulfuric acid, your carbon dot also should be in 0.1 molar sulfuric acid. If it is not possible, you have to involve the solvent parameter also, correction factor also. If absorbance you are not able to keep exactly 0.1, that parameter also you have to include that in that equation. So selection of that particular probe is important. Then matching the absorbance is important. Finally, area under the curve or the fluorescence intensity, you have to put it in that equation. Okay.
Ma'am, yes, ma'am. But actually, ma'am, we don't know the concentration of carbon quantum dots what we have prepared. So how to take its 0.1 molar solution or something concentration?
No. 0.1 molar I did not tell. 0.1 should be the absorbance. So okay, that you can say sometimes what happens, you prepare the carbon quantum dots and lyophilize it. You know what is lyophilization? You remove the solvent. So you get the solid powder. Then solid powder, you take 1 mg, dissolve it in 10 ml. So you get the concentration of 1 mg per ml. Yes. Okay. Like that you can do. Otherwise, you just trial and error. You make the absorbance to 0.1.
Okay.
Just do dilution and make it to 0.1.
Okay. Thank you, ma'am. Thank you.
Yeah.
Good morning, ma'am.
Yes,
ma'am, I just want to know about the bioimaging one. Just give brief information.
Yeah. See, bioimaging, nowadays, bioimaging is extremely, see some slides I did not show. In bioimaging, now, there are certain probes which can be selective for nucleus or selective for mitochondria. For example, I told you cationic probes will be accumulating in the mitochondria because of the negative membrane potential of mitochondria. So when it is accumulated in the mitochondria, you can understand several processes that is happening in the mitochondria, or if it is in the nucleus, you can understand several processes, especially the DNA related processes, which are very important for various disease diagnosis and other understanding that, tracking them the early stage and all. So you can do that. So fluorescent molecule, whatever we are using for bioimaging, the first condition is that it should be non-cytotoxic. So first experiment we should do is check the toxicity of that in the normal cell lines. So if it is found to be non-toxic, you can do either live cell imaging or the controlled imaging. In that, you will inject this and you will put this particular sample and you can see under the microscope. So the best fluorescence microscopes are there, but confocal microscopes will give a better idea about this. For example, in this you see, this is so I need to tell you this. See, this is a cancer. Imagine a cancer cell membrane. There are several folate receptors which will be present in that. This maximum folate receptor means it is more, means it is like, you can say that they will be overexpressed. Folate receptors are overexpressed in cancer. Normal cells, such folate receptors will not be present, but in the cancer cells, some folate receptors will be present. So what this particular group, this is not my work, one research group has done, they have attached folic acid with carbon dot. So it becomes fluorescent in nature. Now this folate receptor, this folate carbon dot can easily internalize into the cell. It can go inside the cell because there are folate receptor. So it goes in the cell. Only if folate receptors are there, then only this carbon dot will go inside the cell. If folate receptors are not there, it will not go inside the cell. So if folate receptors are there, means there will be more fluorescence. If folate receptors are not there, they will not go, and internally you can not see. So this is what given in this imaging picture. This is only with folic acid. Sorry, this is only with normal cell line with Fa. This is the Fa C and G. This is the Fa with carbon dots. So Fa carbon dot is able to go inside the cell because only the cancer cell lines have folate receptor. We have folic acid plus carbon dot. That is why internalization has happened. So from there, what we can understand, okay, this particular cell line has a lot of folate receptor. It will be carcinogenic in nature. Same way, see cancer tracking nowadays during the operation, surgical removal of cancer and all, the cancerous parts will be fluorescent in nature because there is oxygen deficiency, pH also different. So because of that, the cancer cell will be highly fluorescent. So for the surgeon, it will be easy to remove that. Micro scale, what to tell, accuracy is there for the removal of the cancer. This is also an imaging type of applications.
Good afternoon, ma'am.
I have a question, ma'am.
It was a wonderful lecture, ma'am.
Sir, please, I think we should take from Dr. Thakur, madam. Yes, Dr. Yamini, madam, please.
Madam has already explained. Bioimaging was my question. Thank you, ma'am, so much.
Yeah. So now, yes, Dr. Pradeep Das, sir, please.
Good morning, ma'am.
Yeah. Yes.
Thanks for your nice presentation. So I have some queries because I am not a fluorescence spectroscopy guy, but still my colleague is working there. So some molecules exhibit fluorescence, but if they have a similar structure, but some of them they are not showing the fluorescence. Why is that? And the second question is, what is the significance of the Stokes shift in fluorescence spectroscopy?
Yeah, see, first of all molecules are not fluorescent, I told you, especially terephthalic acid, you see. Terephthalic acid with amino group, amino terephthalic acid is highly fluorescent. So that depends on more electron donation by amino group. Amino group is an electron donating group. It donates electrons. So because of that, and there is also carboxylic group which will be electron withdrawing. So because of that, it favors for the conjugation, and homolumo level get adjusted. Molecule is getting modified. That is the reason that molecule is fluorescent. For example, I also told you about naphthalene and anthracene. As the extent of conjugation increases, there is a fluorescence property that is increasing. So depends on the structure of the molecule. Even you can see phenolphthalein and fluorescein. The phenolphthalein is not fluorescent in nature. It is a very good dimolecule, but it is not indicator. It is not fluorescent in nature because rigidity of the structure is not there, even though it is a chromophore and it has conjugation, but then rigidity of the structure. Rigidity plays an important role. The substituent also plays an important role. And your second question, Stokes shift. See,
Yes.
Stokes shift, as I told you, if the molecule goes to the excited state and if there is a large change in the dipole moment, solvent will orient themselves around it and causes a large Stokes shift. So to understand if there is a role in the solvent, many cases, solvent role, understanding solvent role is important. Which solvent to be used for the experiment, which solvent gives more redshift. For example, I want, in this case, you see green color we have observed. Sometimes we want red color emission. So if I use butanol as a solvent, maybe red emission I'll be able to see. Sometimes I'm focusing only on blue emission. So cyclohexane can be used as a solvent. So this understanding and all I will be getting from the Stokes shift. So the more the Stokes shift, more that molecule is showing higher dipole moment in the excited state. That type of conclusion we can draw.
Okay. Thank you, ma'am. Thank you very much.
Yes, Dr. Abhishek, sir.
Thank you, ma'am, for this wonderful presentation on fluorescence spectroscopy. So just a request, so it is be kind of you, please, if you share the PPT with the organizers so they can share with the participants.
Yeah, I'll surely do that, and you can note down my mail ID also in case of any query related to your experiments or you want to do more for fluorescence. You can anytime approach me. I will be happy to help you.
Thank you, ma'am.
Dr. Manji, madam, last question, please.
Yeah, ma'am. Thank you, madam. Thank you, madam, for very nice presentation. My question related solvatochromism effect. Okay, how solvatochromic dye differentiate between polar and non-polar, that is a hydrophobic or hydrophilic environment in fluorescence spectra?
Okay. See, as I told you, pyrene cannot be a solvatochromic probe because pyrene or any other nonpolar molecule, highly nonpolar, will not be exhibiting such a big change in dipole moment when you go to the excited state. See, all molecules exhibit a change in dipole moment. You understand by dipole moment, there is a charge separation. So electron is getting changed from its position. There is a charge separation, but all molecule will not have extensive dipole moment change. Some molecule shows a very big change because of their inherent property. They may not be non-polar in nature, slightly polar. So when it goes to the excited state, there is a huge charge separation, huge change in the dipole moment happens. Now, if huge change happens or not, it depends on the solvent also. If you have a very good polar solvents will be more favoring the polar molecules now because polar likes polar, non-polar likes non-polar. We have studied about that. So the polar solvent molecule will orient very nicely around the probe molecule. Because of that nice arrangement, energy decreases because of the stabilization. So more polar the solvent is, more stabilization will happen, more redshift will be happening. So in that slide, I have just showed you that in butanol, it gets extremely redshift of about 200 nanometers Stokes shift. But in case of cyclohexane, you are not getting anything. So it based on probe solubility also, probe's dipole moment also, and depends on the polarity of the solvent also, this solvatochromism can be changed. Some probes even show absorptions also solvatochromism. That means the ground state also, they are able to do that polarization. There are some molecule, highly polar molecule.
Okay, madam. Thank you.
Yes, Dr. Ishanki, ma'am, you can please take your question in brief and then we'll move for the next session. Yes, please.
Thank you, sir. Ma'am, I have a question that how low quantum yield molecules can be a problem in bioimaging? How it is a problem in bioimaging?
Yeah, you need to understand if it is the molecule is having low quantum yield, why. For example, sometimes the quantum yield will be less because of the oxygen. The molecule will interact very strongly with oxygen. So what happens? You have to purge the solution with nitrogen. Then you observe the fluorescence, maybe the fluorescence is enhanced. So, and sometimes even though the molecule is weakly fluorescent, on binding with biomolecules or going into a restricted medium, fluorescence enormously increases. So thereby you can convert weak to a strong. But even though with these conditions also, if the molecule is showing very weak fluorescence and with oxygen and with pH and all, there is no effect, then it may not be highly suitable for bioimaging application. But I feel that most of the molecules which have this problem with oxygen, we have generally come across with oxygen. So purging with nitrogen will help it to overcome that problem.
Okay.
So thank you, ma'am. Thank you so much. If you could permit, shall we conclude with the session, ma'am?
Yes. Thank you so much.
So thank you so much, ma'am. Now may I request Dr. Pradeep Das sir to please propose both of our current session, please.
Okay, sir. Okay, sir. Respected resource person, respected coordinator, and all esteemed faculty members. It's my privilege to propose the vote of thanks on this wonderful occasion on behalf of the refresher course in chemistry at Sant Gaja Baba Amravati University. I extend our heartfelt gratitude to our distinguished resource person for delivering such an enlightening and inspiring lecture on fluorescence spectroscopy. Your presentation provided us with a clear and comprehensive understanding on the fundamental principles of fluorescence, modern spectroscopic instrumentation, and its diverse application in chemistry. We particularly appreciated your lucid explanation of the photophysical mechanism underlying fluorescence and phosphorescence. Your discussion on the excitation of molecules from the ground state to an excited single state, followed by rapid radiative relaxation resulting in fluorescence. So equally enlightening was our explanation of how molecular structure of fluorophore, its interaction with the surrounding molecule and pK of the molecule influence its fluorescence properties, including shifts of the lambda max, and also discussion the mirror image rule and relationship between molecular structure and structural behavior mode of these complexes. So the particular examples and research perspectives you share have undoubtedly inspired all of us to explore these exciting interdisciplinary areas further. I'd also like to express my sincere gratitude to our respected coordinator for his constant encouragement, guidance, and dedicated efforts in organizing such enriching academic sessions that broaden our scientific outlook. My heartfelt appreciation goes to all faculty members and organizing committee also for their meticulous planning and tireless effort which ensure the smooth and successful conduct of today's lecture. We hope that today's lecture has motivated all of us to appreciate the immense potential of fluorescence spectroscopy and its transformative application in scientific research. So I once again express my sincere gratitude to everyone who contributed to the success of this program. Thank you for your valuable time and attention. Thank you, ma'am.
Thank you so much. We have very interactive, wonderful candidates here. I really enjoyed the session. Thank you so much.
Thank you so much, ma'am. Thank you so
Thank you,
much.
ma'am.
And with the kind consent of Professor Divya, ma'am, I would like to declare that this particular session will be over here and we will meet for the next session. Thank you so much, ma'am.
Thank you.
Yes, hello, Dr. Humne sir, Dr. Vivek sir. Dr. Vivek sir, whether we are audible to you? Hello, Dr. Vivek sir.
Sir?
Sir, whether we are audible to you, sir?
Yes.
Yeah. So, shall we start, sir?
May I one request?
Yes, sir.
Can I share my screen here?
Yeah, sir. You can please share, sir. So, now may I request Dr. Borkar, sir, Dr. Prashant Borkar.
Yes, sir.
Borkar, sir, please wait for 1 minute. We will take the consent from Dr. Professor Vivek, sir, and then we will start.
Sure, sir.
Yes, sir, it is shared.
Yeah.
So, shall we start, sir, if you could permit?
It's visible.
Yeah, sir. You can start your presentation. Now it is visible. So now, first of all, I extend my warm welcome to Dr. Vivek Humne sir on behalf of Malvi Mission Teacher Training Center, Sant Gadge Baba Amravati University, and all the participants, those who have gathered from the across country. So friends, in the next session, we're going to talk about the modern tools in the chemistry research with the help of one of our renowned and the scholarly expert, Dr. Vivek Humne sir. So first of all, I extend Dr. Borkar sir to please introduce our guest in brief, and then we will start with the session. So Dr. Prashant Borkar sir, please.
Okay. Thank you, sir. Good afternoon to all the respected dignitaries, esteemed participant, respected resource person, faculty members, and dear colleagues. It gives me immense pleasure to welcome you all for the today's live session of the UGC refresher course in chemistry, which focuses on highly relevant topic, that is modern tools for the chemistry research. It's my privilege to introduce our distinguished resource person, Dr. Vivek T. Humne sir, the assistant professor in the Department of Chemistry at Sri R.R. Lahoti Science College, Morshi. Dr. Humne has did his PhD from University of Pune and has impressive academic, industrial, and international research background. He has served as a national postdoctoral fellow at CSIR National Chemical Laboratory, Pune. He also has worked as a postdoctoral fellow at Uppsala University, Sweden, and also contributed as an research associate scientist at Life Science, Pune. He, his research interests include photoredox reactions, heterocyclic chemistry, carbazole natural products, and molecular docking. Dr. Humne has published over 34 research papers in the reputed international journals, holds 2 Indian patents, and authored 3 book chapters. He has also received prestigious major DST sub research project worth more than 26 lakhs. He has also been recognized with the post prestigious fellowship including DST Serve National Postdoctoral Research Fellowship and Erasmus Mendus Postdoctoral Fellowship. With his rich experience in academic research, industrial R&D, and modern synthetic chemistry, Dr. Humne is exceptionally well qualified to guide us through today's topic on the latest tool and techniques transforming the chemical research. On behalf of organizers, I extend a warm and heartful welcome to Dr. Vivek T. Humne sir. Sir, we are truly grateful that you have accepted the invitations and agreed to share your valuable knowledge with us. So, ladies and gentlemen, without taking much more of your valuable time, I request Dr. Humne sir to kindly take over the session and enlighten us on modern tools of chemistry for the research. Over to you, sir.
Sir, giving this wonderful introduction. Mine. So actually, basically, I'm working in organic chemistry, organic synthesis, and as introduction given by Prashant, my research area is redox reactions as well as the synthesis development of iodine copper mediated transformation and carbazole synthesis of carbazole natural product. But in this session, I'm trying to deliver my lecturer on some basic concept of research because it's okay that every person have its independent area of research, but uh, we must aware today we must aware from the modern tools which are generally used for the research, and in big universities like Pune, Mumbai universities, it is resources are very much available. But in small universities like Nagpur, Gondwana, and even though Amravati, such tools are not easily available for research. But I'm in this session, I'm trying to deliver my lecturer then how to use these tools such that we improve our research area. So in next 1.5 hours, we try to understand the significance of research, means why there is a need of good research, and then once you know you are the research area, then there is a need of our representation, how we represent our research at the globalization level. And for good research, we must aware for the some tools which are used for the writings. I know that we are from the background of ground level, and we are not very much aware from the good English language, but some tools are also available nowadays. Some tools are also available such that we can improve our grammatical English as well as the writing skill of research. And the most important thing is literature survey. I saw in many universities there is a lack of literature survey, and if you don't know about the literature survey, then your research will be going to in that step. So you must aware how much we do our literature survey. Some tools are also available such that we can do a literature survey by using these tools. And the most important thing is use of artificial intelligence. Nowadays, since last 2 years, artificial intelligence are one of the growing area in not our research, but in our daily life also. So we must aware about the artificial intelligence, and we have to use this AI in our research also. So I hope when you listen this presentation, at least you can write a good paper and you communicated this to a journal, and you will get a very nice impact factor for your research. Before that, before going to these tools, we must know what is meant by research. Then from these two figures, we can see that the research or is basically divided into two parts. One is the invention and another is the research. So what is mean by invention? Invention is nothing but is that the thing which is not previously being exist, and one person who can find out this thing and explore this thing beyond of this global, then this concept is called as the invention. Research is nothing but research is if anything is already exist in universe but nobody will know, then what is the use of this thing and how these things are work, then some person go through this thing and find out this thing and come find out this thing and place this thing in front of the world, and it give the application of this new thing, then this thing is called as the research. So we can say that invention is very much important. Invention is rarely happen, but research is mostly happen. We can say that. So research is nothing but research is made up of two words. One is the re and another is the search. Means again find, means one thing we again and again we find that, then this is called as the research. So it is very difficult to invent the new thing, but whatever we doing the our work at platform, so we can do the research thing. During the research thing, if you get a new thing which will be the very novel for this world, then you can say you invent this thing. So invention is always a good impact as compared to the research. So some quality should have. So here we find out, here we point out the some points for a good research. So in first point, we can say that a person going to step by step. So research is also like this. Means we suddenly think that we achieve a very good findings. So it is not possible. So we have to do at ground level. You have to do at very primary level. And if you doing this, you did some mistake, then you correct your mistake and go ahead. Means step by step, you can increase your skill. You can increase your research skill. So research is such that means uh, many universities, the faculties thought that suddenly I want the good impact factor papers. So I thinking that it is not possible. Because whatever you develop your area, you once you know the depth of your area, then you correct your depth, you correct your the knowledge, and once you getting the very good knowledge of your research, then I'm sure that you will get a good impact factor paper. So my suggestion is that don't we make that we suddenly we get a good impact factor paper. Try to write a paper which will be published in very low impact factor. And once you getting an confidence, then definitely you can upgrade your research area and you will get a good impact factor paper. So this is the step-by-step improvement of your work in research. Then second point is that Scientific method consists of systematic observation. Means whatever you develop your research, it should be systematic. It should be classified, and whatever you have data, it should be interpreted very nicely. It should not be manipulated. One important thing is that it should not be manipulated. Whatever you get data, properly you understand this, you correlate your data with the previous citations and try to find out the reasons why you get such type of data. If you find out such type of thing, then definitely, even though you get the negative results, then you will explore your research in very good manner. So second point is that the scientific, whatever you have data, whatever you have method, it should be properly interpreted. Third point here, I can say that acceptable scientific methodology to be solve problems means whatever you have developed your research, it should be the replicates. Means here I'm trying to say that in many universities, I heard last year in from IIT Dhanbad, I'm not properly say that this is maybe IIT Dhanbad, 4 to 5 papers are retract. So why this happen? So why this happen? Maybe this happened due to this is a manipulated paper, or maybe this paper is not replicated. So whatever you developed your research, it should be replicated, not by you, by others also, such that if such type of thing is repeated continuously, then what happen? Your citation will be increased. Research is not a meaning of only published papers. Research is the meaning, research is the platform where you do the work properly. Once you generate your work, you should get a good citations. We generally we say that the person having the 10,000 citations, 5,000 citations, 1,000 citations. So what is the meaning of this? Means this concept, whatever you develop your research, is acceptable at globalization level. So try to, means once you develop your concept, try to duplicate this. Try 2 to 3 times. I'm the organic chemist. So whatever I develop my method, I try to replicate my organic method, organic procedure 2 to 3 times, such that we get the around same type of yield, around same type of reaction time, such that reaction is completed. So C point, this replication point is very important for our research. The next point is that it should create new knowledge that is generally applicable. So I mean that don't do traditional research. Upgrade yourself according to the new research. Yeah, I'm agree that maybe your whatever with your background is traditional research. Your background belongs to the traditional research, but try to do your research according to the upgradation. Now, what happened today? What going on today? Think like this. It's such that the new things is happen, new knowledge is explored by you in front of the world. So this is important. So try to create a new knowledge which should be applicable. Next point is that your research should be socially important. This is important that many persons are working in material chemistry, and I'm saying that many persons are working in organic synthesis, but this organic synthesis not used in socially purpose. Only many people are doing research, and this research published paper, and these papers are kept in his bag. So this is not an important thing for socially purpose. Whatever you're doing in material science, in organic science, or organic chemistry, whatever it be, try to do your research, try to develop your research such that it can be used for the socially purpose. I'm the organic chemist, so my aim is that I'm synthesize some compounds and I'm doing the activity. And obviously, for development of what drug, it need 20 to 25 years. But we cannot do like this. But at least we do one basic level research such that I can do in vitro, in vivo study, and we doing patented, and just like till the patent you stop here and some person will come, you saw your he will see your research and continue your research. So this is the important, so such that the social impact of your research will be increases such that, okay, step by step. And the last point of this is whatever you doing, it should be patented. What I'm saying patented, if your research is new, so don't be think about the publications, think about the patent, because in many industries, in many other country, they refer the patent. Industries are always refer the patent. If if they saw there's some new concept in your patent, they can carry out your research in that industry also. So this is very important thing, that whatever you did, whatever you will do, it should be patented. Nowadays, I think many third parties are available who can do the patent of your research. So you can contact him and you can patent your research, and then you can publish your research in good articles. So these are the important thing. Our research is basically divided into the two type. One is the fundamental research and another is the applied research. So fundamental research is basically based on the theories. It is basically based on the hypothesis, means such that previously in a traditional way, the hypothesis that you heard that you listen that the hypothesis that Earth is middle of the universe and everywhere means every satellite is revolve around the Earth. It was the hypothesis. But when exactly experiment was done, when exactly observation was done, then it clear that not Earth, Sun is the center of the universe, and every satellite is moving around the Sun. So this is the hypothesis. So maybe our hypothesis uh, will be the wrong, it will be the incorrect, but it will give some direction to the research. Means it will give some direction to the research that we can think on this way also. So this is the fundamental research. Basically, in chemistry, we doesn't do the fundamental research. We're doing the applied research. Fundamental research is done by the mathematical person, physics person, the physical person, this physics person generally doing the fundamental research. Always we going to the applied research. So what I mean by applied research? I'm very happy that I'm doing a research in chemistry, because making of molecule or developing of concept is not an easy, it is not an easy way. Every molecule have its own property and it's not a simple way. These molecules is developed by us. We are the chemist, and we should be proud for this. So we're doing on the applied research. Applied research means nothing but the research which is done by some practically, or the research which have the basic of fundamental research. Fundamental research have some basic, and on the basis of this, we develop for practical way, and then practically we prove that this thing is happen. So this thing is nothing but the applied research. We know that in COVID-19, you know that the Poonawalla was there, and in their company Poonawalla, they made the COVID-19 vaccine. So This is the very important. This belongs to the applied research. If he was not there, then we can't do anything. Without vaccine, we can't live, we can't go anywhere. So this applied research is very much important. So try to think that how we can develop our research towards the applied chemistry. So these are some points through which we can make a good research. This is the one of the general point. Many of person belongs to the good universities here. So even though, but some persons belongs to the college level or some universities where the facilities are not available. So I'm saying that you decide your problems, you decide your area of research. Area of research is decided by what you have done. Huge area of chemistry is there. So try to pick one small area and decide that I have to work in there. Once you decide your problem, do the literature survey. We will see some tools are available which will be used for the literature survey. Literature survey is very important. From the basic to advanced, you have to do the literature survey. Because literature survey study shows the gap of your research. Means what are the gaps are present in your research. This will be shown by the literature survey. And once you know the gap of this problem, then this is called as the origin of problems. How these problems are created, why these problems are created, this is called as the origin of problems. Once you decide I have to work on this problem, then you decide your objective. Objective means what type of research you will do, how you will do. This is called as the objective of your research. Such that I am saying that objective of research is my area is mostly iodine mediated transformation, copper mediated transformation, photoredox reaction. So when I saw any drug, when I saw any natural product, so I think that how this will be prepared from my methodology, because these things are set in my laboratory, and I think that how these things are made by using the inexpensive catalysis. So this will be the objective of research. Then methodology, what procedure you will use. This is called as the methodology of research. Every person have the different methodology. Somebody use depending on your area of research, you can generate your methodology of the research. It should be reliable, it should be non-expensive. Then such type of methodology is always beneficial for research. After the methodology of research, you will get some data, and these data should be interpreted properly in terms of numbers, in terms of graph, in terms of figures. You can show your research, you can interpret your research properly. And after this, overall of all these 6 points comes to the conclusion. The conclusion should be very precisely. It should be says exactly what you have to say. So this is called as the research. So these are the 7 points. On the basis of these 7 points, you can make your research very good in very well manner. So once you go through the research, then point came that how we represent our research. So representation is the important. So I think that representations are mainly depends on the 3 to 4 category. One is the published papers. This is published papers means whatever you have to publish your papers. Another is the patent, and then is the review. Okay, so here we just discuss in very shortly So papers, articles are basically based on the three category. One is the communication, another is the letter, and another is the full article. Here we can distinguish what is meant by short communication. Short communication is nothing but it is a very brief and novel early results which you want, and the length and figure of this this thing is very important. It should be published very fast. Okay. So go to the rapid communication. In rapid communication, obviously it need data, it need characterization, but it should be very fast. The rapid communication should be very novel, which is not did earlier. Then short communication, sorry, short notes. Short notes is also part of the communication. Also part of communication. These short notes consist of very concise observation. It consists of preliminary data and have there some technical corrections. This is called as the short notes. It is somewhat little bit more detailed study of the communication. Then brief communication. Brief communication is always based on your methodology. Whatever you have developed your methodology, you can concise your methodology and you can publish in terms of the brief communication. And the later, we know that many journals are know that today synthetic, synlate, tetrahedron letter, synthetic, synthetic communication. So these are what? These are the part of the letter. So letter is always based on the communicate to journal, and the way of working of this letter is exactly similar to the communication era. So here I publish some article like organic and biomolecular chemistry in as an communication, and a journal of organic chemistry as a note. So this JOC is only for 2 pages, but this concept is very much important. That's why they accept it. The tetrahedron letter, I also published some tetrahedron letter. The urgency of this uh, article is that it has some part of the novel research. That's why they consider this as a communication. Okay, basically this communication or letter is only for 3 to 4 pages. They have some limitations, words limitations. So keep in mind that when you develop your research, you decide what you have to do, whether you have to do communication, then go to the author's instruction and try to write according to them. Then next is the article. So article or the original research article or full length research article. These are the complete detailed study of your research. Whatever you have developed should have very details. It consists of comprehensive discussion. Either it is negative discussion or positive discussion. It consists of the interpretation of the data, investigation, whatever you did, you go through the proper investigation. Then you can communicate your research as an full paper or article. So these three is a complete based on your comprehensive knowledge of research. So it doesn't have the words limit. This paper doesn't have the words limit. Then the fourth point is the literature review. So literature review is an important part. In many coursework, we suggest that do the literature review. So this literature review is a part of your research. Whatever you have done, whatever you will do, Before that, you do the literature review. So I'm suggesting that if you have a good amount of, if you have a good population of papers around, in, for example, if you choose one good concept, and for good concept during your PhD or during your research, you collect all these references around 200, 300. So, and you read that and properly arrange your literature, classified your literature, and you can publish your research as a literature review. Then, as we discussed earlier, patent is an important. Before publishing your article, try to patent your research, because it is important thing. What I'm saying that patent is important. If you patented your research, then it comes on the commercialized platform. Some company refer your patent, and this company think that your research have some good potential, then they refer your patent. And maybe if your patent have some good methodology, and they can contact to you and they can try to purchase this methodology from your side. So this is important then. So, and many third parties are available today. Many third parties are available, so they can patented your research. Try to reach them and patent your research. So first patent your research and then publish your article. Once you patent this, you cannot be published. So here I publish some papers as well as some reviews. Last year we published one review in green chemistry on CH activation, and also we patented our research in government of India also. So try to do this. So all of these things is the representation of business. So representation is not only the poster presentation and oral presentation in conference, in some guest lecturer series. No, this is not an important thing. It will do not an credit to you. Publication and patent is important. If you publish your paper, even though as a short communication, even though as a letter, even though as a literature review, somebody will refer your research, and then they continue your research from your point. So this is the very important thing. So in my view, the representation of research is basically short communication, article, literature review, and patent. So these are the some model tools. Many of persons are familiar with these model tools. ChemDraw is the well-known software which is generally used for the chemistry. This is a paid software, but nowadays it is very easily available in Google. So you can download this ChemDraw from Google. ACD ChemSketch is also available. It is a free software which is available in ACD website. And one of the important thing is the KingDraw. I'm not sure that everybody know about the KingDraw, but KingDraw is the one of the app which will you download in your mobile also. I am the organic chemist, so I always I already download the ChemDraw. What is the benefit of this ChemDraw? When I have to draw the stoichiometry of the reaction, then every time I have to count the number of every time I have to count the numbers of carbon atom, hydrogen atom, oxygen atom, and then write its atomic weight like this. So ChemDraw is the very simplest app which can be used in mobile. You can very easily draw every molecule in your mobile and just select and go to the molecular weight. Suddenly it will give the molecular weight of your compound. It will be very easiest way to execute your research. So here I will show some ChemDraw. So everybody know about the ChemDraw, but here I am trying to show the stoichiometry, means how we can determine the stoichiometry of the reaction by using the ChemDraw. So just so my area of interest is carbazole. That's why I am here draw the carbazole structure, and one of the starting substrate is cyclohexanone. So just this one. Okay. So this is the one of the reaction. So how we can make stoichiometry? Okay. In structure analysis stoichiometry, here you will get one table, and you can see here. So formula is given that this is the formula of the starting substrate, cyclohexanone, and this is the formula of tetrahydrocarbazole. The molecular weight is also given. And if I want to use only one equivalent, and I want to use here only 50 mg of, or we can say only 50 mg of starting material. So this is the 50 mg, and by using the 50 mg, how much I will get? I will get 87.24 mg of product. So this is the very important thing. And even though obviously this is the theoretical yield, and once you're doing reaction, and if we doesn't read the theoretical yield, and consider if I get only the only 70 mg of product. Look this 70 mg, then you can see that only putting the 70 mg, I will get the percentage of yield. So this is the very important concept when we're doing the organic synthesis. This thing is very much important when we write the supporting information. You're very well familiar with the supporting information. Those who have published a good impact factor paper, they very well familiar with the supporting information. Everything we does, everything we cannot give the in manuscript. Procedure, characterization table, or data, everything we have to give in supporting information. So we did around, we synthesized around 35 compounds. We developed 3 methodologies. We developed 3 procedures. So for every compound, 35 compounds, it is not possible manually. It is not possible manually. You cannot, you can count this manually, but it will take more time. So this is the simplest way. Once you know the ChemDraw, everybody know the drawing of structure of ChemDraw. You simply go to the, select the structure, select your reaction, then go to the stoichiometry, and suddenly you will get the data at what level you did your reaction. It may be 50 mg, it may be 100 mg, it may be 1 gram, whatever be. You just put the values of this, you will get the theoretical yield. Then whatever you get observed yield, write your observed yield, then you will get the percentage of yield. Such that you will, by using this method, there is very less percentage of mistake. If you do the manually, I'm sure that you will do some mistakes. So this is the important thing. So by using this camera, many features are there in camera. So in new camera, you can make a good graphical extract also. So if I select this one ring and just put the color, then it will give the color of this thing. So like this, you can do the color of this. Again, so these things are very important. So representation should be nice. You're very well familiar with the graphical abstract. Once your graphical abstract is good, then reader will be attracted towards your manuscript, and they try to read out what is the exactly given in your manuscript. So graphical abstract should be attractive, and for this, novelty should be there. Don't try to copy the other graphical abstract. Think yourself and try to implement your knowledge to the graphical abstract such that it will become very good. So this is the about the camera. Just we come back to our presentation. ACD is the I generally I doesn't use the ACD. I use the camera. That's why I'm suggested that you can also, because camera is a worldwide accepted. Google also have the camera files. You just Google to camera, and many version of the camera is also available. You can use this. King's Draw, here I'm unable to show my mobile. Even though the King's Draw also, you can just go to the YouTube and see what happened exactly in King Draw. So this type of writing tools are available in your mobile. You can easily, because every time it is not possible to open the camera, write the structure, and then count the molecular weight. This thing is not possible every time. So mobile is with you. You just download King Draw, draw your structure, and suddenly select, and you will get the molecular weight. So this the three tools are mostly used. I'm here organic synthesis, that's why I'm saying that these three tools, mostly ChemDraw is used for writing the reactions, drawing the structures. Then these three tools are used for graph. Graph is everywhere. Even though in organic synthesis, material chemistry, biological chemistry, everywhere you have to show your research in terms of graph, in terms of table. So nowadays, if you read some good articles like JAX, Anglichem, Chemical Science, such type of figures are there. Means this is the three-dimensional figure. Such type of figures are there. Three-dimensional figures are included, and it attracted the readers. Then what exactly happened in your research? So this will be the novelty. Try to gain some novelty. For this, Origin is there. Origin is one of the software. It is also available in Google. You can download the version of Origin. In Origin, you can draw the tables, you can draw the graphs, and these graphs can be converted into the three-dimensional. Prism, those who are working in the biological area, they are very well familiar with the Prism software. It is paid software, but it is very much useful to draw the graphs, and also by the IC50 values and some midpoints and slopes is very much important. And I'm always a fan for this Prism graph software. And by using this, Mainly this Prism software is used by the biochemist person. If we don't have such two types of software, you can use the Excel. In Excel, we know very well with the Excel, just draw the table and convert it into the graphs. But the drawback of Excel is that we cannot convert this table into the three-dimensional. Here only we can do the 2D structures of graphs. So try to learn this origin or prism such that your research will be more attractive. So next point is very important is the literature. Previously, I have told that literature is a very important part of our research. Basically, research is based on the preliminary research, primary research. Primary research is nothing but which is easily available, like internet or some audio recording website, which is easily available. So, which is easily available from any sources. Such type of literature is called as the primary research. These are the some types of the electronic sources which can be used for the literature survey, diaries, letter. So this is mainly that English research person, some language research person use such type of methods for collecting the literature survey. Secondary research consists of interpretation and evaluation that are derived from or refer to the primary primary source literature. A secondary source of information is one that was created by someone who did not have first-hand experience or did not participate in the event or condition being researched. Secondary sources describe, analysis, interpret, comment on, and discuss the issues. Once you get the primary literature, then you have to analyze whatever with the comments given by the others. Then this is called as the secondary literature. So try to correct means whatever with the literature review. We discussed earlier literature review. Review is belongs to the secondary research. Articles, patents, such type of textbooks. These are belongs to the secondary literature. So this is just a type of the research. So here the some tools which are generally used for the literature survey. In big universities, they use the SciFinders. SciFinder is one of the program. On one click, you can collect the numbers of the literature on the in the numbers of the literature of your research area. But many, I think many universities purchase this SciFinder. The cost of SciFinder is too much high. It is around 18 lakhs per annum. So it is not possible for us. We're doing at a very basic university. So it is not possible for us to collect the literature from the SciFinder. Rexy is also one of the program, is one of the search engine through which we can collect the literature. Rexy is proposed by the elsewhere. And one of the important thing is ONS. Before 2 years, Honorable Prime Minister declared that every university, every college, every research center should have ONOS subscription. What is the meaning of ONOS? It is a one nation, one subscription plan. This is a very much important. As I told that the SciFinder and Rexy, these are the very costly searching engine. So government of India try to provide research article. We will see the research article and very good impact factor research article. Like we will see here to every university, to every college, such that they can do a very good research. They can comes on the flow of the research. This is very important. Here I will show the one example of ONOS. In my university, I have subscription. So here I have subscription for ONOS. So in your university, it is very reasonable. It is very reasonable, around only 10 to 20,000 per annum. The cost of this is 10 to 20,000 per annum. So here I log in this. Okay, so look at this. One nation, one subscription means ONON provide one interface through which we can search a very good impact factor journals. Here you can see that here American Chemical Society. If I click this, then ACS publication, journals of Asian publications are open. Here you can see this. And if I'm trying to
Hello, sir.
if I'm trying, if this, look this is the all journals, even though material, polymer, biochemistry, organic, energy, every journal. If I just try to open, my favorite journal is Organic Letter and Journal of Organic Chemistry and JAX. Just like
Vivek sir, sorry.
Yes.
Vivek sir, actually, in our university, elsewhere, it's not going to open the paper for this one nation and one link. I don't know
sorry,
why.
Sir. Sorry, sir. Which from which university you belongs?
Actually, Veer Bahadur Singh Purvanchal University, Jaunpur, in UP.
Yeah, exactly. What happens?
Why it's not working for elsewhere?
Yeah. Sir, what happened that the when I contact to my corresponding some corresponding person of ONS in my university. So what happened? The suspicion of elsewhere is too much high.
Okay.
Then the ACS, and if you go through this ONOS, then RSC is not there, sir.
RSC is there in our university.
Okay, RSC is there. Okay.
RSC is there. Yes.
Okay, good one. So in my university, RSC is not there. Elsewhere is there, and also whatever you problem face in university, same problems I also face.
Okay.
Elsewhere journals are not happen because that tetrahedron later belongs to the elsewhere. So what happened? The subscription cost of elsewhere is too much high, and might be everything is working on one cloud.
Right.
You can understand this. The cost is not for ONOS. The cost is for the cloud.
Right.
Okay. And ONOS make one cloud, and every journals collected on one cloud, and they give the permission to the others. Third party means we are the third party. ONS give the permission to the third party, they can access the journals. Okay. So what you have to do? The ONOS make one cloud, and for inviting journals for this cloud, they have to pay the charges, and elsewhere have too much high charges, and maybe the negotiation is not fulfilled. The negotiation was not completed. That's why this year, I think this problem came from March or April or May. I think that.
Right, sir.
Yeah, exactly. Because from the month of May, a new financial year is start. That's why the negotiation was not success, and the elsewhere was not included in that. But something will be good. Something will be going good. I think that. So the aim of government is that every researcher should access. Sorry, sir. May I know your name, please?
Dr. Mithilesh Yadav.
Sir. Mithilesh, sir. You got some good experience from this ONOS.
Actually, sir, RSC and SCS, we are going to download it. But in elsewhere, we are going to not getting that one. So
Yeah, but including RSC, ACS,
Yeah,
there is
yes, yes. That's good. Nothing is better than something.
village there, theme journal is there.
Yeah,
Okay.
yeah.
Village, theme journal, and nature science is there. Okay. Nature science, you can access the nature communication, such type of papers. Means for making
Right,
a good
right.
research, the writing skill should be the nice. And how we improve our writing skill? When we go to the research, when we go to the literature. So I'm sure that the impact factor will be increases of your research. I'm sure that when you collect your all papers from the ONOS, and when you write some papers and cited some papers, and definitely you will get a good impact factor paper, sir. Good luck,
Right.
sir, for this.
Thank you, sir. Thank you.
So this ONOS, and it is very good thing that government of India start this ONS, and every university, and I'm just doing the publicity because ONOS, because many colleges are there, they don't know about the research. Many research centers are there, they not implement the policy of research. So I'm requesting to such type of colleges, go to the library, go to the librarian, and try to give one application to the principal, and do an application to the university, to principal. I have to subscribe, I have to use the ONOS, because once you read paper, you will get the idea. You will get the idea, then you can work nicely. So this important thing is that this is the importance of ONOS, and thanks to the government of India to open this ONOS, because uh, before that the Sci Hub was there. Everybody know about the Sci Hub, but this was banned. So ONOS opened the door for the research, and every researcher should use the ONOS, this website. After this, these are the some modern tools. Here, these are the modern tools to store your research. This is very important. I use these modern tools. My favorite is the Chemotion ELN. This is the one of the important. ELN means what? Electronic Lab Notebook. Electronic Lab Notebook means mostly we write our reaction, we write our notes, we write our data on one notebook. But these data should be preserved for a long time, because today whatever you doing, it is not necessary that tomorrow you will. This thing can be used after 2 years. This thing can be used after 3 years, 5 years. Then it is very difficult to remember then what we had done at that time. So I'm suggesting that you should use the electronic lab notebook. Electronic lab notebook is the free of cost. You can download from the Google, and Chemotion ELN is one of the important notebook in which we can use the organic and synthetic chemistry, even though you can write the procedure in there. And once you get the NMR, once you get the some H1C13 mass, you can upload in that experiment. Means for whole life, this thing is safe, and it is the free of cost. One of the important thing is it is the free of cost. Use such type of things such that after 5 years, after 10 years, if your student is trying to do this reaction, then suddenly you open this notebook, open this experiment, write the one word. So with this word, that experiments are open, and you can give to your student. So this is a very important thing to preserve your research for a long time. eLab FTB is one of the lab book which is generally used for the general science and biochemistry. Molecular drawing, Indigo ELN is used for the analytical and synthetic chemistry. Many other lab book is used. So whatever you want, whatever you like, such type of lab book you can download from the Google and use for your research, to preserve your research for a long time. So Docker is one of the program through which we can download the Chemotion ELN. So this is the important thing. Once you write your paper, Then another point is the plagiarism comes that. So this is the some UGC guideline. This UGC guideline shows that 10% of the plagiarism is acceptable, even though in the article and the thesis, and about 10 to 40% is considered as a level 1. So this is considered as an moderate plagiarism. So consider this in thesis. This is not applicable because many universities want this certificate for the plagiarism. It should be below than 10%. But if you try to write some articles, and if these articles having the plagiarism around 10 to 40, it means then it is acceptable. I don't think so. It is not acceptable. It is acceptable for your publishing data. Then above 40 to 60% is considered as level 2. So this is a very serious thing about that. It is called as a substantial plagiarism. So for this, government or some agency may debar you for 1 year if some article, if some journal found that your article have the more than 40% plagiarism, and they want to take some action, so they can be debarred to you for 1 year for submission of articles. And above 60% is a very serious thing. It is a very severe plagiarism, and for this maybe your research, registration, everything will be the cancelled. So don't be worried about this. Many tools are there such that we can reduce our plagiarism. Plagiarism is nothing but a similarity index. Okay, it is a similarity index. Plagiarism is nothing but the similarity index. And always in for thesis, if you have some student and try to submit your PhD thesis, so try to make your plagiarism below 10%. And if you try to write some article, any article literature review, so it should be 10 to 40%, and it will be accepted for submission. So these are mostly the two tools which are used for the plagiarism. The most favorite tool of mine is the Turnitin. I'm very much like the Turnitin. Since my PhD work, always I use the Turnitin. So, and Drillbit. So these two are the authentic tools which are used for the detection of the plagiarism. Many programs, many online tools are available. Many online tools are available who compromise that I will check the plagiarism. So don't go through such type of tools, because what these tools are not authentic. Turnitin and Drillbit are the authentic tools which are recommended by the universities, which are recommended by the government, through which you can detect your plagiarism of article and thesis, how much it comes. It may be, I'm sure that if I write paper, then my plagiarism will be the 30%. Sometimes my plagiarism is 30% because the tables are there, some sentence are there. So I avoid this plagiarism. So we will see that how we can avoid this plagiarism. So many universities have the subscription of Drillbit and Turnitin. So try to submit your even the articles. I saw that many researchers doesn't check the plagiarism of articles. So I'm suggesting that before submitting the article to the very well known journal, so first you try to detect your plagiarism rate and then submit to the respective journals. So here, this is the important thing. So these tools are used for the artificial intelligence, mostly used for the chemistry research. I'm not using all these tools, but I just want to say that I just want to suggest which tools are the important. For flexibility, means before we discussed that we not able to take this subscription of turn in it, okay, and Rexy, such type of search engine. So these tools are available through which we can easily assess what type of research are going on today. So one tool is the Perplexity. It is one of the search engine. You just write your topic, name of the topic, and on the basis of this name, then it can give the numbers of the papers, numbers of the articles in your interface. Gemini, we very familiar with the Gemini. We very well know how to use the Gemini. So in Gemini, the deep search is also the one of the interface is deep search. So try to use deep search because deep search gives the more detailed idea of your research. One of the icon is there, deep search. Always use deep search, and we are very well familiar with the Gemini. It is also a search engine. Consensus is also a search engine through which we can search our topic. Research Rabbit is used for the literature review. Here you can get the numbers of papers. The papers will be not open, only you will get the abstract from the Research Rabbits. So this is the one of the, again, AI tool which can be used for the chemistry research. OpenRead, this is the important. Jenny is one of the writing tool through which we can write the one matter. We can write one of the phrase for your research. OpenRead is one of the AI tool. Once you submit your PDF, then he can summarize your PDF and also use for the academic purpose. Quillboot, nowadays Quillboot is one of the famous AI tool which is used for the paraphrasing tool. Sci-Face, and mostly I use the Sci-Face which is used for the paraphrasing. So I just want to say that don't use this tool for the writing. Here I just want to say one example. I have Sci-Space. I'm logging this. Okay, this is the one of the interface of Sci-Face. So here I can paraphrase. Look, this is the one interface. If I wrote something, if just I take one example of like this, I just copy this and paste this, okay, and just paraphrase. So I don't need to use my mind. Suddenly he gives the paraphrase like this. So you can use this, but it not gives an idea. It not gives an idea of your mind. It express the ideas of that paper like this. It is not an idea of your mind. So I'm suggesting that try to write paper yourself. Paraphrase is important when you get some literature review. When you if you want to write the introduction part, so in that case you can correct your paraphrase according to such type of AI tools. But for whole paper, it should not be there. So I want to show one thing. So you can write also paper also here like this. Start writing. If you just write, okay, just write. If you put one topic and just okay and write Okay, and just enter. So you can see that after some time, they write papers. Look, look. So this is what they also give the citations also. So this is what we say the use of AI. So here, what I'm not using my mind. I'm just put one word there, and just everything has been done by the AI. So whatever they write, it's not comes from my mind. It's come from the data. It comes from the data, whatever available in internet. So this thing is not good. One important thing is that everything is right by the AI. And when you go through, and nowadays I'm here want to say that one important thing is that if you submit your article for plagiarism, also submit your article for AI also. And if you write some article by using the AI, you will do the 100% AI. So this thing is not good for research. Try to write paper from your mind, from your experiments, such that it will become good. Huh? Why we use AI? AI you use for the literature review. So here literature review is there. If I use the
Vivek sir.
yes.
Sir, what about the paraphrasing? We can use the paraphrasing from AI, and
Yes,
in
sir.
our manuscript, we can publish that one.
From my side, I'm say that it is not good. It is not authentic.
Sometimes, sir, if we polish the paragraph from AI, just polish, we will write and just polish the that paragraph. We can help. We can take the help from
Yes, yes,
AI.
exactly.
Huh?
That's why I'm just show one example. That's why I'm show one example. Even though whole my manuscript you can write by the AI. Okay, and if you want to say, look, for plagiarism, 10% is mostly applicable. 10% is mostly applicable for plagiarism. Same rule is applied for AI also. If your manuscript or thesis have the 10% of AI taking material, then I'm say it will be the okay. But if you go beyond 40%, 50%, then where you use your experience, where you use your mind, so this will be the not. And yeah, I'm agree that AI, from using AI, everything become easier. But use AI where necessity is there, like
Yes,
this.
sir. Actually,
Yeah,
sometimes if we polish the some paragraph from the
yeah, sure,
AI,
sure. If
because the
your yeah,
problem is
if
that this data is going to save there. Maybe it is harmful for us because we
yes,
pay.
yes,
So
exactly, exactly.
try to avoid with AI.
Yeah, exactly, exactly. What that's why I'm saying to say that if your manuscript have less than 10% AI percentage, then it will be the applicable. Okay. What I'm saying that in introduction part, you can use AI. What happen? Introduction part have the literature survey. You can abstract the limitations, drawbacks from the some papers, and try to write in your words, and then go through the AI. Okay, then it will be the polish.
Yes, sir.
Sorry.
But sir, that our paragraph which we want to polish, if we put in AI, that's going to unsecure. Maybe it is going to save with AI, and
Suppose if you publish that paper after 10 months or next year, and today we just polish in that with that AI, maybe it is going to unsecure for us.
Yes, yes. So don't uh, upload your data. What I'm saying that don't upload your original data to any AI tools, because what happened? What is the role of this AI tool? The role of this AI tool to collect the data from others. Here I write, here I give, here AI give the some sentences. So it's not the AI sentence, it collected from some other sources. So I'm suggesting that here, don't upload your original research to any AI tools. Only for refining your research, either in introduction part or some in conclusion part, you can use the AI. And my suggestion is that if your article is less than 10%, then it is acceptable, just similar to the plagiarism. Okay, so that one is important. So you can use such type of AI tool, but from AI tool it will be the easy. But we are the Indians, and if we just communicate the paper to ACS elsewhere, RSC, then one of the most common comment is that you have the grammatically mistake, you have the grammatically incorrect. So by using this, try to write article, try to write paragraph in your own words, and just put the paraphrase, then it will be the refine your concept. So that one, another more important thing is that due to the lack of time, so some good features are also there. So these good features are everywhere uh, in AI tools. So if you just use any AI tools, will be it Grammarly, Sciencebase, and go through this, try to understand what are the features, and you can use these features for your research. By using this research, I'm sure that whatever you express your research in front of the world, it should be great. It should be very nice. So finally, we say that for good research and effective research, uh, the whatever world want, we should express this thing to the world. If recent research, go to the recent research, such that compare your research with the recent research, try to develop your research according to the upgradation and express in front of the world. It should not be hypothetically, means it should have some evidence, it should have some practical base, such that your research will be the good. Practical experiment is important, and it should be the relevant. Relevant means it should be the socially impact, such that your research will become more and more cited. And finally, I'm thankful to the Mission Marvel Mission Santa Gadge Baba Amravati University, and thanks to the coordinator Kodape Madam, who invited me for giving this wonderful talk. And I hope this is the basic thing. This is not too much a high level what I do. This is the one of the basic thing through which you can develop yourself, you can develop your research. And I'm sure after go through this presentation, I'm sure that you very well understand the way of research. Thank you very much.
Thank you, sir. Thank you so much. Now, whose turn this is for the proposal vote of thanks?
Good afternoon, sir.
Yeah, ma'am, please.
Good afternoon, everyone. Myself, Dr. Preeti Deshmukh, Assistant Professor, Department of Chemistry, Pradhan Mantri College of Excellence, Government Autonomous PG College, Chhindwara. It is my proud privilege to propose the vote of thanks on behalf of MMTTC, Sant Gadge Baba Amravati University, Amravati, and all the participants. We express our heartfelt gratitude to Dr. Vivek Humne sir for delivering such an informative lecture on modern tools for chemistry research as parts of this refresher course. Sir, your expert guidance, clear explanation, and engaging presentation have greatly enriched our understanding of advanced research technique in chemistry. Sir, your insightful explanation of the significance of research presentation, modern writing tools like CamDraw, tools for picture and graph as Origin Pro, Prism, MS Excel, literature survey tools like SciFinder, ONOS, ELN, tools for reduce plagiarism like Turnitin, tools for artificial intelligence in chemistry research, Perplexity, Gemini, Research Rabbit, OpenRead, Jenny, SciSpace. Your practical example and clear presentation have motivated us to adopt these modern tools in our research work. This session was truly inspiring and will be beneficial in our academic research perspective. I also express my sincere thanks to organizing committee, coordinators, and all the participants for their active involvement and cooperation. Once again, thank you, Dr. Vivek Humne sir, for your valuable time in inspiring lecture. Thank you to all.
Thank you,
Thank
ma'am.
you very much.
Thank you. And thank you, Professor Humne sir. With the kind
Thank you
consent
very
of Professor Humne sir, I would like to declare that this particular session will be over here. Thank
Thank
you
you
so
very
much,
much.
sir.
Thank you.
Thank you, participants. We will stop and reassemble sharp at 2:30 with our afternoon schedule. Thank you.
अरे यार कॉपी मिसिंग है इसमें तो इन तो कॉपी मिसिंग है चार्ट को
सारंग धोटे सर.
हो सर
सर सुरू करा.
ठीक है सर ठीक है
ओके.
डायरेक्ट शुरू करू सर
हो सर.
ठीक है सर सो गुड आफ्टरनून टू ऑल
Good afternoon, sir. Good afternoon.
Good afternoon.
Good afternoon, sir. Good afternoon.
Good afternoon, sir.
Is this screen visible to all?
Yes, yes.
So today's topic is the navigating IPR in the chemistry from the conceptual understanding to the procedural frameworks.
So in this lecture, in this session, we are deal with what is the IPR, the types of IPR, and how we can connect our chemistry concept or chemistry formula or the chemistry model or any type of research to one of the IPR scheme. So this is the very important from the teacher point of view, from the cash placement point of view, and one of the most important thing is from the student point of view is also. So from you, anyone can tell me what is the IPR? What is the full form of IPR?
Intellectual
property rights.
Okay. And okay. Good. The different types of IPR. How many IPRs are there? Different types of IPR.
Patent, copyrights, trademarks.
Okay. इसके पहले ये लेक्चर हुआ इसके ऊपर IPR के ऊपर?
Yes, sir.
Yes.
Okay. For the cash placement, which is the most important? Cash placement. Which type of IPR is very important?
Patent.
Copyright maybe.
Okay, patent. Okay. Patent. So published patent is countable or granted patent is countable?
Granted.
Granted. Okay. So we are trying to solve the various queries regarding this IPR. So as per the IPR full form, the IPR is the intellectual property right. So in this intellectual property right, here we are dealing with the only the subject specific, that is a chemistry subject specific. So what is the IPR? This is encompasses non-physical assets like the patent and trade secret. It is also protect our assets, that is the safeguard of laboratory. Also it protect, it is also helpful for the licensing our software or our apps like that. It is also helpful for the getting some research funding. What is after nowadays there are so many patent granted are there, but what is the after the granting of a patent? What is the next procedure? That also we are discussing. So this is the IPR, which is the most important for chemistry teachers as well as for the student point of. Now, the types of intellectual property rights, that is one of the one is the trademark. Okay, trademark is there. Next one is the industrial design is also there. Copyrights is also there, patents and trade secrets. Okay. Now, my question is that when we are going connect this IPR for our chemistry research, so how we can go for the trademarks? For example, here is one example is that protect the brand and identity and symbols. Protect the brand. If suppose you started your startup or one of your student is starting the startup, so for that the trademark is very important. Okay. Next one is if suppose we develop some prototype for the investigation or for the characterization that falls under the industrial design, or we suppose we develop one software, mobile phone applications, or any type of book that falls under the copyright sections, and the technical invention and processes that falls in the patents. This is the very important. Now, first one is the geological indicators. This is the one of the type of the IPR. In this slide, you will observe the various types of pictures are there, like the Kadaknath Murga, then the Kanjivaram Sari, Kolhapuri Chappal, Bengal seeds are there, then these Haldis, then the strawberries, Bihapuri Mirchi, all are the geographical indicators. They indicate the particular geographical area, so that they are known as the geographical indicators. So my question is that, can we file geographical indicators in the patent office? Can we file by ourselves? Yes or no? Okay.
Yes, sir, we can file.
We can find. Can we get the benefits from there? Any monetary help after the filing the geographical indicators? So local stuff can be produced and it's beneficial, low cost. Okay, local staff is benefited. Okay. Okay, as we are the chemistry teachers, so how we can connect the geographical indicators with the subject of the chemistry? Anyone? Can we find any idea or any concept which is the specific for the particular geographical area? Can we go for the geographical indication certificate? Okay, we will see. This is the example. Protecting the chemical and biological uniqueness of a region. And one of the my question is that can individual file the geographical indications? Yes, we can file the geographical indicators, but we are not getting any type of monetary help. That is, we are not receiving any type of funding for that, but we can file. Okay. So as for the chemical subject, which type of idea or which type of concept or that we can go for the falls under the geographical indications? There are the two examples are there. One is the flora analysis. Another one is the ecosystem analysis. Okay, flora analysis, just neglecting about the chemical composition of the product, we can find flora analysis. That is the uniqueness of the flora, which is not observed in any other region, but observed only by that particular region. That floral analysis also can be a geographical indicators. We can go for that. Or ignoring the environmental factors influencing the product of characteristics, ecosystem analysis. There is one of the example is there also. Ecosystem analysis, that is also falls under the geographical indications registrations. These are the two examples. One of the examples is this. In Vidarbha, there are the two unique regions are there. One is the Medghat tribal zone is there. Another one is the Lonar Lake is there. In the Medghat tribal zone, unique flora and phytochemical profiles can be protected under the geographical indicators. This is the most important. If suppose you are doing the research on the phytochemical profiles for the Medghat tribal regions and that phytochemicals are not observed other areas except the Medghat tribal zone, then that phytochemicals can be a geographical indicators for that Medghat tribal zone, and we can find that. Another one is the example is the Lonar Lake. That is an ecosystem. As we know that Lonar Lake is very unique. They are in the unique microbial activities also there. Their unique ecosystems are also there. We are forgetting about the environmental factors. Though we can protect the alkali-philic ecosystem and microbial metabolics under the geographical indicators. Both are the related to the chemistry subjects. So we can go with that. We can think about that. That means we can go file the geographical indicators with our chemistry subject also. Everyone got it? समझ में आ रहा है सभी को?
Yes, sir.
Yes, sir. Okay.
Yes, sir.
So this is the one of the example of the geographical indicators. Next one is the most important to the patents, the protecting the inventions, the primary vehicle for the protecting chemical inventions. We are deal with the only chemical inventions. We will see which type of inventions. Now, first is for the any idea, for the any process, there are the few terms are there, which is very, very important. First is industrial applicability. Invention must be capable of being made or used in an industry. वो किसी भी industry में use होनी चाहिए और capable होनी चाहिए. So that we get the grant, we get the patent grant. Novelty is also there. Invention must be genuinely new and globally. If suppose किसी कंट्री में ऑलरेडी उसको डिस्कवर हो चुका है, आपने जस्ट उसको मॉडिफाई किया है और आपने उसको पेटेंट फाइल कर रहे हैं, तो दैट पेटेंट इज आल्सो रिजेक्टेड और उसके ऊपर बहुत सारे ऑब्जेक्शंस आ सकते हैं. तो सो दैट आपका पेटेंट जो होना चाहिए, आपकी जो आइडिया होने चाहिए, दैट शुड बी नॉवेल. नेक्स्ट वन इज इट शुड नॉट बी नॉन ऑब्वियस. must involve the inventive step not obvious to a person skilled in the art. That is the very important. मैं ऐसे ताली बजाऊंगा तो लाइट चालू होना चाहिए, लाइट लाइक दैट, ये सभी चीजें इस टाइप के पेटेंट नहीं होती है। आपको आपके क्लेम में वहां पर कुछ आपको मेंशन करना पड़ेगा, क्लेम मेंशन करना पड़ेगा। हाउ वी कैन गो फॉर दैट, दैट इज आल्सो वेरी इंपॉर्टेंट। इफ सपोज आप सभी इस कंडीशंस को अगर फुलफिल करते हैं तो देन वी कैन गो फॉर द पेटेंट फाइलिंग। So for the chemistry point of view, these are the some examples. First one is the natural metabolite identification. Natural metabolite is identified as a potential therapeutic agents. आप इसको भी पेटेंट फाइल कर सकते हो। Redesign analog synthesis, redesign the metabolite to reduce the toxicity, that is also patentable. Toxicity testing, that is आपने जो ड्रग अभी डिजाइन किया है उसको डिजाइन करने के बाद फॉर एग्जांपल वन ऑफ द ड्रग इज यूज्ड अगेंस्ट द कैंसर टारगेट, ओके, तो उसकी अगर टॉक्सिसिटी अगर आपने रिड्यूस कर दी है तो दैट इज आल्सो वेरी इंपॉर्टेंट, दैट इज टॉक्सिसिटी टेस्टिंग एंड पेटेंटेबल केमिकल प्रोडक्ट। एनालॉग इज रिकॉग्नाइज्ड एज अ पेटेंटेबल केमिकल प्रोडक्ट। सो यहाँ पर एक थोड़ा सा समझ लेते किस वजह से हो रहा है। इन द मेड़घाट टाइगर ट्राइबल रीजन एक फाइटोकेमिकल्स फाइंड आउट हुआ है, उसको अपन ने रीडिजाइन किया है, उसका एनालॉग सिंथेसिस किया है, आफ्टर दैट उसकी टॉक्सिसिटी टेस्टिंग की है एंड इट इज ऑब्जर्व दैट जो ड्रग रीडिजाइन ड्रग जो सिंथेसिस हुआ है वो इट इज अ गुड एज एन कैंसर टारगेट, एज एंटी कैंसर करके भी यूज हो रहा है। और जो प्रीवियस जो ड्रग था उसमें जो साइड इफेक्ट जो थे वो रीडिजाइन करने के बाद वो साइड इफेक्ट रिड्यूस हो चुके हैं। तो सो दैट वी कैन गो विद दैट, तो सो दैट ये जो नया जो मॉलिक्यूल बोल सकते हो या फिर नया जो ड्रग बोल सकते हो आप उसको पेटेंट कर सकते हो। ओके, सो आप में से कोई बता सकता है मुझे कि इन सब चीजों के लिए पर्टिकुलर सॉफ्टवेयर्स यूज होते हैं फॉर द रीडिजाइन टॉक्सिसिटी टेस्टिंग, कोई सजेस्ट कर सकता है मुझे सॉफ्टवेयर का नाम क्या होगा? Software or program or app or any method by which we can redesign the synthesis or we can test the toxicity or patentable, ये patentable छोड़ दो, बीच के दो, redesign और toxicity testing के लिए which platforms are used? Okay, इन सिलिको मेथड नाम सुना है? इन सिलिको, इन सिलिको, okay, anybody know the molecular docking?
Yes, sir. Sir.
Yes, sir.
Okay, yes, okay. Through this molecular docking we can check the binding energy, that is a binding affinity against the particular protein. Am I right?
Yes, sir.
Okay. Okay. Now, there are some online platforms are there where the drugs can be redesigned. That means उस सॉफ्टवेयर में, उस प्रोग्राम में, उस वेब पोर्टल में आप वहां पर आप मेंशन कर सकते हो कौन सा प्रोटीन है जिसके ऊपर आपकी उसकी इफिशियंसी बढ़ानी है, तो सो दैट ड्रग के भी वेरियस टाइप ऑफ सिंथेसिस वो बता सकते हैं, उसको भी आप सिंथेसिस कर सकते हो। दैट इज आल्सो पेटेंटेबल। दिस इज द मोस्ट इंपॉर्टेंट, दिस इज द केमिस्ट्री पॉइंट ऑफ व्यू। मैंने आपको एक आइडिया, जस्ट एक आइडिया सजेस्ट किया है कि आप ड्रग जो है उसको भी रीडिजाइन कर सकते हो। बट रिमेंबर वन थिंग, जब भी आपका प्रोडक्ट इन पेटेंट ऑफिस एग्जामिनेशन के लिए जब भी जाएगा तो वहां पर आपका जो आइडिया है, आइदर आपका जो कंसेप्ट है या फिर जो भी है प्रोडक्ट, उसको कंपैरेटिव फॉर्म में आपको क्लेम करना पड़ेगा। दैट इज प्रीवियस जो जो ड्रग था उसमें क्या ऑब्जर्व हो रहा था और अभी जो ड्रग है उसमें क्या ऑब्जर्व हो रहा है, उसकी एफिशिएंसी बढ़नी चाहिए, उसकी टॉक्सिसिटी भी रिड्यूस होनी चाहिए, देन एंड देन ओनली आपका प्रोडक्ट पेटेंटेबल हो सकता है। Okay, next one is another example. The novel extraction, that is a patenting a novel extraction. This is the process, extraction process से भी आप उसको पेटेंट कर सकते हो। जैसे आपके पास फॉर एग्जांपल नोन केमिकल इज देयर, फाइटोकेमिकल इज ऑलरेडी नोन, ऑलरेडी एक्सट्रैक्शन मेथड इज ऑल्सो देयर, बट एक्सट्रैक्शन मेथड जो न्यूली डेवलप्ड एक्सट्रैक्शन मेथड है उसकी इफिशियंसी ज्यादा है, सो दैट एफिशिएंट एक्सट्रैक्शन मेथड. Then isolation is also there. Through that novel extraction method, we can specifically isolate the phytochemicals, which is very, very important. So that patentable, so that extraction process is also patentable. That extraction process is also very, very important. So that आप केमिस्ट्री में नया मॉलिक्यूल या फिर नए ड्रग सिंथेसिस करना चाहिए ऐसा कोई इंपॉर्टेंट नहीं होता है. आपके पास जो एक्सट्रैक्शन मेथड है उस एक्सट्रैक्शन मेथड्स में अगर आप कुछ नोवेल्टी अगर लाते हो, उसकी इफिशियंसी अगर आप बढ़ाते हो, तो बाय दैट मेथड आल्सो आपको पेटेंट ग्रांट हो सकता है. नेक्स्ट वन इज द लेबोरेटरी सेटअप, विच इज द वेरी वेरी इंपॉर्टेंट. ओके, इसमें भी आप काम कर सकते हो पेटेंट में इन द पॉइंट ऑफ व्यू, केमिस्ट्री पॉइंट ऑफ व्यू. तो देखते हैं. फर्स्ट वन इज द हाइड्रोजेल यूजेस. Innovative uses of hydrogens qualify for the patent protections. Nowadays solid acids भी आते हैं, तो आप हाइड्रोजेल्स आप यूज कर सकते हो लेबोरेटरी सेफ्टी पॉइंट ऑफ व्यू, या फिर लेबोरेटरी में आप सेटअप कर सकते हो, वो भी पेटेंटेड है. या फिर नई टर्म आ रही है, दैट इज अ माइक्रोफ्लूइडिक सेपरेशन. आप में से कितने लोगों को पता है व्हाट इज द माइक्रोफ्लूइडिक सेपरेशन? व्हाट इज द माइक्रोफ्लूइडिक सेपरेशन? What is the microfluidic separation? Microfluidic. Okay. Anybody knows what is the lab on chip?
Yes, sir.
Okay. Lab on chip. Okay. Simple example is ड्यूरिंग द कोरोना वैक्सीन एक किट आती थी जहां से कोविड की टेस्ट पॉजिटिव नेगेटिव आइडेंटिफाई करते थे, रैपिड टेस्ट में जो किट थी. दैट इज आल्सो वन ऑफ द एग्जांपल ऑफ द माइक्रोफ्लूइडिक सेपरेशन, या फिर लैब ऑन चिप भी बोल सकते हो. प्रेगनेंसी किट इज आल्सो वन ऑफ द टाइप ऑफ वन ऑफ द इन्वेंशन दैट इज वो माइक्रोफ्लूइडिक सेपरेशन में ही आता. बट अभी आप क्या कर सकते हो, जो माइक्रोफ्लूइडिक सेपरेशन में जो सेलुलोज पेपर होता है या फिर वो वाटरमैन फिल्टर पेपर होता है, इंस्टेड ऑफ दैट अगर आप सपोज वाटर फिल्टर पेपर की जगह पर दूसरा पेपर अगर आप लगा यूज कर सकते हो, सो दैट द सेपरेशन इफिशियंसी इंक्रीजेस एज कंपेयर टू द ओल्डर वन, तो वो भी आपका पेटेंट हो सकता है. दैट इज द इम्पोर्टेंट, दैट इज ऑल्सो पेटेंटेड. ओके, दिस इज द वेरी वेरी इंपॉर्टेंट. तो सो दैट ये एक एग्जांपल था केमिस्ट्री पॉइंट ऑफ व्यू. इतने सारे पॉइंट्स हैं जहां पर आप यूज कर सकते हो और उसको पेटेंट आप कर सकते हो. आप किसको पेटेंट नहीं कर सकते हो, दैट इज द वेरी वेरी इंपॉर्टेंट. ओके, फर्स्ट वन इज which is the under section 3 is very very important. Section 3 outlines what does not patented. First one is mere discovery. नो पेटेंट विदाउट द एफिकेसी इंक्रीजेस. एक नया ड्रग आपने सिंथेसिस किया है, बट वो नया ड्रग सिंथेसिस करने के बाद उसकी एफिकेसी जो होती है वो इंक्रीज ही नहीं हुई है. जस्ट वी आर डिस्कवरिंग द न्यू ड्रग, बट उसकी एफिशिएंसी आइदर वो कम है या फिर उतनी है जितनी ओल्ड ड्रग की थी जो ऑलरेडी ड्रग मार्केट में अवेलेबल है या फिर नेचर में अवेलेबल है. तो सच टाइप ऑफ डिस्कवरी इज नॉट पेटेंटेबल अंडर सेक्शन 3. सेकंड वन, इफ सपोज आपने कुछ नया सब्सटेंस जो था जो ऑलरेडी पता था, उस सब्सटेंस के जगह पर आपने प्रॉपर्टी को एनहांस किया है. ओके, प्रॉपर्टी को एनहांस किया है, इसकी इफिशियंसी अगर आप बढ़ाई है तो वो वहां पर इसको पेटेंट हो सकता है. बट जस्ट नॉन सब्सटेंस है और उसी की प्रॉपर्टी आपने एक्सप्लेन किया है तो वो नहीं होगा. याद रखना, यहाँ पर एक एग्जाम्पल भी गिवन है. इफ अ रिसर्चर सिंथेसाइज अ न्यू सोडियम सॉल्ट ऑफ known acid or isolate or novel isomer, the patent examiner will automatically reject it under the section 3D. Okay, as a chemist we know that there are the various types of isomers are there. Okay, already one of the isomers है, but आपने एक नया isomers find out कर दिया है तो वो पेटेंट नहीं होगा, वो रिजेक्ट ही हो जाता है अंडर सेक्शन 3D. दिस इज द इम्पोर्टेंट. ओके, नाउ from all participant, one question is there: can we go for the agriculture product for patent? Agriculture product को मैं पेटेंट कर सकता हूँ क्या? In Indian patent law, according to the Indian patent law, according to Indian patent law, can we go for agriculture product?
Yes.
No,
Yes,
sir,
sir.
it will come under
Yes.
trademark.
Okay. We will
Yes,
see.
sir.
Okay. And can we go pharmaceutical product for the patent? Hello.
Yes, sir.
Yes.
Yes, sir.
Yes.
Yes. Okay. See. Now, there are some examples. Non-patentable discoveries, traditional knowledge, that is a standard Ayurvedic principle without the technique, without the novel technical intervention. That is also non-patentable. Pure algorithm, computer, software, कभी भी पेटेंट होते नहीं हैं विदाउट द हार्डवेयर. अगर आपका सपोज हार्डवेयर अगर उसके साथ है तो देन वी कैन गो फॉर पेटेंट. बट कोई भी सॉफ्टवेयर, कंप्यूटर प्रोग्राम, ये जो होते ये कभी भी पेटेंट होंगे नहीं. नो सब्सटेंसेस आल्सो देयर. दीज आर द सम एग्जांपल्स जो पेटेंट होते नहीं. नाउ माय क्वेश्चन इज दैट, जो था क्वेश्चन कि एग्रीकल्चर प्रोडक्ट या फिर ड्रग्स को जो है वो मैं इंडियन पेटेंट लॉ के हिसाब से पेटेंट कर सकता हूँ क्या? इसका आंसर है नो. आप ड्रग्स को पेटेंट नहीं कर सकते हो. दैट इज मेडिसिनल ड्रग्स, यानी मीन्स व्हाट, मेडिसिनल जो पॉइंट ऑफ व्यू जो आपकी डिस्कवरी रहेंगी, मेडिसिनल एप्लीकेशन जो रहेंगे, वो अंडर सेक्शन 3 आप इंडियन पेटेंट लॉ के हिसाब से पेटेंट नहीं कर सकते हो. साथ में एग्रीकल्चर प्रोडक्ट भी आप पेटेंट नहीं कर सकते हो. इसका एक एग्जांपल मैंने आपको दी. ओके. नाउ अभी मुझे पेटेंट फाइल करना है. टुडे जो सेशन है मैं सिर्फ और सिर्फ आपको पेटेंट फाइल करना, पेटेंट क्या होता है, कॉपीराइट क्या होता है, ये नहीं पढ़ाने वाला हूँ. मैं आपको इसके बारे में पेटेंट को फाइल करते समय उसकी जर्नी होती है पर्टिकुलरली, वो सब कुछ आपको पढ़ाने वाला हूँ. और ये जो स्टेप्स होती है आप नोट भी करके रख सकते हैं. सबसे पहले द लास्ट लेक्चर मैंने आपको कंसेंसस, रिसर्च रैबिट, एआई कौन से मॉडल्स होते हैं, ये सब कुछ मैंने बताया था. आपने जो आइडिया इन्वेंट की है, आपको लगता है कि ये प्रोसेस को मुझे पेटेंट करना चाहिए, तो देयर शुड बी द सम पेटेंट सर्च. कुछ फ्री पेटेंट सर्च इंजिन्स होते हैं जहां पर आपको अपनी आइडिया को सबसे पहले चेक करना है कि वेदर सच टाइप ऑफ वर्क इज ऑलरेडी पब्लिश्ड और नॉट. ये ग्लोबली हो चुका है, नहीं हो चुका है. तो बिकॉज पेटेंट फाइल करने के लिए योर वर्क शुड बी द नॉवेल, नॉवेल्टी उसमें होनी चाहिए. इसलिए आपको सबसे पहले करना पड़ता है इनिशियल इन्वेस्टिगेशन, conduct thorough research or search for the existing patent and publications. For that, we can use Indian Patent Journal, Indian Patent Search Engine. We can also use the Google Patent Search also there. आपके पास वाइपो भी है. इन सभी से आप यूज करके आप इनिशियल सर्च कर सकते हैं. सर्च करने के बाद दो पॉसिबिलिटीज है यहाँ पर कि वेदर माय वर्क इज न्यू और नो, वर्क एंटायरली नया नहीं है, सच टाइप ऑफ वर्क इज देयर. तो सो दैट मैं उसमें कुछ मॉडिफिकेशन करूंगा, या फिर मुझे पूरा वर्क जो है ये किसी ने अभी तक काम किया नहीं था, सो दैट मैं इस पे काम करूंगा. सो दैट नेक्स्ट प्रोसीजर इज ड्राफ्टिंग ऑफ स्पेसिफिकेशन. आपको पेटेंट को जो है ड्राफ्ट करना पड़ता है, एप्लीकेशंस लिखने पड़ते हैं. वो नेक्स्ट इसमें बताऊंगा मैं कौन से एप्लीकेशंस होते हैं. एक बार आपका एप्लीकेशंस बन गया, आपको कुछ फॉर्म भी सबमिट करनी पड़ती है, फीस भी सबमिट करनी पड़ती है. फीस सबमिट करने के बाद आपको रिक्वेस्ट फॉर एग्जामिनेशन के लिए भी देना पड़ता है. आपकी जो आइडिया होती है उसको एग्जामिनेशन भी करना पड़ता है. विदाउट रिक्वेस्ट फॉर एग्जामिनेशन, याद रखना, दैट इज नॉट इम्पॉर्टेंट. So tell me one thing, patent publication is good practice or bad practice?
Good, sir.
Good practice.
Good practice. Anyone can explain how it is a good practice? Patent publication, only patent publication is good practice or bad practice? Only publication. Okay, now see. Patent. Okay. What is the aim of patent publication? What is the aim of patent publication?
The work is already recognized.
Okay. Okay. to give the protection to our
protect
innovation.
our
Intellectual property. Protection of intellectual property.
Patent publication. Okay. Okay. I got it. Let वन बाय वन कंसेप्ट को समझ लेते हैं. Okay. और कहाँ प्रॉब्लम जाता है, दैट इज आल्सो वेरी वेरी इंपॉर्टेंट. नाउ नेक्स्ट इज, ये आपको सर्च है, आपको सर्च करना पड़ेगा. ग्लोबल प्रायर आर्ट सर्च प्रोसेस होती है. लोकेट सिलेक्ट अप्रोप्रिएट पेटेंट डेटाबेस, सर्च करो थ्रू द साइंटिफिक लिटरेचर, पेटेंट डेटाबेस से भी सर्च करो, और योर सेल्फ आप इवेलुएट करो कि ये नॉवेल्ट है या नॉवेल्टी इसमें है या नहीं है. इसके लिए आप जो मैंने आपको कुछ टूल्स जो बताए हैं, आप उसको भी अमलगट करके, दैट इज कंबाइन करके भी आपको वो आपका वर्क वेदर इट इज अ नोवेल और नॉट, ये भी बता सकता है. ठीक है. Next procedure is, there are the two types of specifications are there. One is the provisional specification, another one is the complete specification. Do you know that both the specification, what is the provisional and what is the complete?
No, sir.
Okay. The provisional specification सबसे पहले समझ लेते हैं. आज आप लैब में बैठे हो, लैब में बैठे बैठे आपने ऐसा सोचा है, फॉर एग्जाम्पल मान के चलते हैं कि मैंने बाय यूजिंग अ कंप्यूटेशनल केमिस्ट्री से मैंने एक नया ड्रग सिंथेसिस कर रहा हूँ, दैट इज अ रीडिजाइन ऑफ अ ड्रग बाय यूजिंग अ कंप्यूटेशनल केमिस्ट्री मेथड. आफ्टर द रीडिजाइनिंग, जो भी ड्रग का नया डिजाइन जो फॉर्म हुआ है, उस रीडिजाइन को मैं अगेन कंप्यूटेशनल मेथड के थ्रू पर्टिकुलर एंटी कैंसर प्रोटीन के साथ, दैट इज कैंसर रिस्पॉन्सिबल प्रोटीन के साथ में बाइंड करके देखता हूँ कंप्यूटेशनली. मैंने अभी तक वेट लैब मेथड यूज नहीं किया, और इट इज ऑब्जर्व दैट कि जो प्रीवियस दैट इज अ लीड ड्रग जो था, उसके कंपैरिजन में रीडिजाइन ड्रग इज वेरी इफेक्टिव. तो इमीडिएटली मेरे माइंड में आता है कि ये जो है ड्रग, इसको मैं इमीडिएटली फाइल करना चाहिए. और आज की डेट, सपोज आज की डेट है 8 तारीख, 8 तारीख को मैं फाइल करता हूँ, दैट इज द प्रायोरिटी डेट. दिस इज द प्रोविजनल स्पेसिफिकेशन. जस्ट आपको फॉर्म नंबर 1, फॉर्म नंबर 2, फॉर्म नंबर 3 भर के देना है. अलॉन्ग विद दैट फीस, आप इसको ऑनलाइन भी पे कर सकते हो या फिर ऑफलाइन में आप डीडी के साथ भी इसको पे कर सकते हो. आपने क्या किया है, यू आर जस्ट सिक्योरिंग यूर प्रायोरिटी डेट. व्हाट इज द प्रायोरिटी डेट, दैट इज आल्सो वेरी वेरी इंपॉर्टेंट. तो समझ लेते हैं इसमें. आपने आज फाइल करके रखा है इसको, दैट इज 8 जुलाई इट्स डे. बट अलॉन्ग विद दैट, इन वन ऑफ द अनदर कॉर्नर, दूसरे किसी लैब में एक इंसान है, उसने भी वही सोचा है, और उसने भी आपके जैसे ड्रग सिंथेसिस किया है. ड्रग सिंथेसिस करने के बाद सेम मॉलिक्यूलर स्ट्रक्चर, सेम बाइंडिंग एनर्जी, वॉट एवर इज दैट ऑलरेडी इज, एवरीथिंग इज सेम. बट उसने जो है फाइल करने के लिए 2 दिन एक्स्ट्रा लिए, दैट इज अ प्रोविजनल स्पेसिफिकेशन, उसने 2 दिन के बाद किया है. तो उसकी प्रायोरिटी डेट होगी 10 जुलाई. ओके. तो आपका भी क्लेम आ गया और उसका भी क्लेम आ गया 10 जुलाई को. देन हु इज द विनर, फर्स्ट वन और सेकंड वन?
सर फर्स्ट वन.
फर्स्ट वन इज द विनर. ओके. टिल नाउ फर्स्ट वन इज द विनर. नाउ अभी थोड़ा समझ लो. आपने जस्ट प्रोविजनल स्पेसिफिकेशन में जस्ट यू आर मेंशनिंग द एब्स्ट्रैक्ट, व्हाट इज द केमिकल प्रोसीजर, व्हाट इज द केमिकल फॉर्मूला, एंड जो भी ड्रग डिसीज के लिए था पर्टिकुलर उस डिसीज के लिए आपने उसमें मेंशन कर दिया है. दूसरा जो पार्टनर है उसने भी वही किया है. ओके. फ्रॉम द डेट ऑफ प्रोविजनल स्पेसिफिकेशन आपके पास 1 साल का टाइम होता है, जहां पर आपको कंप्लीट स्पेसिफिकेशन देना पड़ता है. कंप्लीट स्पेसिफिकेशन इज व्हाट, वहां पर होते हैं क्लेम्स. आपको क्लेम्स लिखने पड़ते हैं आपके आइडियाज के, आपके प्रोसेसेस के, या व्हाट एवर इज दैट, आपको क्लेम लिखना पड़ता है. क्लेम 1 इज दैट दिस ड्रग इज डिराइव फ्रॉम द दिस इज कंटेंट दिस कंटेंट, ऐसे आपको क्लेम्स लिखने पड़ते हैं. विदाउट क्लेम अगर आप फाइल करते हो, दैट इज प्रोविजनल स्पेसिफिकेशन. कंप्लीट स्पेसिफिकेशन में आपको 1 साल का टाइम मिलता है, जहां पर आपको कंप्लीट क्लेम्स लिखना पड़ता है, अलॉन्ग विद दैट बैकग्राउंड लिखना पड़ता है, ये किस फील्ड से रिलेटेड करता है, लाइक दैट. तो इसके लिए आपको 1 साल मिलता है. अभी मैं मेरा क्वेश्चन देखिए. जो फर्स्ट वन था उसने 1 साल के बाद कंप्लीट स्पेसिफिकेशन फाइल कर दी, और जो सेकंड वाला था ना, उसने 15 दिन में ही, विद इन 15 डेज उसने कंप्लीट स्पेसिफिकेशन फाइल कर दिया है. नाउ हु इज द विनर, फर्स्ट वन और सेकंड वन?
Sir, second one.
Anyone?
Second one, sir.
Second one. Wrong. First one is winner.
Yes.
Priority date. Date of priority. Date of priority is very, very important. Remember this thing. Okay. Because first इंसान ने अपनी आइडिया को पेटेंट बुक करके रखा, दैट इज नोन एज एडवांस बुकिंग सिस्टम टाइप. उसने 8 जुलाई को ही बुक कर दिया था, भले ही सेकंड वाला दूसरे ही दिन कंप्लीट स्पेसिफिकेशन क्यों ना दे, दैट इज नॉट इम्पोर्टेंट. कंसेप्ट एंड आइडिया इज वेरी वेरी इंपॉर्टेंट. दैट इज द डेट ऑफ प्रायोरिटी. दिस इज द वेरी वेरी इंपॉर्टेंट. सबको समझ में आ गया है डिफरेंस?
Yes.
Yes, sir.
सो दैट टू अवॉइड दैट क्या करो, कभी भी प्रोविजनल स्पेसिफिकेशन के साथ आप डायरेक्टली कंप्लीट स्पेसिफिकेशन भी लिख के भेज दो उनको फुल क्लेम के साथ. तो दैट मीन्स आपको सामने जाके कोई ऑब्जेक्शंस नहीं होते. किस टाइप से फाइल करना है मैं आपको बताऊंगा, बट दिस इज द इंपॉर्टेंट थिंग. प्रोविजनल स्पेसिफिकेशन अगेंस्ट द कंप्लीट स्पेसिफिकेशन. प्रोविजनल स्पेसिफिकेशन के जस्ट एक साल के अंदर आपको कंप्लीट स्पेसिफिकेशन भरना पड़ता है. इफ एनी प्रॉब्लम अगर होता है, अगर आप नहीं कर पाते हो, तो आपको एक फीस, लेट फीस पे करके आपको और 6 महीना ज्यादा मिल सकते हैं. बट मैक्सिमम लिमिट इज 18 मंथ. दिस इज द इम्पोर्टेंट. और जब तक आप कंप्लीट स्पेसिफिकेशन नहीं करोगे तब तक आपका पेटेंट पब्लिश्ड, एग्जामिन और ग्रांट नहीं होता है. सो दीज आर द सम स्टेप्स एंड फॉर्म्स आर देयर. फर्स्ट वन. ओके. इफ सपोज आप जो फॉर्म भरने वाले उसके लिए आपको लगेगा फॉर्म नंबर 1 जो आपको भरना ही है. देन अलॉन्ग विद दैट आपको टेक्निकल डिस्क्रिप्शन भी देने हैं, दैट इज अ फॉर्म नंबर 2. ये फॉर्म नंबर 2 में ही आपको क्लेम्स मेंशन करने पड़ते हैं. ओके. बट ऐसा नहीं है कि आपको फॉर्म नंबर 1 पहले सबमिट करोगे, फॉर्म नंबर 2 बाद में सबमिट करोगे, ऐसा कुछ भी नहीं होता है. ध्यान में रखना, आपको फॉर्म नंबर 1, 3, 2, 5 ये सबमिट ही करने पड़ते हैं, वेदर योर एप्लीकेशन इज प्रोविजनल और कंप्लीट. दैट इज द इम्पोर्टेंट. फॉर्म नंबर 1, फॉर्म नंबर 5, फॉर्म नंबर 2 एंड फॉर्म नंबर 3. एंड दीज फॉर्म्स आर वेरी वेरी इजी. आप इसको इजीली फिलअप कर सकते हो, वेरी इजी है. सभी फॉर्म इंडियन पेटेंट जर्नल, सॉरी इंडियन पेटेंट ऑफिस के वेबसाइट पर जाओ, सभी फॉर्म्स वहां पर अवेलेबल होते हैं. वेरी वेरी इजी. और ये थी उसकी स्टेप्स और एक कॉस्ट. अभी समझ लो प्रॉब्लम कहाँ पर होती है. और जो पेटेंट एजेंट्स होते हैं या फिर पेटेंट अटॉर्नी होते हैं वो कहाँ पर अपने से ज्यादा अमाउंट कर डिमांड करते हैं. तो यहाँ पर सबसे पहले कैटेगराइज करके रखी है मैंने. एजुकेशनल इंस्टीट्यूट होगा, स्टार्टअप होगा या फिर इंडिविजुअल होगा, या फिर फिजिकल फाइलिंग ऑनलाइन ऑफलाइन दोनों भी है, या फिर लार्ज एंटिटी होगी, कॉर्पोरेशन सेक्टर होगा, उस टाइप में. यहाँ पर अगर आप देखते हो तो ऑनलाइन के लिए कितनी फीस लगेंगी और ऑफलाइन के लिए कितनी फीस लगेगी वो पर यहाँ पर मेंशन किया हुआ है. ठीक है. मैं मान के चलता हूँ प्रोविजनल फाइल्स कर रहा हूँ सबमिट, प्रोविजनल. तो प्रोविजनल के लिए आपको फीस लगने वाली है 1600 रुपये, दैट इज ऑनलाइन. But if suppose I am doing the offline, then it is a 1,750 rupees. This is for educational institute, startup and individual only. जिसका नया स्टार्टअप है. अगर सपोज आप अगर कंपनी के थ्रू अगर जा रहे हैं तो यही कॉस्टिंग बढ़ जाती है यहाँ. ओके. तो सब फर्स्ट स्टेप में आपको क्या करना है, बंडल क्या रहेगा. फर्स्ट वन आपको फॉर्म नंबर 1 भी रखना है एप्लीकेशन, प्लस फॉर्म नंबर 2 भी रखना है. यहाँ पर देखो स्पेसिफिकेशन लिखा है, आप जस्ट यहाँ पर एब्स्ट्रैक्ट टेक्निकल बैकग्राउंड आप मेंशन करो, क्लेम नहीं लिखा तो भी चलेगा. फॉर्म नंबर 3 करो फॉरेन फिलिंग है, एस और नो, देयर इज नो प्रॉब्लम. एंड फॉर्म नंबर 5 दैट इज इन्वेंटरशिप. व्हाट इज द इन्वेंटरशिप, थोड़ा समझ लेते हैं, थोड़ा सा बेसिकली समझ लेते हैं व्हाट इज द इन्वेंटरशिप. नाउ अगेन देयर इज वन क्वेश्चन फॉर यू. For research article, the position number 1, 2, 3, 4, 5 is very, very important. Am I right?
Yes, sir.
Yes.
Yes. If suppose in the research article, anyone, suppose the person A is there, he is in the first position, and person B is there, which is in, who is in second position. So that according to UGC rule, first one will get 70% marks.
Right.
Right. And 30% marks is for the B, right?
Yes, yes.
So such type of scheme or such type of rule is also applicable for the patent?
We don't know, sir, really.
No. Remember one thing, for the patent certificate, where your name is first or last, there is no such type of marking is there. Everyone got the same marking system. How much mark? मैं आपको स्लाइड में बताऊंगा, ध्यान में रखना। इन पेटेंट, इन कॉपीराइट, इन आईपीआर में मेरा फर्स्ट नेम होना चाहिए, मेरा सेकंड नेम होना चाहिए, या फिर फर्स्ट होना चाहिए, थर्ड, ऐसी कोई जरूरत नहीं है। सभी को इक्वल मार्क डिस्ट्रीब्यूट होते हैं। दिस इज द इम्पोर्टेंट, क्योंकि समटाइम्स आपके व्हाट्सएप ग्रुप पर एक ऐसा मैसेज आता होगा कि ये पेटेंट फाइल करना चालू है, पोजीशन 1 अवेलेबल, पोजीशन 2 अवेलेबल, पोजीशन 3 अवेलेबल। तो आप देखोगे पोजीशन 1 के लिए हायर कॉस्टिंग होती है और पोजीशन 5 के लिए लोअर कॉस्टिंग होती है। तो लगता है कि लोअर लेना चाहिए, इसलिए ध्यान में रखना, नंबरिंग हायरार्की पेटेंट में नहीं होती है। दिस इज द इम्पोर्टेंट।
But corresponding author is there, sir.
Where in patent?
Yes.
No, sir, no. In the patent, there is no corresponding. There is an applicant.
Inventor.
No, sir. Okay. I tell you the difference between the. Suppose there are the 10 people, 10 students are there. 10 students develop one idea, develop one concept or procedure, and they are trying to file a patent. So that out of 10, one will be the applicant. जो है करस्पॉन्ड करने वाला है वो रहेगा 1 नंबर वाला। कोई भी एक आउट ऑफ 10 कोई भी एक डिस्कस करेंगे 10 में 10 लोग और बोलेंगे कि किसी को करना है। दैट अप्लीकेंट इज ओनली रिस्पॉन्सिबल फॉर द कम्युनिकेशंस। जो भी राइट, जो भी मेल आएगा, जो भी आएगा। और ये जो इन्वेंटरशिप होती है फॉर्म नंबर 5 इज दैट कि ये जो 9 लोग होते हैं, 9 लोग साइन करके देते हैं कि हमने हमारा एज अप्लीकेंट करके इस पर्सन को रखा है, जो भी डीलिंग करना है, जो भी करस्पॉन्डिंग करना है, इस पर आप इसको कीजिए। दैट इज द डिक्लेरेशन ऑफ इन्वेंटरशिप। दैट इज ए भी लिख के देगा जो इंसान कि इन्वेंटर्स ये सभी लोग हैं और इनको रिप्रेजेंट मैं अकेला कर रहा हूं, उसको अलग से मार्क्स मिलते नहीं है। दैट इज द इम्पोर्टेंट। हाँ, यस,
ओके सर।
ओके, ध्यान में रखना, पेटेंट में नंबर 1 नंबर 2 नहीं होता है। Okay, now next one is, suppose I am interested for the early publications. For the early publications, along with this form number 1, 2, 3, 5, I will also apply with the form number 9 is also there. For early publication for the online way, there is a 2,500 fees. If suppose physical, the DD is there 2,750. So early publication, form number 9 is there. What is the meaning of early publication is very simple. Within 1 month after the filing of your patent, within 1 month, your idea, our concept is published in Indian Patent Journal website. Okay, Indian Journal Patent website. And if you see the Indian Patent Journal, इसको ISBN number भी नहीं है. So that for the teacher point of view, for the CAS plus point of view, the publications is not important for teacher point of view only. Publication is not important. Remember this. Then why publications is there? तो उसका भी रीजन समझ। एक्चुअल में पब्लिकेशन क्यों होना है? आपका जो कंसेप्ट है, दैट कंसेप्ट इज पब्लिकली ओपन, दैट इज पब्लिकली ओपन हो गया, सभी डोमेन में ओपन हो गया है। इफ सपोज एनीवन हैविंग द ऑब्जेक्शन, तो ये ऑब्जेक्शन के लिए आप इस पेटेंट जो पब्लिश हुआ है उसको पढ़ो और इसमें ऑब्जेक्शन लो अगर होगा तो। फॉर दैट ओनली देयर इज अ पब्लिकेशन। इफ यू डोंट, हाँ सर,
maybe someone objected and it will go rejected.
No, sir. If suppose you filed one patent along with the early publication fee, your idea or your concept is published on the patent journal. I'm monthly that is checking all the websites of this, and I observed that your idea is similar with my idea which is already patented. So that I am just writing one letter to patent office by using the patent number. So that from the patent office you will receive the one mail that is particular person having the objection against your idea. Then and then only just clarify yourself, give the whatever the objection is that how to you can remove that objections, what is the your answer for the objections. If suppose the controller of examiner is agree with your or is satisfied with your all the explanation, then he will ask you to go for the examination, that is a form number 18A. And then only they decide whether the patent is granted or not. During publication, there is no chances to reject your patent. Remember this thing.
No,
There
but if he will not clarify or not respond to all the queries, then maybe it can, or it is
They-
similar work with previous one, published one, so they
Ah.
can reject like that.
They just send you mail, sir. Your
Okay.
such type of work is already published. So whether you want to go for examination or not.
Okay.
Without examination, there is no patent granted whether it our idea should receive the objection or not. This is the very, very important thing. If suppose I want to after the publication, I am also interested for the early examination. Early examination, like early publication, there is early examination is also there. So that ये फॉर्म नंबर 1, 2, 3, 5 के साथ में फॉर्म नंबर 18A, फॉर्म नंबर 9 और 12,010 100 अलग अलग डीडी। ध्यान में रखना, आपको पेटेंट में एक साथ डीडी नहीं बनाने पड़ते, आप अलग अलग डीडीज बनानी पड़ती है। तो ये सब डीडी बना के मैं अगर सबमिट कर देता हूँ तो मेरा जो एग्जामिनेशन जो है पब्लिकेशन के बाद विद इन 1 वीक मेरा एग्जामिनेशन भी स्टार्ट हो जाएगा। Now, this examination period is very, very important and very, very crucial for us. During this examination, if suppose such type of work is already there, globally check होता है, thoroughly check होता है, आपने जो claim किया है उसका technical background check होता है, सभी check होता है। और ये सब check होने के बाद, if suppose there is no such type of objections are there, then patent will be granted within 1 year of date of filing. Within 1 साल में आपको patent grant हो जाता है with the minimum cost. If suppose there are some objections are there, then time for a granting is also increases and costing is also increases because आपको हर बार hearing के लिए जाना पड़ता है, उसका explanation देना पड़ता है। But इन सब चीज को bypass करने के लिए we are appointed the patent attorney जिनकी costing सबसे ज्यादा होती है। Just वो 50 to 60,000 drafting के लिए ही लेते हैं। That is the so इफ सपोज आप ऑनलाइन मोड में जाते हो इंडिविजुअल या फिर स्टार्टअप करके, तो नियर अबाउट 13,000 में आपका पेटेंट पब्लिश भी हो सकता है और एग्जामिन भी हो सकता है। जो मेरा जो क्वेश्चन था कि ग्लोबली रिकॉग्नाइज हुआ है करके वक्त, रिमेंबर वन थिंग, पेटेंट पब्लिकेशन ये जो होती है टर्म, दिस इज नॉट showing that your work is globally accepted. This is only for the public domain में वो आइडिया आपकी ओपन हो जाती है, सब लोग पढ़ो, उसमें अगर उसको ऑब्जेक्शन है तो आप उसको बता सकते हो। बिकॉज पब्लिश के बाद एग्जामिनेशन के लिए वो जो होता है कंसेप्ट, वो कम से कम 1 साल तक ओपन होता है। और इन बिटवीन अगर आपको सपोज पेटेंट ग्रांट होता है तब भी उसके बाद भी ऑब्जेक्शंस आते हैं। दैट इज द इम्पोर्टेंट। बट स्टूडेंट पॉइंट ऑफ व्यू, सपोज मैं एज अ स्टूडेंट हूँ, यूजी का स्टूडेंट हूँ, एमएससी का स्टूडेंट हूँ, तो फॉर दैट पॉइंट ऑफ व्यू फॉर मी इट इज इनफ कि स्टूडेंट की आइडिया पब्लिश हो रही है, स्टूडेंट की आइडिया पब्लिश हो रही है। इन सम जगह पर वो रिकॉग्नाइज भी कर लेते हैं पब्लिश हुआ करके इसकी आइडिया, ये पेटेंट पब्लिश हुआ करके। एज अ स्टूडेंट पॉइंट ऑफ व्यू इज वेरी वेरी इंपॉर्टेंट बिकॉज वी आर परकुलेटिंग द नॉलेज ऑफ आईपीआर इन द स्टूडेंट, दैट इज द इम्पोर्टेंट। और नैक यही एक्सपेक्ट कर रही है। जस्ट अर्ली पब्लिकेशन इज ऑल्सो देयर। आप पब्लिश करो स्टूडेंट की आइडिया पेटेंट पब्लिकेशन में, नैक आपको अप्रिशिएट करेगी। और देयर इज वन स्कीम, दैट इज अ कपिला स्कीम इज देयर। थ्रू दिस कपिला स्कीम कॉलेज को जितने भी सपोज आज मैंने 10 स्टूडेंट के फाइल कर दिए हैं, दैट इज 1600 रुपए का ये बना दिया है, और 8,000 रुपए का मैंने वो भी कर दिया अर्ली एग्जामिनेशन। तो ये सारे पैसे पर स्टूडेंट वापस भी कॉलेज को मिलते हैं। दैट इज द इम्पोर्टेंट कपिला स्कीम। सबको पता था कपिला स्कीम के बारे में?
नो सर।
No, sir, no.
कपिला स्कीम इज ऑल्सो देयर। हर साल आपके कॉलेज के अगर मिनिमम 100 बच्चों का अगर पेटेंट फाइल आप करके देते हो, दैट मीन्स पेटेंट फाइल मीन्स व्हाट, प्रोविजनल एंड फॉर्म नंबर 18A का 8,000, इतने सारे पैसे वो वापस करके देते हैं, आपके कॉलेज के अकाउंट में पैसे आते हैं। दैट इज अ कपिला स्कीम, इंपॉर्टेंट है। ओके, सो दीज आर द प्रोसेसेस फॉर द पेटेंट। So
So we have
remember
to, sir, we have to need the 10 students, yeah?
no sir,
Minimum?
it is not compulsory, sir. In some
Okay.
patent you can go along with the 40 student also.
Sometimes 2, 3 is also okay for Kapila scheme.
Yes, yes sir, yes sir, yes sir. If suppose from your college, sir, 100 student is not. That is the patent number. If suppose in one patent there are the 20 inventors, so there is so that funding amount will be not 20 into 1600. That is only 1600 per patent, per idea. If suppose 10 students are there and all these 10 students having the different idea, they are having the different patent publications. So that funding will be 10 into 16,000. Got it, sir? Okay, you can go. अभी नॉर्मली स्टूडेंट जो होते हैं, एक स्टूडेंट वी कैन क्लब विद द 10 स्टूडेंट 20 स्टूडेंट को लेकर भी एक पेटेंट पब्लिश आप कर सकते हो. बिकॉज सर इनिशियली पेमेंट तो आपको ही करना या फिर स्टूडेंट करेगा. इतनी ज्यादा फीस स्टूडेंट बेयर नहीं कर पाते, तो कुछ स्टूडेंट फिर 500 रुपए कलेक्ट करेंगे. तो उन सबका भी नाम डाल के आप पेटेंट फाइल कर सकते हो और कुछ दिन के बाद वो पैसे भी वापस मिलते हैं. आप वो भी कर सकते हो या फिर डायरेक्ट कॉलेज भी फाइल कर सकता है. दैट इज अ कपिला स्कीम, मिनिस्ट्री ऑफ Innovation Council. Now, step number 4, request for the examination, form number 18. We be within 48 months में आपको भरना पड़ता है. Without this request, patent applications will be abandoned और ये कभी भी प्रोसेस नहीं होगा. That means अगर आपने सपोज पेटेंट पब्लिश कर लिया है, पेटेंट पब्लिश के बाद वो अगर सपोज उसके ऊपर कुछ भी ऑब्जेक्शंस नहीं आ रहे हैं, वी आर नॉट रिसीव्ड एनी टाइप ऑफ मेल, तो दैट नॉट मीन दैट कि आपका पेटेंट गारंटी होने वाला है. आपको इस फॉर्म नंबर 18 को भरना ही पढ़ के देना पड़ता है. विदाउट दैट, विदाउट ऑब्जेक्शन आए या फिर ना आए, आपको फॉर्म नंबर 18 देना ही पड़ता है. वहां से आपका एग्जामिनेशन स्टार्ट होता है और ये आपको भरना पड़ता है विद इन 18 मंथ्स फ्रॉम द प्रायोरिटी डेट. जिस डेट में आपके भरा था उसके विद इन 48 मंथ्स में आपको इसको फिल करना पड़ता है. नहीं तो ये पेटेंट अबेंडेंड हो जाता है.
48
मंथ, 2 साल के अंदर. 48 मंथ, 2 साल के अंदर, 2 साल के अंदर. अगर आप सपोज
24 मंथ सर ना, 2 साल मतलब 24 मंथ.
हाँ सॉरी 48 मंथ्स. यस करेक्ट 48 मंथ्स. 48 मंथ्स सर. दैट इज 4 years.
4 years.
4 years.
4 years. Within 4 years.
It's a long time.
नो सर, ये क्या बोला है इसमें, विद इन 48 मंथ्स. आप इसको अप्लाई कर सकते हो, 1 महीने भी अप्लाई कर सकते हो. जैसे इस प्रोसीजर में मैंने बोला है, फॉर्म नंबर 1, 2, 3, 5 इज रेडी, देन गो विथ फॉर्म नंबर 9 एंड अलॉन्ग विद दैट गो विद द फॉर्म नंबर 18. विद इन दिस सिंगल एप्लीकेशन वी कैन गो फॉर द अर्ली एग्जामिनेशन आल्सो. Within 2 to 3 minutes, your examination is started, sir. And you will receive the mail regarding the objection also. Without objection, patent is never granted, sir. Why not? Objection is also there. Got it, sir?
Yes.
Yes. Okay. Now, next procedure is the copyright. So, copyright आप किसको कर सकते हो? That is also very, very important. Audio file, literature, architecture design, video and film, choreography, music, drama, picture graphics, computer code clusters. आप इस सभी चीजों को कॉपीराइट आप कर सकते हो. और मोस्ट ऑफ द टाइम आपने इस टाइप का लोगो दिखा होगा जिसके सर्कल के अंदर सी लिखा रहता है. दैट इज अ कॉपीराइट. ओके, कॉपीराइट विच इज द वेरी वेरी इंपॉर्टेंट. ओके, कॉपीराइट जो होता है, दिस इज रजिस्ट्रेशन. Remember one thing, copyright is what? Registering your idea. That is, does not mean that it is globally accepted. You are just registering your idea so that उस सर्टिफिकेट के ऊपर लिखा रहता है रजिस्ट्रेशन फॉर द कॉपीराइट. पेटेंट के ऊपर लिखा रहता है पेटेंट. ओके, आप एज अ साइंस पॉइंट ऑफ व्यू, केमिस्ट्री पॉइंट ऑफ व्यू, आप क्या क्या कर सकते हो? आप आइडिया कर सकते हो, एक्सप्रेशन कर सकते हो. इन सभी चीजों को आप कॉपीराइट कर सकते हो. एक एग्जांपल देखेंगे इसमें. आप केमिस्ट्री की बुक्स अगर आप लिख रहे होंगे तो आप उसमें भी आप कॉपीराइट कर सकते हो. सॉफ्टवेयर अगर होगा आपके पास तो आप सॉफ्टवेयर को भी आप कर सकते हो. जैसे यहाँ पर एक एग्जांपल दिया है, एटोडॉक वीना रैपर्स करके है. सोर्स कोड अगर है वो. स्मार्टफोन एप्लीकेशंस जो होते हैं, स्मार्टफोन एप्लीकेशंस को भी आप कॉपीराइट कर सकते हो. स्मार्टफोन एप्लीकेशंस पेटेंट नहीं होते हैं, याद रखना. स्मार्टफोन एप्लीकेशंस ओनली कॉपीराइट ही होंगे. अगर आप सपोज स्मार्टफोन एप्लीकेशंस के थ्रू अगर आप हार्डवेयर हैंडल कर रहे हो, then and then only it is a patentable. Okay, multimedia assets means what? आप अपना YouTube का लेक्चर, अच्छा टेल मी वन थिंग, आपके जो YouTube के लेक्चर्स होते हैं आप उसको कॉपीराइट कर सकते हो कि नहीं कर सकते हो?
Yeah, it is already copyright, sir.
Yes, you can go with the copyright. आपके जो YouTube के लेक्चर्स होते हैं आप उसको भी कॉपीराइट कर सकते हो। जैसे अभी आप में से कुछ पार्टिसिपेंट ने ये जो स्लाइड है इसके स्क्रीनशॉट लिए होंगे।
Yes.
हाँ, दिस इज अगेंस्ट कॉपीराइट, मैं आपके ऊपर ही केस रख दूंगा।
Yes, it is against copyright.
यस, नियर अबाउट 5 लाख का क्लेम होता है इसके ऊपर। ओके, बिकॉज दिस इज यूनिक, दिस इज द यूनिक। ये पीपीटी आप मैंने खुद ने बनाई है, तो सो दैट मेरी क्रिएटिविटी इसमें इन्वॉल्व हो चुकी है, तो सो दैट दिस इज द वेरी वेरी इंपॉर्टेंट। तो आप कॉपीराइट भी कर सकते हो। कॉपीराइट का क्या होता है, तो उसका वेरी सिंपल है ये। और रिमेंबर वन थिंग, कॉपीराइट सिर्फ और सिर्फ ऑनलाइन प्रोसीजर के थ्रू ही होती है। रिमेंबर, ऑफलाइन आप कॉपीराइट नहीं फाइल कर सकते हो। तो इसको क्या करना है? हाँ, यस
Sir,
सर। हाँ,
so what about the 40 years ago people publishing the papers in elsewhere and like that time no online, so how they did?
which okay. In copyright law, according to copyright law, there is one section that when you create your work, from that date itself is copyrighted. Do you know this term? For example, wildlife photographers are there. Okay, there is one wildlife photographer. That wildlife photographer shots near about 100 photographs. तो सो दैट वो 100 के 100 फोटोग्राफ्स को कॉपीराइट नहीं कर सकता है। तो सो दैट जिस दिन उसने पिक्चर निकाली है, फोटो निकाली है, और जिस दिन उसने फेसबुक पर डाल के जस्ट कॉपीराइट करके लिखा है, फ्रॉम दैट डेट इट इज अ कॉपीराइटेड, ये भी चलता है। डू यू नो दिस टर्म सर? एंड पब्लिकेशंस कंपनी, उन्होंने क्या बोला था कि जो भी हमारा जो मटेरियल जो भी आप पब्लिश कर रहे हो, इट इज अ कॉपीराइटेड फ्रॉम एल्सवेयर कंपनी या फिर वेले कंपनी या फिर जो भी कंपनी, उसके कॉपीराइट है, आपका कॉपीराइट नहीं होता है। दैट मीन्स आप अपने पेपर की जेरॉक्स कॉपी भी किसी दूसरे को दे नहीं सकते हो। दिस इज अगेंस्ट द कॉपीराइट लॉ। ओके सर?
Right.
यस। नाउ फॉर्म नंबर 1 इज देयर, ऑनलाइन फॉर्म। आपको फॉर्म नंबर फर्स्ट फॉर्म भरना पड़ेगा। देन आपको जो वर्क है वो सबमिट करना पड़ेगा। रिमेंबर वन थिंग, आप जिस वर्क को आप सबमिट करना चाहते हो, सपोज मैंने एक बुक लिखी है, 100 पेज की बुक है वो, तो उस बुक को पीडीएफ भी आपको अपलोड करना है। अलॉन्ग विथ दैट फीस भरने के बाद ये फॉर्म की प्रिंट आउट भी निकालना है आपको, और आपका जो बुक है उसकी आपको 2 प्रिंट आउट निकाल कर दिल्ली कॉपीराइट ऑफिस में भेजनी पड़ती है। रिमेंबर दिस टर्म। मोस्ट ऑफ द टाइम लोगों को लगता है कि उसको अपलोड कर दिया, फॉर्म भर दिया, फीस भर दी, सब कुछ हो गया। ऐसा नहीं होता है। आपको अपना काम भी आपको बाय पोस्ट, स्पीड पोस्ट से या फिर रजिस्टर्ड पोस्ट से दिल्ली कॉपीराइट ऑफिस में भेजना पड़ता है। ना यहाँ पर भी क्या होता है, आपका जो वर्क है ना, एक लिस्ट मंथली अपडेट होती रहती है। दैट इज, एक लिस्ट पब्लिश होती है वेबसाइट पर। अगर सपोज एग्जामिनर को लगता है कि ये थोड़ा बहुत इस टाइप का काम हो चुका है, तो वो रिजेक्शन में डाल देगा, या फिर इसको स्क्रूटिनी होता है, रिस्क्रूटिनी होता है, और वेरियस स्क्रूटिनी के बाद आपको मेल आएगा कि आपका वर्क जो है सक्सेसफुली रजिस्टर्ड हो चुका है, आप सर्टिफिकेट डाउनलोड कर सकते हो। रजिस्ट्रेशन इज क्लियर, आपका वर्क जो है वो सिर्फ और सिर्फ रजिस्टर्ड होता है। तो फीस कितनी लगती है उसकी, इट इज ऑल्सो इम्पोर्टेंट। लिटरेसी वर्क अगर है, आप बुक्स लिख ले हो, रिसर्च मोनोग्राफ से, लैब मैनुअल से, ब्लॉग से, उसकी फीस है ₹500 पर वर्क। अगर आप सॉफ्टवेयर प्रोग्राम अगर करते हो, दैट इज आप सॉफ्टवेयर बना रहे हो, प्रोग्राम बना रहे हो, वेब पोर्टल बना रहे हो, स्मार्टफोन एप्लीकेशंस बना रहे हो, उसके लिए भी 500 पर वर्क है। आर्टिस्टिक वर्क है, सपोज आपने फोटोग्राफ निकाला है, फ्लोरा है, सेटअप है, या फिर जो भी डिजाइन आप करते हो, डायग्राम अगर आप बनाते हो, उसको भी ₹500 पर वर्क है। सिनेमाटोग्राफिक फिल्म अगर आप बना रहे हो, जैसे वीडियो लेक्चर सीरीज आप रिकॉर्ड कर रहे हो, लैब का डेमोन्स्ट्रेशन है, उसके लिए 5000 पर वर्क रहेगा। और दूसरा है आर्टिस्टिक वर्क फॉर गुड्स एंड सर्विसेज, आप लोगो, कंपनी का लोगो भी आप बना सकते हो, लाइक एडिडास जो लोगो होते हैं ना, वो सभी लोगोस को भी आप 2000 रुपीज में भी आप उसको रजिस्टर्ड कर सकते हो। रिमेम्बर वन थिंग, ये लोगो वाला सेक्शन जो था ना, वो पहले यहाँ नहीं था कॉपीराइट में, बट लास्ट फ्रॉम 1 ईयर अभी इन्होंने भी यहाँ पर भी कर दिया। बिकॉज लोग क्या करते थे, मेरी अगर खुद की कंपनी अगर है तो मुझे अगर लोगो को अगर रजिस्ट्रेशन करना है तो मुझे इंडस्ट्रियल डिजाइन के थ्रू जाना पड़ता था मेरा लोगो। तो फिर मैं इंस्टेड ऑफ दैट क्या करता हूँ, मैं कॉपीराइट कर लेता हूँ, मेरा एक लोगो की इमेज ले लेता हूँ, कॉपीराइट कर लेता हूँ, 500 रुपये मेरा काम हो जाता था। बट अभी नया सेक्शन ऐड हुआ है, आर्टिस्टिक वर्क फॉर गुड एंड सर्विसेज। इसके लिए आपको 2000 रुपीज पर वर्क भरना ही पड़ता है। यहाँ पर आपको जस्ट एब्स्ट्रैक्ट ही लिखना पड़ता है। यहाँ पर नो नीड टू राइट द क्लेम, अगर आपको कुछ भी लिखना नहीं, प्रिसाइज इंफॉर्मेशन देनी पड़ती है विद इन 500 वर्ड, विद इन 200 वर्ड्स में। एंड इम्पॉर्टेंट इज आपको जस्ट वर्क ही अपलोड करना पड़ता है इन द फॉर्म ऑफ पीडीएफ, बाकी कुछ भी अपलोड नहीं करना पड़ता है।
सर
हाँ सर, हेलो सर।
yeah, actually sir, what about the Facebook, that surface sometime we posted something, one
Okay.
paragraph or two paragraph, I think it's a copyright, it's a copyright, yeah.
Yes, sir.
And
Yes, sir. Yes, sir.
nobody
There
can
is
use, if someone use, so it's a penalty there.
no, sir. No, sir. No, sir. For penalty, you should have one legal document,
Okay.
and that Facebook screenshot is not a legal document, sir.
Yeah, see.
Okay. Why we are doing the copyright? Just we want one legal document. If suppose you post one photograph which is captured by you in your chemistry lab, and you think that this is the uniqueness, and when you post it on the Facebook from that date, that here is also date of priority also is very, very important. Suppose that photo was posted today, that is 8th July, and you are filing the copyright on the 10th July, and if someone is doing use that photo for their own work, so in that time you can claim it from the priority date, that is 8th July. That is also important, sir. But for that we need a one legal document so that there is a copyright registration.
Sometimes we write the post, it's a one paragraph or two paragraph, sometimes it's stories.
Yes,
If you write, so
yes.
it is also, it's a copyright there, yeah.
Yes, sir. No, sir. What is the copyright law? From the date of creation, that work itself is copyrighted. Remember this. When you post your poem or a story on the Facebook, from that time, from that date, that entire work is copyrighted with you. But Facebook never provide a certificate. How you can
Okay.
claim that? How
Okay.
you
नहीं,
can claim that?
एक्चुअली मैंने देखा है समटाइम्स कोई किसी का स्टोरी लेता है या कोई चीज लेता है तो लिखता है कि फ्रॉम दैट गाइज वॉल या समथिंग लाइक दैट, या इट इज
हाँ
ये वहां से कॉपी है, लिखते हैं लोग लास्ट में।
हाँ, लिखते सर, उसको कुछ नहीं होता है सर। मैं
अच्छा
आपको
अच्छा।
मैं आपको लास्ट में कुछ लॉज भी बताऊंगा जहां पर आप यूज कर सकते हो इस सब चीजों पे। एक लॉ है उसमें भी, आपको कोई कुछ नहीं बोलेगा सर अगर आप।
अच्छा।
हाँ होता है, मैं बताता हूँ वो कैसा होता है। नेक्स्ट वन इज द इंडस्ट्रियल डिजाइन। ओके, इंडस्ट्रियल डिजाइन। रिमेम्बर वन थिंग, आपने देखा होगा आपके बहुत सारे कलीग्स ने इंडस्ट्रियल डिजाइन रजिस्ट्रेशन सर्टिफिकेट लिया होगा, आइदर फ्रॉम यूके, यूनाइटेड किंगडम से लिया होगा या फिर इंडिया से लिया होगा। तो ध्यान में रखिए, इंडस्ट्रियल डिजाइन इटसेल्फ इज अ रजिस्ट्रेशन सर्टिफिकेट, ये पेटेंट नहीं होता है। रिमेम्बर दिस थिंग विच इज द वेरी वेरी इंपॉर्टेंट। इंडस्ट्रियल डिजाइन इज आल्सो गोइंग फॉर रजिस्ट्रेशन। जो आपका वर्क है वो किसी ने चुराना नहीं चाहिए, इसलिए आपने उस वर्क को रजिस्टर्ड करके रखा है। कंपनी आपके तरफ आएगी नहीं। अगर आपका पेटेंट ग्रांट है तो कंपनी आपके तरफ आएगी।
तो जैसे सर समटाइम्स वी सबमिट द पेपर इन दैट that site is there, just we inform there, and after that
Okay.
you can submit somewhere.
Yes.
Archive.
Archive. Yes, you can submit, sir. You can do it.
Like that, it is just.
Yes.
State registration, it's not a.
Yes. मोस्ट ऑफ द ज्वेलरी की जो डिजाइन होती है, आपने देखा होगा एक ज्वेलर की डिजाइन दूसरे ज्वेलर के साथ मैच नहीं होती, बिकॉज आफ्टर द डिजाइन, जैसे ही डिजाइन हो जाता है ज्वेलर्स का सेट, पर्टिकुलर कोई भी ऑर्नामेंट्स, उसको इमीडिएटली इंडस्ट्रियल डिजाइन के अंडर रजिस्टर्ड किया जाता है, विच इज द वेरी इंपॉर्टेंट। ये पता होना चाहिए। बहुत बार मिस गाइड किया जाता है, इंडस्ट्रियल डिजाइन को ही पेटेंट ग्रांट करके दिया जाता है। आपने देखा होगा बहुत सारे लोगों ने जर्मन का भी पेटेंट लिया होगा, दैट इज नॉट यूजफुल एट ऑल, नैक में चलता नहीं है। यूनाइटेड किंगडम का भी इंडस्ट्रियल डिजाइन रजिस्ट्रेशन किया होगा, जिसके 30,000 फीस भरी होंगी। इंडिया में 1,000 में इंडस्ट्रियल डिजाइन रजिस्ट्रेशन हो जाता है। बट देन एज अ स्टूडेंट पॉइंट ऑफ व्यू, दिस इज द वेरी इंपॉर्टेंट।
तो सर एक क्वेश्चन यहाँ पर मेरा,
हाँ
तो सर जो रजिस्ट्रेशन का सर्टिफिकेट
हाँ
अलग होता है जिसपे नंबर पड़ा रहता है समथिंग, और
हाँ
जो
हाँ
फाइनली जो पेटेंट हो जाता है उसका येलो कलर का होता है क्या वो,
हाँ
जिसपे
हाँ
पट्टी लगी रहती है?
हाँ मैं आपको बताऊंगा सर, वो
ओके
एग्जांपल है मेरे पास।
ओके।
ओके, ठीक है। सो इंडस्ट्रियल डिजाइन इज अगेन ओनली फॉर द रजिस्ट्रेशन इंडस्ट्रियल, और रिमेंबर वन थिंग, इंडस्ट्रियल डिजाइन रजिस्टर्ड करने के बाद आप उसको पेटेंट फाइल कर नहीं सकते हो, वो भी अलग एक रूल है। मैं आपको रूल बताऊंगा, सभी रूल्स बताऊंगा, वो आपको पता होने चाहिए रूल्स। ओके, नाउ अगर मुझे करना है इंडस्ट्रियल डिजाइन में, अगर मुझे इंटरेस्टेड है तो मैं क्या कर सकता हूँ? तो मैं एक टीएलसी apparatus का एक फिजिकल लेआउट बना देता हूँ, उसका विजुअल शेप्स कुछ अलग रखता हूँ मैं। तो मैं इसको इंडस्ट्रियल डिजाइन रजिस्ट्रेशन में डाल सकता हूँ, या फिर स्पेक्ट्रोफोटोमीटर का मैं जो एर्गोनॉमिक एक्सटीरियर जो है उसको थोड़ा सा चेंज करता हूँ, तो ये भी मेरा इंडस्ट्रियल डिजाइन रजिस्ट्रेशन में जा सकता है। ये जो दो एग्जांपल्स है यहाँ पर, टीएलसी एंड स्पेक्ट्रोमीटर, दैट इज लेबोरेटरी हार्डवेयर में आप जा सकते हो। बट टीएलसी apparatus के अंदर अगर मैंने एक मशीन को कनेक्ट कर दिया है, वो मशीन itself उस क्रोमेटोग्राफिक सेपरेशन को कैरी कर रही है, इस प्रोसेस को मैं पेटेंट फाइल करूँ, और बाहर वाले डिजाइन को मैं करूंगा इंडस्ट्रियल डिजाइन रजिस्ट्रेशन। सबको समझ में आ रहा है? एक एग्जांपल है सबसे लास्ट, दीज आर द फीस अकॉर्डिंग टू 2026। अभी फीस इन्होंने इंडियन पेटेंट ऑफिस ने फीस बहुत ज्यादा रिड्यूस कर चुकी है। तो देखो, अगर आप सपोज इंडिविजुअल है, स्टार्टअप है, या फिर एजुकेशनल इंस्टीट्यूट अगर है, अगर आप ऑफलाइन फाइल कर सकते हो तो आपको फॉर्म नंबर 1 भरना पड़ेगा, उसके 1,000 फीस। ओके, अलॉन्ग विद दैट आपको फॉर्म नंबर 24 भी भरना पड़ेगा, जिसकी फीस नहीं, दैट मीन्स फॉर्म नंबर 1 और फॉर्म नंबर 24, ये दोनों फॉर्म फिलअप करो, 1,000 रुपये का डीडी लगा दो, आपका डिजाइन रजिस्टर्ड हो जाता है। ओके, बट फॉर्म नंबर रिन्यूअल इज ऑल्सो देयर। आपको आपकी जो डिजाइन होती है, आपको उसको रिन्यू करना पड़ता है। कोई बता सकता है मुझे इंडस्ट्रियल डिजाइन को कब रजिस्टर रिन्यू करना पड़ता है?
सर आफ्टर 5 years और 7 years।
और कोई बता सकता है?
After 10 years.
ओके, एनीवन? आफ्टर 10 years, आप 10 साल के बाद इसको रिन्यू कर सकते हैं। और
अगर
अगर
नहीं
आप
किया तब?
नहीं किया तो आपका जो डिजाइन है पब्लिकली ओपन हो जाता है, कोई भी यूज कर सकता है उसको सर, फिर आपका क्लेम
अच्छा,
नहीं बनेगा।
सो वी हैव टू पे द अगेन मनी।
यस 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 यस, मैं आपको एक कंपैरेटिव स्टेटमेंट ही देता हूँ ना सभी का, कहाँ पर प्रॉब्लम है, कहाँ पर लॉस होता है। ओके,
हम्म।
नेक्स्ट, दिस इज द जियोग्राफिकल इंडिकेटर्स का एग्जांपल, नवारा राइस, कश्मीरी सैफरॉन। आप इसमें भी कुछ चेंजेस कर सकते हो, या फिर इसमें कुछ नया फाइटोकेमिकल्स अगर होगा इसमें तो अभी फाइंड आउट कर सकते हो, तो आप उसको भी कर सकते हो जियोग्राफिकल इंडिकेटर्स में। प्रोसेस कौन सी होती है जियोग्राफिकल इंडिकेटर्स की? देखो 80% फीस जो है वो रिड्यूस हो चुकी है। आपको फॉर्म नंबर 1 GI 1 सबमिट करना पड़ता है, रजिस्ट्रेशन GI 3 भी करना पड़ता है, और आफ्टर 10 साल के बाद उसको रिन्यू भी करना पड़ता है। ठीक है, तो ये भी आप कर सकते हो। यहाँ पर मैंने एक एग्जांपल दिया है, ट्राई एंटी कैंसर और एंटी डायबिटिक मेटाबोलाइट्स ऑफ अ प्लांट अराउंड द लोनार लेक। लोनार लेक जो है उसके आजू बाजू में जो कुछ प्लांट्स मिलते हैं उसके फाइटोकेमिकल्स काफी यूनिक है। ऐसे फाइटोकेमिकल्स बाकी किसी रीजन में आपको नहीं मिलते हैं, वो आप फाइंड आउट करो, आप उसका ज्योग्राफिकल इंडिकेटर्स आप ले सकते हो। रिमेंबर वन थिंग, इसका कैश प्लेसमेंट में आपको बेनिफिट कुछ नहीं मिलेगा, बट वेन एवर दैट मेटाबोलाइट्स आर यूज्ड, वहां पर मेंशन होगा कि इस इंसान ने इसको ज्योग्राफिकल इंडिकेटर करके दिया। दैट इज ऑल्सो
सर आई हैव वन क्वेश्चन हियर।
ओके।
सर बीच में एक मामला आया था कि ये गाय का गोबर और जो मूत्र है ये पेटेंट नहीं था, इंडियन पेटेंट नहीं था, ये कुछ ऐसा मामला बीच में आया था।
यस सर। सर
तो
अभी एक बात बताइए, काउ यूरिन एंड काउ डंक, इसमें नॉवेल्टी क्या है?
नॉवेल्टी तो बाबा रामदेव जी बता रहे हैं, उसमें ये है वो है, दुनिया भर की बीमारी सही हो रही है।
तो अगर तो अकॉर्डिंग टू इंडियन पेटेंट लॉ, मेडिसिनल एप्लीकेशंस ये पेटेंटेबल ही नहीं है इंडिया में। एंड
अच्छा।
व्हाट, हाँ, एंड व्हाट इज द पेटेंट सर? इन आयुर्वेदा ऑलरेडी मेंशन किया गया है। तो आपने देखा होंगे फर्स्ट स्लाइड में मैंने वहां पर लिखा था कि आयुर्वेदा वाला
सर
कोई भी हाँ।
सर फिर तो बासमती में, हल्दी में, जिनको ये यूएस पेटेंट कराना चाह रहा था, खासतौर पे हल्दी और नीम का,
हाँ
उसमें
हाँ
भी नॉवेल्टी तो उसमें भी नहीं हुई फिर।
सर, आप अगर उस टर्म को अगर आप अच्छे से देखोगे, टर्मरिक वाले केस में उन्होंने टर्मरिक को पेटेंट किया है कि टर्मरिक ग्रो करने के प्रोसेस को किया है? बिकॉज सर टर्मरिक ये पेटेंट नहीं होगा, ये ज्योग्राफिकल इंडिकेटर में ही जाएगा, वायगावची हर्ड।
अच्छा, नीम की पत्ती का भी मामला था कि नीम जो है इंडिया का प्लांट है, इसको जो है यूएस वाले शायद पेटेंट करने वाले समथिंग।
नहीं 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 सर, ये सब होता ही नहीं है सर। अभी
अच्छा।
हाँ, अभी आपको मैंने आईपीआर का लेक्चर दिया तो आपको कुछ टर्म समझ में तो आई होगी।
नहीं नहीं सर, आ रहा है।
जैसे फॉर एग्जांपल कड़ू नीम जो होता है, अजाडेरा का इंडिका है उस पेड़ का नाम।
हम्म।
मैंने अफ्रीका कंट्री का भी काम किया, वहां पर भी ये प्लांट अवेलेबल है।
अच्छा।
वहां पर भी अवेलेबल है, जिम्बाब्वे में भी अवेलेबल है, तो फिर इसको पेटेंट कैसे करेंगे अपन?
अच्छा।
हाँ, कांजीवरम साड़ी सर, सपोज आपने कांजीवरम साड़ी फर्स्ट टाइम बनाई थी, राइट? फॉर
हम्म।
एग्जाम्पल कांजीवरम साड़ी आपने बनाने के बाद, बट वो कांजीवरम साड़ी आपके नाम से थोड़ी रजिस्टर्ड है, कांजीवरम साड़ी उस पर्टिकुलर एरिया के नाम पर ज्योग्राफिकली इंडिकेटर है।
राइट राइट।
ओके सर, तो कड़ो नीम का जो होता है, वो अगर सपोज अपने ही एरिया में, सपोज मेरे नागपुर में अगर मिलता तो मेरे नागपुर को नाम मिलता उसका, बट वो
बिल्कुल।
ग्लोबली कहीं पर भी अवेलेबल है। तो इन लोगों ने क्या क्लेम किया है, दैट इज ऑल्सो इम्पोर्टेंट। हल्दी वाले केसेस में उन्होंने फाइटोकेमिकल्स को क्लेम किया है क्या, जो अभी तक हुआ नहीं है? वो होगा सर पेटेंट, और वो भी यूएस पेटेंट होगा, इंडिया पेटेंट नहीं करेगा।
अच्छा।
हाँ, उसका भी रीजन बताऊंगा मैं आपको, और एक सामने रीजन है। जैसे आपने क्वेश्चन पूछा था कि पेटेंट सर्टिफिकेट और सर्टिफिकेट ऑफ रजिस्ट्रेशन डिजाइन में क्या डिफरेंस होता है, यहाँ पर स्क्रीन में देखो, दोनों भी सर्टिफिकेट मैंने अपलोड करके रख दिए हैं।
अच्छा।
हाँ, इस सर्टिफिकेट में देखो सर, फर्स्ट वन सर्टिफिकेट में अभी कलर चेंज हो रहे हैं, मे बी इनके कलर अभी चेंज हो रहा होगा। सभी केसेस में लोग मिसगाइड कहाँ पर होते हैं, कंफ्यूज कहाँ पर होते हैं, तो देखो सबसे ऊपर पेटेंट कार्यालय लिखा है, पेटेंट
हम्म।
कार्यालय, और यहाँ पर भी देखो पेटेंट कार्यालय ही है, दोनों भी केसेस।
सर एक क्वेश्चन है, ये जो फर्स्ट वाला है इसको अगर हम पेटेंट करते हैं तो यहाँ तक पहुंचने से पहले एक दूसरा मिलता है जिसपे वो इस टाइप का नहीं होता है।
और वो
उस
पेटेंट पब्लिकेशन है।
हाँ राइट राइट सर, उसके कितने दिनों बाद ये मिलता है, दिस वन फर्स्ट वन?
फर्स्ट वन जो है सर, विद इन 6 मंथ आपको मिल जाएगा, या अगर आपने सपोज अर्ली पब्लिकेशन फीस भर दी तो आपको वो 1 महीने में ही मिल जाएगा।
एक्चुअली हमने पेटेंट किया था तो उसका सर वही वाला पेज मिला है, और
हाँ,
ये
जो
वाला अभी
काम,
तक मिला नहीं।
हाँ वो काम का नहीं है सर।
हाँ, वो काम का नहीं है वो, राइट।
नहीं, पेटेंट पब्लिकेशन काम का ही नहीं, बिकॉज क्या है सर, इसमें देखो क्या लिखा रहता है, पेटेंट नंबर है, एप्लीकेशन नंबर, आपको जो मिला
हम्म।
है वो एप्लीकेशन नंबर ही है अभी तक, आपको पेटेंट नंबर नहीं मिला है।
नहीं मिला है, राइट राइट।
और यहाँ पर देखो लिखा रहता है सर कि 20 ईयर्स के लिए आपका पेटेंट ग्रांटेड है,
अच्छा।
20 ईयर्स, और यहाँ पर वर्ड है सर, हैज बीन ग्रांटेड। और ये देखो इन्होंने अप्लाई कब किया, 2024 को, इनको मिला कब, 2025 को। 1 साल में सर, कम से कम 1 साल में पेटेंट मिलता है। बट इस सर्टिफिकेट में देखिए सर क्या है, ये सर्टिफिकेट में यहाँ पर लिखा है सर, सर्टिफिकेट ऑफ रजिस्ट्रेशन ऑफ डिजाइन। यहाँ पर कहीं
अच्छा।
पर भी वर्ड नहीं आएगा कि आपका वर्क रजिस्टर्ड हो, ग्रांट हो चुका है करके। लोग कहाँ पर थोड़ा मिसगाइड होते, पेटेंट, यहाँ पर भी पेटेंट है, यहाँ पर भी पेटेंट। अरे ये पेटेंट ऑफिस है, नीचे देखो क्या लिखा है। दिस इज द इम्पॉर्टेंट सर। और ये
हॅलो
वाली,
सर.
हाँ हॅलो.
हा सर, पण मग याच्यामध्ये जे आहे आता हा येलो जे आहे दिसतंय आपल्याला, तर
हम्म.
ते डिझाईन पेटंट आहे ना.
हो डिझाईन पेटेंट आहे सर.
आणि
त्याला
डिझाईन
डिझाईन,
पेट
सर सर
हा
सर,
हा
त्याला डिझाईन म्हणतात, त्याला डिझाईन पेटंट नाव नाही सर.
ओके ओके.
त्याला डिझाईन पेटंट म्हणून आपणच
पण
म्हणत असतो.
पण हे पेटंट मध्ये येतं ना. This is-
नाही सर, नाही नाही, ते पेटंट मध्ये येत नाही. हे
ओके.
IPR मध्ये येते सर.
आणि मग जे डिझाईन पेटंट असतं मग याच्यात आणि त्याच्यात काय फरक आहे?
सर हे बघा, मी सगळ्यात पहिले सांगतो. डिझाईन जिथे वर्ड येतो ना सर, तो पेटेंट नसतो, त्याला युटिलिटी पेटंट म्हणतात. युटिलिटी पेटंट म्हणजे बाजूचं.
अच्छा.
हे याला याला इम्पॉर्टन्स आहे सर, याला नाही आहे सर. इथे काय केलं
म्हणजे
सर
हे
तुम्ही?
पेटंट नाहीये असं.
हा हे पेटंट नाही आहे सर. तुम्ही बघितलं असाल तुमच्या आजूबाजूच्या कलिग्सने असे सर्टिफिकेट खूप जमवले असतील.
हो सर. येस.
So,
माझ्या
but
आज
we can
7
get the API score
No, sir.
from
No, sir.
no.
No, no, no. You will get the API score only from the patent granted certificate only.
So
Not
left side one.
Yes, left side one. This one. You are never getting the marks for this. Sir,
What about patent published?
No, sir.
Patent green wala IP.
Green wala is industrial design only. Sir, one thing is remember.
Okay.
और इसका शॉर्टकट में बता देता हूँ मैं. पेटेंट ग्रांट होने के लिए कम से कम आपको 30 से 40 हजार लगेंगे सर, और कम से कम आपको 1.5 साल लगता है. पेटेंट सॉरी इंडस्ट्रियल डिजाइन रजिस्ट्रेशन के लिए आपको कम से कम 2,000 लगते हैं सर, और ये विद इन 5 to 3 months में ही ग्रांट हो जाता है. तो इसमें एफर्ट्स कहाँ पर ज्यादा हो रहे हैं, वो आपको कैश प्लेसमेंट में दिया जाएगा सर. दैट इज अ पेटेंट ग्रांट. मेरे खुद
Hello,
के
sir. I have one
हाँ
question.
हाँ.
In UGC guidelines, it is mentioned their patent published also for getting the marks for case.
Do you have that copy, sir?
Yes, sir.
Because in our Maharashtra state, they are only for the granted patents, sir. I will show that a screenshot is also there with. So यहाँ तक क्लियर हो गया सभी को. So टाइटल कभी भी याद रखना, सर्टिफिकेट ऑफ रजिस्ट्रेशन ऑफ डिजाइन, और ये है पेटेंट प्रमाण पत्र. दिस पेटेंट प्रमाण पत्र इज वेरी वेरी इंपॉर्टेंट बिकॉज ये 20 साल तक ग्रांट होता है, ये 10 साल तक ही होता है. दिस इज द इम्पोर्टेंट. इन्होंने फाइल कब किया था? 2016 को. एक प्रॉब्लम आ गया तो इसलिए 2017 में है, और इनको ग्रांट हुआ 2018 में. तो डेट देखो सर.
But 10 years it is not mentioned.
हाँ
हॅलो सर.
ये सर, हाँ ये
सर.
पुराना है सर. हाँ सर.
परत माझा असा एक प्रश्न आहे अजून. आता मी एक काम केलेलं आहे की अँटीबॅक्टेरियल ड्रग वरती काम केलेलं आहे, आणि त्याच्या ऍक्टिव्हिटीज MIC वगैरे सगळं मी व्यवस्थित चेक केलेलं आहे. आणि मग मला आता त्याला पेटंट ग्रांट साठी जायचं आहे. तर मग याच्यात काय प्रोसिजर असणार आहे नेमकी, कशा पद्धतीने गेलं पाहिजे?
सांगतो सर, ते सांगतो सर, सांगतो. थोडा आपण हिंदीत बोलूया त्याच्यासाठी, बाकीची आहे.
येस येस सर.
हा प्रॉब्लेम सगळ्यांचा असतो, तो पण मी सॉल्व्ह करतो तुमचा. ठीक आहे.
येस.
ऍट द लास्ट अपन जाओ थे. नाउ पेटेंट वर्सेस कॉपीराइट. रिमेंबर वन थिंग, पेटेंट जो होता है उसका 20 ईयर्स तक की वैलिडिटी होती है. आपको 1 साल के बाद उसकी रिन्यूअल फीस भरनी पड़ती है. अगर आप रिन्यूअल फी नहीं भरते तो आपका पेटेंट जो है वो पब्लिकली ओपन हो जाता है. ध्यान में रखना, पब्लिकली ओपन मीन्स व्हाट, पब्लिकली वो ओपन होकर लोग उसको यूज कर सकते हैं. एग्जाम्पल इज कोडैक कैमरा. जब अपन छोटे थे तो वहां पर एक ही कैमरा था, कोडैक. बट कोडैक के बाद आज देखो, आज मल्टीपल कंपनीज के कैमरे आ चुके हैं. कोडैक कहीं पर भी नहीं है, बिकॉज 20 ईयर के बाद कोडैक कंपनी का पेटेंट, उसकी आइडिया पब्लिकली ओपन हो चुकी है. बट यहाँ पर कॉपीराइट का कुछ अलग है. कॉपीराइट जो होता है आफ्टर लाइफ टाइम, आफ्टर द डेथ ऑफ ऑथर भी यहाँ पर आपको मिलता है. दैट इज 60 ईयर्स तक भी आपको मिलता है. ओके. कुछ कुछ फैक्टर्स में आपको 60 साल तक मिलेंगे. बट अगर आपने सपोज एक बुक ली आफ्टर द डेथ ऑल्सो, जो अपने बाद जो रहेंगे सिबलिंग्स वगैरह जो भी रहेंगे, उनको भी बेनिफिट्स मिलता रहेगा. दिस इज द कॉपीराइट. रिन्यूअल फीस जो होती है पेटेंट में, आपको हर बार रिन्यूअल फीस भरनी पड़ती है फ्रॉम द 3rd ईयर ऑनवर्ड्स. बट कॉपीराइट्स में आपको कभी भी रिन्यूअल फीस भरनी नहीं पड़ती है. दिस इज द इम्पोर्टेंट. ये एक एग्जाम्पल है, इस एग्जाम्पल के थ्रू थोड़ा समझ लेते हैं. ठीक है. मैंने यहाँ पर एक सोफिस्टिकेटेड एक पोर्टेबल एक डिवाइस बनाया है, जिस डिवाइस के थ्रू मैं फाइटोकेमिकल्स का एनालिसिस कर सकता हूँ। दैट मीन्स ये फाइटोकेमिकल्स के मैं एंटी बैक्टीरियल एंटी माइक्रोबियल में यूज कर सकता हूँ यहाँ पर। बट यहाँ पर यूनिकनेस इज व्हाट, इस डिवाइस को बनाने के लिए मैंने मोस्ट ऑफ द फाइटोकेमिकल्स की सर्च किया है। जैसे फॉर एग्जांपल कश्मीरी सैफरॉन को ही मैंने यूज किया है। तो अगर सपोज ड्यूरिंग दैट कश्मीरी सैफरॉन जो उसका फाइटोकेमिकल्स अगर रिस्पॉन्सिबल हो रहा है कि वो एंटीबैक्टीरियल वगैरह शो करता है, और ये इस टाइप का फाइटोकेमिकल्स इंडिया में ग्लोबली कहीं पर भी नहीं है, ओनली ऑब्जर्व इन द कश्मीरी सैफरॉन, फिर वो फाइटोकेमिकल्स मेरा जियोग्राफिकल इंडिकेटर्स में जाएगा। ये टर्म समझ में आ गई? आर यू गेटिंग इट?
यस यस।
ओके, नाउ नेक्स्ट वन। यहाँ पर इस इंस्ट्रूमेंट पे सोफिस्टिकेटेड ऐप को रन करने के लिए मुझे सॉफ्टवेयर बनाना पड़ेगा, कोडिंग करना पड़ेगी। तो ये जो सॉफ्टवेयर और कोडिंग जो हो रही है, ये मेरा पेटेंट में नहीं जाएगा, ये किस में जाएगा? मेरा कॉपीराइट में जाएगा। यहाँ पर लिखा है कॉपीराइट सॉफ्टवेयर सोर्स कोड यूजर मैनुअल एंड एक्सप्लेनेशन। जस्ट दैट मीन्स इसके साथ जो यूजर मैनुअल्स की भी जो प्रिंट आउट निकालते हैं अपन, वो भी कॉपीराइट होगा। गॉट इट? कोड बुक ये इसमें जाएगा। दूसरा फैक्टर, अभी ये जो डिजाइन जो आपको दिख रही है, ये यूनिक डिजाइन है। सच टाइप ऑफ डिजाइन यहाँ पर देखोगे आप, बड़ी सी स्क्रीन लगी हुई है, देयर इज वन चार्जिंग पोर्ट इज आल्सो देयर, क्यूएड भी रखा है मैंने वहां पर। इस टाइप की डिजाइन जो है ये किसी ने यूज नहीं करनी चाहिए, दैट शुड बी द यूनिक। तो सो दैट मैं इसको करूंगा इंडस्ट्रियल डिजाइन, हाउ इट लुक्स, विजुअल शेप अपीयरेंस। ओके, बट सबसे इंपॉर्टेंट, ये किस वे से वर्क करता है। सपोज मैंने एक इसका ड्रॉप लिया है और उस ड्रॉप को मैंने उस स्लिट में रख दिया है, पेपर चिप मैंने यूज किया है। आफ्टर पासिंग अ पर्टिकुलर करंट, जो भी प्रोसेस होती है उस प्रोसेस के थ्रू मुझे रिजल्ट मिलता है, उस प्रोसेस को उस मैकेनिज्म को मैं करूंगा पेटेंट। दैट इज द फर्स्ट वन। तो विद एक एग्जांपल में मैंने आपको तीनों चारों भी टाइप्स मैंने समझा के दिए। यहाँ पर किसी को डाउट है?
सर
यस।
इसका मतलब कि सर जो ये मोबाइल है, मोबाइल फोन है, ये
हाँ
सबकी लंबाई चौड़ाई सबका अलग अलग, हर कंपनी का अपना होगा, ये सेम
हाँ
नहीं
हाँ,
होगा?
सेम नहीं होगा,
थोड़ा बहुत अंतर जरूर होगा।
थोड़ा बहुत अंतर होगा।
अच्छा, ये डिजाइन में आएगा सर?
ये डिजाइन में आएगा, ये डिजाइन में आएगा सर। और उसके अंदर जो एप्स होते हैं वो कॉपीराइट में जाएगा।
अच्छा अच्छा,
बट
ये जो ऐप होते हैं सर,
माइक्रो, हाँ
मोबाइल में जितने ऐप होते हैं सब ये कॉपीराइट में आएंगे?
हाँ, कॉपीराइट में आते हैं सर। मेरे खुद के 74 ऐप है सर, वो सभी के सभी कॉपीराइटेड है।
ओके ओके।
हम्म। आप गूगल प्ले स्टोर पर सारंग धोटे सर्च के नियर अबाउट 74 ऐप्स को दिखेंगे।
देखिए मोबाइल का पूरा जिस कंपनी का ये, वो इसको इस सेट को, इस मॉडल को पेटेंट कराती होगी?
नहीं सर, मोबाइल के अंदर
हाँ
सिलिकॉन चिप जो होती है वो
हाँ।
पेटेंटेड है।
अच्छा
बट वो बाहर से दिखता कैसे है, वो इंडस्ट्रियल डिजाइन है।
अच्छा।
और उसके अंदर जो प्रोसेस करने के लिए जो ऐप यूज हो रहे, हर एक ऐप इस कॉपीराइटेड है सर।
ओके।
आपका जो व्हाट्सएप है वो कॉपीराइटेड है।
और वो कॉपीराइट लिखा रहता है उस पे?
हाँ, वो कॉपीराइटेड है।
हम्म।
आपके मोबाइल फोन पर कभी भी कॉपीराइट वगैरह लिखा नहीं रहता है, वो इंडस्ट्रियल डिजाइन है सर। जैसे
अच्छा
पीछे
अच्छा।
वाले फोन, पीछे वाला फोन का कैमरा, हर एक फोन का कैमरे की सेटिंग डिस्प्ले अलग है सर। पीछे वाला
बिल्कुल
कैमरे की
बिल्कुल।
लेंसेस, कोई डायगोनली
हम्म।
रखता है, कोई बीच में रखता है, ये सभी इंडस्ट्रियल डिजाइन में जाती है सर।
बटन भी सर, वॉल्यूम किसी में ऊपर, किसी में नीचे, किसी में बीच में, किसी में
हाँ
बाएं, किसी में दाएं।
हाँ, यस यस। अभी ये जो आपके सामने जो स्क्रीन दिख रही है, इसमें मैंने क्यूएट ऊपर रखी है सर, राइट? मे भी
राइट
पॉसिबिलिटी है
राइट।
कोई क्यूएट साइड में लटका दे,
हाँ हाँ बिल्कुल बिल्कुल।
बट वो मेरी प्रोसेस यूज नहीं कर पाएंगे। क्यों? क्योंकि मैंने उसको पेटेंट किया है।
राइट।
वो सिर्फ इस बॉक्स को चेंज कर सकते हैं, बट मेरी आइडिया को नहीं ले सकते, उसमें मॉडिफाई कर सकते हो।
हम्म।
ठीक है सर। ओ,
यस।
हाँ, ओके। आफ्टर आयपीआर सर, एक प्रश्न तुमचा अँटीबॅक्टेरियल ड्रगचा.
हाँ
हॅलो
यस।
सर, नाउ सी, आपण जो आपने जो ड्रग बनाया है फाइटोकेमिकल से, या फिर जो भी जिससे भी आपने बनाया है, उसमें आपने जो लैब टेस्टिंग की है ना सर, अगर आप क्लेम करते हो उसको कि मेडिसिनल एप्लीकेशंस में है, तो आपका मेयरली दैट मीन्स वो आइडिया जो है रिजेक्ट ही होती है। बट अगर अगर सपोज आप उसको ऐसा बोलते हो कि इट इज अ न्यू मॉलिक्यूल सिंथेसाइज्ड, तो फिर ये पेटेंट होने के ज्यादा चांसेस होते हैं इसकी।
Yes, yes.
दिस इज द वन थिंग, बिकॉज पेटेंट लॉ के हिसाब से, इंडियन पेटेंट लॉ के हिसाब से, मेडिकल इंस्ट्रूमेंट इज नेवर पेटेंटेड। मेडिकल इंस्ट्रूमेंट की बात कर रहा हूँ मैं सर।
Yeah.
जैसे अगर सपोज मैंने एक MRI स्कैनर मशीन बना दी है और उसको अगर मैं पेटेंट फाइल करने जाऊंगा तो पेटेंट होता नहीं। व्हाट इज द लॉजिक? ये MRI स्कैन मशीन के अंदर जो प्रोसेस हो रही है हर एक डॉक्टर यूज कर सके इजीली, उसके कोई चार्जेस ना दे सके, इसलिए फ्री होनी चाहिए, लाइक दैट। चलो लास्ट लास्ट टॉपिक इज आफ्टर IPR, that is a TTA and KTA. How many of you know this term TTA and KTA?
No, sir.
Okay, that point of view, this is a very, very important term. And another one thing is that ओनली पेटेंट ग्रांट सर्टिफिकेट आपके पास रह के कुछ भी वैल्यू नहीं होती है, उसको आपको और एक जगह सामने लेकर जाना पड़ता है। उसके लिए फर्स्ट टर्म आती है TTA, दैट इज टेक्नोलॉजी ट्रांसफर एग्रीमेंट। टेक्नोलॉजी ट्रांसफर एग्रीमेंट होता है। सेकंड वन इज द नॉलेज ट्रांसफर एग्रीमेंट, TTA। नॉलेज ट्रांसफर, ये दोनों भी टर्म्स आपको NAC के थर्ड क्राइटेरिया में मिलेंगे। दैट मीन्स आपका पेटेंट ग्रांट हो चुका है, बट पेटेंट ग्रांट होने के बाद कितनी कंपनियों ने उस पेटेंट को, उस आइडिया को अपने कंपनी में इंस्टॉल किया है, दैट इज उसके साथ एग्रीमेंट साइन हुआ है। दैट इज द वेरी वेरी इंपॉर्टेंट। नाउअडेज स्टूडेंट को ये टर्म्स आपको समझानी पड़ेंगी। व्हाट इज द TTA, टेक्नोलॉजी ट्रांसफर एग्रीमेंट करना पड़ेगा आपको। इसका एक एग्जांपल देता हूँ। मेरा कॉलेज का एक स्टूडेंट है जहाँ पर हमने AI प्रोटोटाइप बनाया था। उस AI प्रोटोटाइप को हमने 8 डिफरेंट कंट्रीज में इंस्टॉल करके दिया था। फिर वन ऑफ द कंपनी ने हमको अप्रोच किया। उस कंपनी ने बोला कि आपका जो पोर्टल है हमें वो काफ़ी अच्छा लगा, हमको भी ऐसा चाहिए। तो जस्ट बिफोर दैट हमने उस AI प्रोटोटाइप का कॉपीराइट लेकर रखा था, एक लीगल डॉक्यूमेंट हमारे पास था, इसलिए नो वन कैन कॉपी इट, उसको कोई कॉपी नहीं कर सकता था। उस स्टूडेंट के साथ उस कंपनी ने आज TTA ट्रांसफर एग्रीमेंट, टेक्नोलॉजी ट्रांसफर एग्रीमेंट साइन हो चुका है। उस स्टूडेंट को, जस्ट वो ग्रेजुएट है, उसको पर मंथ 45,000 TTA एग्रीमेंट के थ्रू, कंपनी के थ्रू मिलता है। दिस इज द एडवांटेज ऑफ TTA। दूसरा होता है नॉलेज ट्रांसफर एग्रीमेंट इज ऑल्सो देयर। आप जो चीज, हाँ
तो सर उसमें जितने ऑथर होंगे, इन्वेंटर होंगे,
हाँ
तो
उन सभी को सर,
45,000 गोइंग टू
हाँ
डिवाइड बाय दैट, या?
है, यस यस, वो सब लिखा रहता है सर TTA में कि होल एंड सोल पर आइडिया हम आपको 45,000 देंगे। इस
ओके, ओके।
45,000 में अकेला रहा तो भी 45, अगर 9 लोग रहेंगे तो वो डिवाइड हो जाएंगे सर।
ओके, ओके।
ओके, तो ये सिंपल स्टैम्प पेपर पर करना पड़ता है, कोई भी कंपनी इजीली कर सकती है सर, बट आपके पास एक लीगल प्रूफ होना चाहिए, आइदर पेटेंट होना चाहिए, इंडस्ट्रियल डिजाइन होना चाहिए, कॉपीराइट होना चाहिए, व्हाट एवर इज दैट। दूसरा होता है नॉलेज ट्रांसफर एग्रीमेंट। ये नॉलेज पर आप इसको एग्रीमेंट भी नहीं कर सकते या फिर सिंपल नॉलेज ट्रांसफर भी कर सकते। जैसे आज मैं आपको जो डिलीवर कर रहा हूँ दैट इज अ नॉलेज ट्रांसफर, बट हर बार अगर मुझे नॉलेज ट्रांसफर करना है तो हर बार मुझे पर्टिकुलर ऑनरोनियम या फिर रिम्यूनरेशन नहीं देना, मैं होलसम में एक अमाउंट ले लूंगा। ओके, या फिर मेरे जो वीडियो जो चलेंगे अकॉर्डिंग टू दैट, जो एग्रीमेंट के ऊपर जो मुझे अमाउंट मिलता है, दैट इज अ KTA, दैट इज अ नॉलेज ट्रांसफर एग्रीमेंट। दिस इज द आफ्टर IPR विच इज द मोस्ट इंपॉर्टेंट फ्रॉम द NAC पॉइंट ऑफ। एंड थैंक यू। ये जो फोटो आप देख रहे हो यहाँ पर, इन 2024 वी सेलिब्रेट द 125th बर्थ एनिवर्सरी ऑफ पंजाब राव देशमुख, द फाउंडर प्रेसिडेंट ऑफ शिवाजी एजुकेशन सोसाइटी। यहाँ पर ये जो स्टूडेंट है, नंबर ऑफ स्टूडेंट कम है और ज्यादा स्टूडेंट है, हमने 200 से ज्यादा IPRs होल्ड करके रखे हैं हमारे स्टूडेंट में। नियर अबाउट 178 स्टूडेंट के पास कीनिया के कॉपीराइट है, 60 स्टूडेंट ने पेटेंट पब्लिश किया था और 150 स्टूडेंट के पास इंडियन कॉपीराइट्स, और विद इन 1 ईयर हमने किया था। सो स्टूडेंट पॉइंट ऑफ व्यू दिस ऑल टर्म्स आर वेरी वेरी, सो थैंक यू सो मच। कुछ डाउट है तो आप पूछ सकते हैं।
थैंक यू सर, बहुत अच्छा आपका परफॉर्मेंस। थैंक यू सर।
हेलो सर।
थैंक यू।
Sir, please share your
Sir, am I audible? Sir.
Yes, sir. Yes, sir.
Yes, sir. Sir,
Yes.
I just wanted to ask if I have a certificate of registration of design.
Yes.
And the word granted is never nowhere written on that
Yes.
certificate.
Yes.
So
Yes. Yes.
am I going to use it in a CAS purpose, or shall I go to the
No,
registration?
no, sir. No. Remember one thing is, industrial design is only registration. बिकॉज सिंपल है, आपने जो फॉर्म, आपने जस्ट कॉलेज में एडमिशन लिया है, आपने एग्जाम ही दिए नहीं है, तो आप एलिजिबल होगे क्या?
ओके सर,
तो
हम
पेटेंट
अगर
ग्रांट जो होता है ना सर, पेटेंट ग्रांट इज व्हाट, आपने फर्स्ट समय एडमिशन लिया है, आपने खुद को रजिस्टर्ड किया है, आपने एग्जाम देने के बाद आपको डिग्री मिली है, तो सो दैट यू आर एलिजिबल. बट कॉपीराइट में एग्जामिनेशन वर्ड ही नहीं होता है, और इंडस्ट्रियल डिजाइन में भी वर्ड नहीं होता. इंडस्ट्रियल डिजाइन इज ओनली रजिस्ट्रेशन. आप जस्ट रजिस्टर कर रहे हो, वो इनोवेटिव है, ये है, वो है, कोई बोलने वाला नहीं हो सर उसको.
ओके. तो इसे सर पेटेंट में कन्वर्ट नहीं कर सकते हैं?
हाँ, वेरी गुड क्वेश्चन. और एक कभी भी अपने थ्रूआउट दिस एकेडमिक जर्नी और वट एवर कभी भी आप रहोगे, तो एक चीज हमेशा याद रखना, कुछ हायरार्की है, उस हायरार्की को मेंशन करना. काइंडली हो सके तो इसको नोट भी करके रखिए, क्या गड़बड़ होती है. सबसे पहली बात, आपके दिमाग में जैसे ही कुछ नई आइडिया आती है, तो आप सबसे पहले उसका आईपीआर लें. वाट एवर इन द फॉर्म ऑफ, आप डिजाइन करो, कॉपीराइट करो, कुछ भी करो, प्रोविजनल पेटेंट फाइल करो, वाट एवर इज दैट, आप जस्ट पेपर, आप जस्ट एक लीगल डॉक्यूमेंट अपने पास रख लो. सेकंड वन इज दैट, एज सुन एज यू रिसीव्ड वन रिसिप्ट ऑफ पेमेंट, या फिर एक फॉर्म जनरेट हो गया, वाट एवर जनरेट हो गया, आप इमीडिएटली न्यूज पेपर में न्यूज दो सर उसकी. दिस इज द बिग प्रूफ फॉर द डेट ऑफ प्रायोरिटी. अभी मेरे साथ लास्ट 2 साल पहले केस हुई थी, तो मैं ही जीत चुका हूँ, तो नो नहीं. और दूसरा, अभी कुछ चीजें समझ लीजिए सर. अभी आप बोलते हो कि मैं कॉपीराइट पहले कर लेता हूँ, बाद में मैं पेटेंट करता हूँ, ऐसा कभी भी होगा नहीं. पेटेंट के लिए नोवेल वर्क चाहिए, कॉपीराइट और इंडस्ट्रियल डिजाइन के लिए नोवेल वर्क नहीं चाहिए. आप कुछ भी वर्क डाल दीजिए, अगर उस टाइप का वर्क रिपीट नहीं हो रहा, थोड़ा सा भी चेंज है, नया उनको नया लगेंगे तो रजिस्टर कर देंगे. बट पेटेंट में ऐसा नहीं चलता है. तो व्हाट इज द हायरार्की? फर्स्ट पेटेंट, then newspaper, then research article. If suppose आपने सॉफ्टवेयर बनाया है, फर्स्ट इज कॉपीराइट रजिस्ट्रेशन, देन न्यूज़पेपर, देन रिसर्च आर्टिकल. इफ सपोज आप रिसर्च आर्टिकल नहीं लिखते हो, तो कॉपीराइट सर्टिफिकेट इज देयर, देन न्यूज़पेपर इज देयर, या फिर आप न्यूज में डाल सकते हो. ये याद रखना, दिस इज द रूल. सबसे टॉप मोस्ट पोजिशन पर होता है पेटेंट. अगर आपको लगता है कि आपके आइडिया पेटेंट हो सकती है, पहले पेटेंट फाइल करो. और दूसरा, आपके दोस्तों के साथ भी अपनी आइडिया शेयर मत करना, विच इज द इम्पॉर्टंट.
पेटेंट यानी ब्रँड पेटेंट ना सर?
नाही सर, प्रोव्हिजनल फाईल करून टाकायचं पहिलेच. मग ते पेटेंट होईल नाही होईल ते नंतरचे विषय. पण तुम्ही आज तुमची आइडिया बुक तर केली. क्या होता है मोस्ट ऑफ द टाइम, अपन एक वर्क कर देते, काफी अच्छा वर्क होता है, उसको न्यूज़पेपर में पब्लिश कर देते. ऑटोमेटिकली आपने जैसे उसको न्यूज़पेपर में पब्लिश कर दिया, नॉवेल्टी ब्रेक होगी. बिकॉज आज अभी नाउ डेज कंट्रोलर ऑफ पेटेंट, दे आर यूजिंग द एआई टेक्निक्स फॉर द डिटेक्शन, फॉर द अर्ली एग्जामिनेशन. जैसे आप डालोगे, वैसे ही वहां पर आपके न्यूज़पेपर की कटिंग दिखेंगी, आपकी नॉवेल्टी वहीं पर ब्रेक होगी, पेटेंट ग्रांट होगा नहीं. पहले पेटेंट प्रोविजनल यू जस्ट फाइल प्रोविजनल पेटेंट, फॉर्म नंबर 135, 1600 फीस. या एक हफ्ते में आपके मेल के ऊपर रिसिप्ट आएंगे. जैसे ही रिसिप्ट आ गई, दैट मीन्स आपकी आइडिया रजिस्टर्ड हो चुकी है. नाउ यू आर ओपन फॉर द पब्लिकेशंस, फॉर द क्या बोलते हैं, आप कई जगह पर आप लेक्चर दे जा सकते हो. फिर आप आराम से उसको प्रोविजनल फाइल कीजिए, ग्रांट के लिए अप्लाई कीजिए, वॉट एवर. बट आपने रजिस्टर्ड तो करके रखा है. दिस इज द वेरी इंपॉर्टेंट.
Sir, what kind of copyrights your students are having?
Which one, sir? My student?
Your students. You said many of your students have got several copyrights and all. So what
Yes,
kind of copyright they are claiming?
Some students develop some small prototypes, softwares. So for the coding and software, they have received the copyright certificate. We also completed the one African project, that is from the Toro Botanical Garden, Uganda, and Kigulu Museum, Uganda. We developed one smartphone applications. And for that smartphone applications, near about the 10 students are there working with me. So that all 10 students received the copyright certificate from the Kenya, because we also completed the Kenya museum also. Some of the students, कुछ स्टूडेंट्स को फोटोग्राफी अच्छी लगती है तो कुछ स्टूडेंट ने फोटोग्राफ्स के ऊपर भी लिया है, कुछ स्टूडेंट्स ने पोएम की बुक लिखी थी, पोएम्स के ऊपर मिला है, कुछ लोगों ने केमिस्ट्री के पॉडकास्ट एपिसोड्स बनाए थे, ऑडियो फाइल्स बनाई थी। एन नंबर ऑफ थिंकिंग वे है सर वहाँ पर। आप किसी भी वे से बच्चों को आप जस्ट इनकरेज कीजिए, काफी हेल्पफुल होता है। मेरा इंटेंशन वही था, हमने कुछ नया बनाया ऐसा क्लेम नहीं करते सर, जस्ट हम जो बना रहे हैं ओनली फॉर द स्टूडेंट। और इसी में से 4 स्टूडेंट का टेक्नोलॉजी ट्रांसफर एग्रीमेंट है, 2 स्टूडेंट को 1-1 लाख की गवर्नमेंट की सीड फंडिंग मिले ओनली फॉर द पेटेंट पब्लिकेशन के भरोसे पर।
Very nice, sir. Very nice, sir.
Thank you, sir. Thank you.
Sir, I have a question. Sir, if suppose there are 10 inventors in a patent, suppose like supervisor and 9 PhD students, and they file a patent on drug discovery, finding a new drug molecule, and in future the drug comes in the market. Okay, so how the royalty amount will be decided?
That depends on you, sir. Because during the filing of a patent, okay, there is one affidavit from your side.
Okay.
Okay, how much percent share will be shared by each participant? That is, supervisor will get done 60%, 90%, student will get 10%, 20%. Each term it should be authorized by your side. उसके लिए आपको CA की हेल्प लेनी पड़ेगी सर। और ये अभी नहीं होता है सर, आफ्टर जब आप टेक्नोलॉजी ट्रांसफर एग्रीमेंट करने वाले हो।
At the time of technology.
नो सर, टेक्नोलॉजी ट्रांसफर एग्रीमेंट इज व्हाट? पेटेंट किसके नाम से है? सपोज मेरे नाम से है तो पूरी अमाउंट मुझे मिलेगी।
ओके।
फिर मेरे अंदर जो 10 स्टूडेंट है वो एग्रीमेंट कहाँ पर है? अपने उनके साथ भी एक एग्रीमेंट साइन करना पड़ता है।
ओके ओके।
बिकॉज मोस्ट ऑफ द टाइम पेटेंट अमाउंट जो होती है वो पेटेंट अप्लीकेंट को ही मिलती है। अप्लीकेंट जिसने पेटेंट फाइल किया था, इन्वेंटर को नहीं मिलता है सर।
Okay, so like applicant will decide.
Yes, applicant and co-applicant, whatever it is.
Okay, thank you, sir.
Thank you.
Okay, so sir, if you could permit Professor Sarang sir, shall we conclude, sir?
Oh, yes, sir.
We have to move for the next session. Our next speaker is waiting.
Yes, sir. Yes, no doubt.
So, thank you so much, sir. Thank you so much. Yes, whose turn this is for the proposed vote of thanks? Please propose vote of thanks.
Yes, sir. Thank you, sir. A very good afternoon to the respected chairperson, esteemed resource person, Dr. Sarang Dhote, all the participants. It is my proud privilege to propose the vote of thanks on behalf of the organizers as well as all the participants. First and foremost, I would like to express my heartfelt gratitude to our esteemed resource person, Dr. Sarang Dhote, sir, for delivering such an interesting and thought-provoking session. Your insightful presentation on intellectual property rights and rich academic experience have greatly enriched our understanding of the subject. We are truly grateful for the time and effort you have devoted to making this program a successful one. I also express my appreciation to the course coordinator, the organizing committee, of the Sant Baba Gadge Amravati University for their successful organization and smooth execution of the refresher course. I'm also thankful to the participants for their enthusiastic presence and active involvement. Thank you all.
Thank you, Professor Sarang sir. Thank you so much for such a wonderful session. You have elaborated and broadened our concept towards this IPR and what are the difference between the patent, design, mark and copyright. So we are really thankful to you, sir. With the kind consent of Professor Sarang sir, I would like to declare that this particular session will be over here and we will move for the next session. Thank you so much, sir.
Thank you.
Thank you, sir. Thank you.
Hello, Professor Ramteki sir.
Hello, sir. Good evening.
Sir, first of all, I'm extremely sorry. Actually, the session has been extended and we have taken 15 minutes from your allotted time.
Okay, sir.
So, shall we start, sir, if you could permit?
Yeah.
So, now may I request Dr. Harshali ma'am to please introduce our guest in brief and then we'll start with the session. Dr. Harshali ma'am, please.
Yes. Thank you, sir. Thank you, Ankit, sir.
Good afternoon, everyone. It's my great privilege and honor to introduce today's distinguished resource person, Professor Dr. Avinash Ramteke sir, who has graciously accepted our invitation to deliver an expert talk in this refresher course in chemistry organized by Malviya Mission Teachers Training Center, Sant Gadge Baba, Amravati University, Amravati. Dr. Ram Teke is a professor in the Department of Chemistry at Devchand College, Arjunnagar, Kolhapur, Maharashtra. He holds an MSc, PhD, NET JRF, and GATE qualification and has an impressive research experience of 18 years and teaching experience of 17 years, including 17 years at undergraduate level and 8 years at postgraduate level. His areas of specialization includes organic chemistry, nanomaterials, and ultrasonic chemistry. He has made a significant contribution to research with 46 research papers published in reputed journals, including publication with an impact factor as high as 21.3. He is currently guiding 5 PhD scholars, reflecting his dedication to nurturing future researchers. Adding to his academic achievements, Dr. Ram Teke has authored 2 books which reflects his commitment to advancing knowledge in the field of chemistry. He has also been granted a Korean patent, a testament to his innovative research. He is also a recipient of a prestigious NET JRF Fellowship for his doctoral studies. Today, Dr. Ram Teke will share his valuable insight on the topic natural products, alkaloids, reference to the nicotine compound. We are confident that his vast knowledge, rich teaching experience, and active research contributions will make this session highly informative and inspiring for all the participants. On behalf of Malviya Mission Teacher Training Center, Sant Gadge Baba, Amravati University, Amravati, I extend a warm and heartfelt welcome to Professor Dr. Avinash Ramteke sir. May I now request our esteemed speaker to kindly deliver his talk. Thank you, sir.
Thank you, ma'am. So nice introductions. Is it visible to all of you?
Yes, sir.
Yes, sir. Thank you, one and all. This is the last sessions, and I think all are very tired. So whole day you are listening a number of sessions. Like I think it's 4 sessions you have today, and this is the last sessions. And this session is specially related to this organic chemistry, and then in that organic chemistry, that is the natural product, is one of the topic. So this is basically, I want to choose this topic for this refresher course because all the peoples are chemistry peoples and they are know the natural products. So I choose this topic for these chemistry people. And this is the topic which is included in almost many of the universities syllabus. But in this topic, I choose one simple compound as an examples because this is the vast topic, natural products. So a number of classifications. Out of that, I chosen the alkaloids, one of the classification or classified compound. And out of this, I choose one examples, that is the one simple examples, that is nicotine, because the nicotine is present in the daily we know well-known plants, that is tobacco, and therefore this is the interest. This is my interest to choose this example. You people know very well the plants contains a number of the natural resources or chemical compounds. Also, if you take an examples of one tree and if you cut down this tree into the different parts like stem, roots, flowers, birds, fruits, leaves, so all the organs having the different kinds of the alkaloids is there. So it is a much natural resource for these chemistry peoples, and we study the n number of these compounds like alkaloids. Fundamentally, we study or we learn today only or try to learn these some fundamental properties of alkaloids, or we can say it is the introductory part, and then how to classify it or how to extract or how to isolate these compounds from this material, raw material, and then we try to understand the how to elucidate their structures. The first one is the general procedure, and second one is we move towards the special reference to the nicotine compound. I would like to explain the this compound. These are the n number of compounds. This is present in the alkaloid class, right? So this natural product which is present in this is comes to the point that is the alkaloids. So these are the n number of compounds. So out of this, this is the nicotine. We take an examples for this alkaloids.
Sir, audio, video, both are
नहीं,
lost.
actually, madam, नहीं, 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 madam. Madam, sir is disconnected. Please wait for 1 minute. I think he should reconnect. Sir is disconnected.
Okay. Hello.
Yes, Dr. Ramteke sir, you are audible, sir. You can please continue.
Yeah. This is a interrupt from my side, my end. Okay. So it is a Wi-Fi connection is disconnected now. So right now it is okay. So just I told you this is the alkaloids compounds. It is present in different kinds of the plants and their various organs. But these alkaloids are generally found in occurrence in the salt form, which is basically it is a basic in nature, and therefore it is form a salt which is present in the acid in the plants. The second one, I want to explain the pharmacological activities. So alkaloids plants having different kinds of the biologicals or the pharmacological activity. Therefore, this is them have some medicinal values, and therefore this kind of compounds it is to be studied, and it is highlighted, or we attract our the research point of view to attract such kind of the natural products. So alkalides are very important compound very important compound which is synthesized in the laboratories and given some nomenclatures for this compound. So just I told you this is the compound is basic in nature and a nitrogen containing compound, but some ambiguity is there, and some compounds it is exceptional cases. So here you see the screen, that is the one of the compound which is the heterocyclic, not heterocyclic and not basic in nature, but still it is considered as alkaloid. Another compound it is the heterocyclic, but it is not basic in nature, so it is considered as an alkaloid. Another example, it is basic in nature, heterocyclic in not heterocyclic in nature, still it is considered as a alkaloids. But some compounds it is the like a thiamine, it is a, we know that it is the amino acid, but it is not considered as a alkaloids, even though it is contain nitrogen and the heterocyclic ring and basic in nature also. So these are some examples I put here, and on the basis of that the alkaloids can be defined like it is a biologically active and basic nitrogenous compound which obtained from the natural resources like the plants, and most of these alkaloids are optically active and having some biological active compounds. So on the basis of this history of your uh, alkaloids, the most notorious poisonous in the history of civilization, used by the humanity for thousands of years, and the first civilizations to use them were probably the ancient of this Egyptian. It was called as vegetable alkali. So these alkaloids have the different terminologies. So I just put here some basic terminologies like alkaloids. It is alkali like compounds, and it is commonly used to the designated basic heterocyclic nitrogenous compounds, right? And one of the highlighted features of this one is the biological active compounds. So this is the very important things. This term is invented, or it is coined by the one of the German
Dr. Ramteke, sir, you are not audible, sir. Hello, Dr. Ramteke, sir, you are not audible.
Yes. So Wagner reagents. So now it is audible?
Yes, yes, sir.
Yeah.
You can please continue.
Hello. Hello. Huh.
Yes, sir. Now you
So
are
this
audible. Please continue, sir.
another reagent. Yes, yes. Wagner reagents, it is iodine in potassium iodide. So red brown precipitate is come out. So these are some taste, the test for the alkaloids. So directly we test with this the raw materials of the alkaloids which is coming from these plants. These are some general properties which we'll highlighted. These most alkaloids are colorless solids. Normally, alkaloids is bitter in taste. We know that this optically active, and especially it is levorotatory. Generally, alkaloids is insoluble in water, but it is some kind of organic solvent. It is soluble because it is salt. Some alkaloids are liquids and some alkaloids are solids. So those are the solid. It is especially soluble in water, and the liquids alkaloids, it is not so soluble in the solids, but not soluble in the water, but it is soluble in the some organic solvents. Alkaloids contain at least one ring in the compounds, at least one ring. It may be saturated or it may be unsaturated, heterocyclic, or it is without the heteroatoms also. It contains one or two nitrogen atoms in the ring, and it is tertiary in nature. Alkalides form the insoluble precipitate with the this kind of different kinds of the acids like present in the already present in the compounds or the resources, natural resources. These tests are used for the detections of alkaloids. So which already will this taste, these different types of the taste we take this directly from the raw materials of the plants. Most of the alkaloids possesses markedly this physiological activity when it is orally administered, right? Alkaloids in small quantity, it is act as a drugs, means it is the medicinally use, it is in lethal or the limited quantity, but it is in larger dose or larger quantity, it acts as a poisonous one. Some physiological physiochemical properties of alkaloids like molecular weight is about 100 to 900, so different for the different various alkaloids. Most bases which do not contain the O2 are liquids at room temperature, uh, while those that do are solids, in rare cases they are the color. So likewise, these are the some physiochemical properties normally are not soluble in water and all, soluble in polar solvent like organic solvent. You know that very well. Naturally occurring chemical compounds containing basic nitrogen, and therefore it is the alkali nature. So these are the some physiochemical properties of this alkaloid. Some of the chemical properties like salt formations, effect of heat on this alkaloids, it can be decomposes like a caffeine, effect of lights and oxygens. So decompose when allowed to stand at the temperatures above 70 degree for the long time, or this one. So decompose positions occurs rapidly and easily when an alkaloid is in solution, is in solutions when it is in dry form. So these are some chemical properties also. Now we move towards some examples of the alkaloids, right? Morphine, so it is induce sleep and stress pain reliever. Atropines, it is the dilates pupils of eyes. The piperine, it is improves the digestions and there's some of the other activities like analgesic. Cocaine, like local anesthesia. Quinine is anti-malarial and another one is anti-fever. Ephedrine is treatment of asthma, and quinine is this effect on CNS, central nervous system, and sometimes it is poisonous also. So precipitation reactions. So we already discussed this all these reactions. So this gives the precipitate, different types of the different types of the precipitates or different color is there. Color reactions also, it is very important to identify these, primarily identify these alkaloids like when ERK test and the Vitali Morin test also. So this is the some color test to primarily identify it is alkaloids or is there or not, right? Some of this flow chart is giving the idea about the isolations of alkaloids. So this alkaloids isolations mean we can able to extract your alkaloids compound from the natural resources like plants. So plant material, it is dumped into the solvent, so particular solvent. So you have the knowledge of the choice of solvent, and then we can dump your plant material, which is dry, and make the powder it, and this dump into this organic solvent. After this, these organic solvent dissolve alkaloids can be extracted with this rotavapor, then which concentrate it on the rotavapors. This organic solvent dissolve this organic solvent is absorb the alkaloids into it, then it is concentrated and then acidified, because acidification it is very important step to extract this compound, because the alkaloids is particularly it is basic in nature, and therefore it is the making a salt with the acid present. Therefore the acidification is made very important. Then this alkalizations, and then it is the absorb organic solvent absorb these alkaloids. It can be this way separate with the help of the separating funnel, like this from this aqueous layer, so alkaline aqueous layer. So this is a simple extraction methods which is used to isolate or the extract of your the alkaloid. Now comes to the next point, that is once we isolate or extracted these alkaloids, now our job is to nomenclature of this compounds, to identify this compound. So nowadays we have different kinds of the analytical tools like spectroscopic methods to identify easily this compound, and we have the different kinds of those separation techniques, not use this extraction chemical reagent method. So we are using different kinds of the chromatographic technique to separate directly your compounds, the different compound present in your plants. So, but the traditionally we nomenclature of this compound, it is based on some points, like according to their source where it is found, like papaverine and ephedrine nicotines, where it is found. So on that basis, their nomenclature is there according to that. Then according to their physiological responses, what kind of the biological activity, like the morphine, it is induces the sleep. So this is the source or the giving the nomenclatures according to their physiological or biological responses. Then according to their discover, this where it is discovered and who is invented. So on that the particular fellow, so giving their name to these alkalides. And the last one is the suffix and prefixes. We know that. So INE, this is the suffix with giving the name of these alkalides, like your the quinine, 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 nicotines, likewise. So another this prefix like ephedrine, it is one of the alkaloids. Neo, it is one of the alkaloid. Iso, it is the one of the iso. This is one of the prefix we use for these isomers. And these NORs means demethylations compounds. It is giving these prefixes some of the alkaloids. So on the basis of suffix prefixes, also the use for the nomenclature of different kinds of the alkaloids, which is we and some of the alkalides are use their nomenclature on the basis of their sources and uses. So here I put some examples of the alkalides like ephedrines and quinine, piperine, nicotines, all these. So where it is source, that is your piperine is coming, it is extracted from the black pepper. It is well known, or it is well known natural product. This tobacco, it is the famous plants which is giving your nicotine compounds, and some of the properties that I put here, that is the nicotine, it is an examples of this. It is deadly poisonous, so up to the and it is used as an insecticide. When it is used as an insecticide, this kind of application, if it is used in their lethal level, okay. So after the crossing their lethal level, so it is the concentration, it is higher, and therefore it is becomes and poisonous, right? So these are the some sources and their properties So on basis of that, some alkalides are also classified or also their nomenclatures. So these are likewise atropine, quinine, conines, piperines, morphines, and reserpines. So some examples are quote here, their sources and properties. So for example, if you take an examples of the opium poppy, this is the one of the plants which giving the extracted from that plants, that is piperine, and it is induces sleep. Second one is the morphine, it is induces with the sleep also. Anesthesia, it is used as anesthesia. So this kind of the alkaloids, it is present in the particular plants. Now our job is classified these alkaloids on the basis of their some structure. So according to the chemical structure, we can classify the alkaloids. So here, if you see here, this is one of the compound that is a hygrine, and he contain this pyrrolidine ring. So if it is pyrrolidine ring is there, so on the basis of this, it is considered as the nucleus of this compound, and therefore it is the pyrrolidine alkaloids. So likewise, the second one is this piperine, so which contain the piperidine and pyridine ring. So this kind of compounds, it is classified as the pyridine alkaloids or pyridine piperidine compounds or the alkaloids. So again, nicotine, this is our compound which taken an examples. So this compound again pyridine is there and this pyrrolidine ring is there. Again, the classifications of this compound is pyridine and pyrrolidine. Likewise, your reserpines, it is indole ring is as a nucleus. So therefore, this on basis of this structure, there is the indole alkaloids. So quinolines and isoquinoline, this kind of the nucleus present in your compounds, then it is a class of the alkaloids. It's quinoline and isoquinoline. So tropone ring is there or tropolone is there. So this is the atropine compounds contain the tropolone. So it is a class of tropyl alkalides. Now the ephedrine compound is contains this phenyl. So phenylethyl ether like structure. So this is phenylethyl amines like compounds. This alkaloids this is the class of alkalides. Morphine contains this phenanthrene ring as a nucleus. Therefore, it is the class of phenanthrene alkalides. Some of the alkalides is classification according to their synthesis or the biosynthesis from the amino acids. So some is the true alkaloids, that is their synthesis from the amino acids having the heterocyclic ring containing the nitrogens, like your this reserpine, atropines. Like protoalkalides, it means they are synthesis from the amino acids, but they do not contain the heterocyclic ring or the nitrogen. And pseudoalkaloids, it is the class of they contain heterocyclic ring and also the nitrogens, but it is not synthesis from the amino acids, right? So for example, this is your caffeine, right? So caffeine, it is cannot be prepared from the amino acids, but it contains the heterocycles and these nitrogens also. This is the classifications of alkaloids. So this is the basic informations of the alkaloids we know very well. All the peoples are chemistry peoples, and it is know very well of this the basic information. Now these compounds, we know the isolations, we know this nomenclatures and the class of compound, class of alkaloids. Then now our job is to be determine their structures. So first of all, we just general methods for determinations of the alkaloids. General methods, it is generally used for the all the alkaloids. So these are some methods like molecular formula, unsaturation determination, nature of oxygen present in your alkaloids, nature of nitrogen atoms, nature of heterocyclic ring, spectral analysis, and synthesis. So all these chemical methods. So the 1 to 5, these methods are the chemical methods are we are using in the chemical reagents for these identifications. But nowadays we are very advanced people and we know that, so this is the waste of our time, and we are using for some spectroscopic and this technique as an analytical tools like NMR, C13, then mass spectroscopy and chromatographic techniques and all these things. So we are easily identify the compounds. But these are our ancient time, these are the chemical methods are used to determine the structural elucidations of these alkaloids. So first of all, the molecular formula. Molecular formula we can determine on the basis of the molecular weight. Once we know the molecular weight and molecular weight, qualitative and quantitative, we can find out easily from the spectroscopic methods like a mass spectrometry. So this, once we know the molecular weight, we can easily find out the molecular formula of the compounds. Second methods, that is the unsaturation determinations, like a presence of double bond. So we know that very well the presence of double bond, like the dilute KMnO4 test or brown water test. So these are the tests or some reduction reaction in presence of the palladium and the some of these halo acids or the halo alkali reactions is there. So these reactions are also used to determine the presence of the double bond or the unsaturation in your compounds. So it means that unsaturation or double bond determined by addition of these some reagents like Br2. It is reacts with your double bond and formations of the 1,2. This kind of the bromide over here. Second one is the reductions reaction, and the third one is this HBr. So this is the Morconi and anti-Morconi crops. It is depends upon the double bond where it is present, right? So on the basis of these reactions, we can easily find out the double bond or the unsaturations. And with this double bonds or these unsaturations, we know that how many number of these hydrogen is there or how many hydrogen is deficient in present in your compounds. We know very well on the basis of that test. Next one, the method to identify your compounds, that is the nature of oxygen. So oxygen is present in the different nature, like it is present in alcohol, it is present in phenol, it is present in the carboxylic group, it is present in the different kinds of the acids or ether or esters. So these are this kind of the nature, lactose also. So this kind of this nature of oxygen present in your compound. So this nature of oxygen, it which nature of this oxygen present in your compound. So we identify this one by one, like the hydrohydrogen. So I have about this phenol. So this compound, it's chemically identified with the help of simple reactions like it is detections by the acetylations or benzoylations reaction. Here I put some simple reactions like the general formula of this your alkalides, so are OH, and if it is treated with this acetic anhydride or acetic chlorides, it is the acetylations.
Yeah, Ram, take a sir, you are not audible.
Yes. So this Grignard reagents, it is also used for the identifications of this hydroxyl group present or not So, and how many hydroxyl group is present? If it is this 1 mole of this CS3 group, that is the methane gas, is excluded from this titrations, then we can say that the 1 mole of OH group is present, is there. So on the basis of this reaction, the nature of OH group may be the nature. On the basis of this, we can find out the number of OH group present, or it can be estimated in the compounds with the help of the simple titrations with the some calculations, right? Now, then our job is to identify the nature of OH group. So we know that the OH group present in alcohol and the phenolic compounds. Alcoholic, it is OH group attached to the aliphatic, and phenolic compounds, it is OH group directly attached to the this benzene ring. So here, these phenolic compounds we can identify easily with the help of simple reaction with the neutral FeCl3 test. If it gives the violet or these green colorations, it will be indicate that this compound contains the phenolic OH group. But the question is presence of alcoholic OH group. So there is some reaction is there, like these thionyl chlorides. If the compound is reacts with the thionyl chlorides, and it formations of this alkali chlorides, or this SO2 and the HCl as an gases. So this is indications of this your compound contain the alcoholic OH group. So this is the differentiates the alcoholic or phenolic OH group is there. If the alcoholic OH group is present, so it may be primary, it may be secondary, or it may be tertiary. Now our job is to distinguish this primary, secondary, and tertiary alcohol group. And it is here it is the some simple reactions I have taken, right? So if it is primary alcohol present in your alkalides, so it is oxidized to give the aldehydes with having the same number of carbon atoms. Further oxidation is used the last product, it is acid, and it is having the same number of carbon atoms. But if your compound contain the secondary alcohol, it is the giving the ketone, right? And the same number of carbon atom. But further oxidations, it gives the acid, same acid, but it is less number of carbon atoms because of the one carbon chain can be this break. And the third one, this is an examples of the tertiary alcohol. If your alkalides contain the tertiary alcohol, the simple same reaction is oxidations. It is oxidized to well-known, that is the ketone, which having the less number of the carbon atom, thus previous one, like secondary or primary. And the further oxidation, it is giving the same product like acid, but it is here it is also the less number of carbon atom. On the basis of this, we can say the oxidation reactions of alcohol can be identified, or we can say the primary alcohol or secondary alcohol or tertiary alcohol is there. Now, in the secondary alcohol, where it is present in the aliphatic group, or where it is present in the ring structures. So this can be identified with the again same oxidations reactions. It gives the ketone with the same number of carbon atom, but it is give the dicarboxylic acid further oxidations which having the same number of carbon atom, but dicarboxylic acids. It will be indicate that your alcohol, it is present, it is secondary, but it is present in the on the ring, right? The next one is the carbonyl group. This is the another nature of the oxygen atom. The presence of carbonyl group is detected by some reactions. These are the reactions. It forms oxime-like structures with the hydroxylamine. This is giving the oxime-like structures. It is indication that your compounds contain the carbonyl compounds or the carbonyl group. Also, it forms the phenyl hydrogens with the phenyl hydrazine, and it is also indicated that the carbonyl compound is present in your alkaloid. So this carbonyl compound, it may be aldehyde or it may be ketones. So here also can be distinguished with this some oxidation and reduction reactions of this aldehyde and ketone group. So if aldehyde is there, so after oxidation, it is giving the acid which having the same number of atom. But if it is ketone is there, so after the oxidations, it is giving the acid, but it is less number of carbon atom. In the same way, we can use the reduction reaction. If it is aldehyde, it can be reduce the primary alcohol, And if it is the secondary, if it is the ketone, so after the reductions, it is giving the secondary alcohol. This is the simple reactions can be used to identify the where it is aldehyde or ketone. Next, nature of oxygen present in the alkalides like a carboxylic acid group. So this presence of carboxylic acid is can be detected by the simple, that is the sodium bicarbonate. So sodium bicarbonate giving the indications as weak efferences, and then it is filter it, and then it is the filtrate is treated with this some uh, concentrate acid like HCl. So it gives giving the your compounds that is reappeared. So this is the simple reactions to identify the acid is there, carboxylic acid is there. So this is the one examples, but how many number of carboxylic group is there? So therefore we can this again the reactions with the NaOH. If it's 1 mole of NaOH is consumed, so it means that the 1 mole of carboxylic acid is there. So this is not the simple task because it is the titration methods. We do the calculations with this, and then we can find out the mole of NaOH and mole of on the basis of this we can find out the carboxylic acid group. Next nature of the oxygen, it is methoxy group. This methoxy group can be detected with the help of these results methods. Especially we know that results methods, it is these are the OCS3 compound which present in your alkalides, and it treated with the hydroiodic acids, so like HI under some pressures, under some temperatures. So it gives the alcohol and the methyl iodide. So methyl iodide, it is a very important compounds in these reactions. Now this methyl iodide, it is again reacts with this AgNO3 silver nitrate, and it gives the AgI silver iodide as in the precipitate. So this will be indicate that this 1 mole of AgI, it will be indicate that the OCS3 present and confirm of the number of this methyl or the OCS3 group in our alkalides. Next, nature of this compound present in your or this group is present in your alkalides. This is the diaxyl group, like, right? So it is sandwiches between this methylene group is sandwiches between these two oxygen atoms. So this kind of the moiety present in your alkalides, it is reacted with the simple acids like HCl, and it formations of this kind of this alcohol. And again, we know that this is unstable one, and it is the removal of water molecular formations of formaldehyde and ultimately the formic acid. This reaction indications, it is the 1 mole of formic acid, it is indicate that the one methylene diaxyl group present in your compounds. It means that the OCS3, OCH2O, this kind of the linkage present in your alkalides. So another some oxygen containing group present in your alkalides like ester, amides, lactones, or lactam. So again, it is these reactions with the simple base and this H2O in presence of some temperatures. Again, it is giving, so ester and amide group gives the sodium salt of your acids, and if it is ester, it gives the alcohol, and if it is the amide, so it is giving the NH3. So these indications of this product, it is the ester and amide group is there in your compound. Lactam, it is the cyclic compounds, and which is the again the ester and the amide group is there, but it is present in the cyclic form. So this can be also identified with the this product hydroxy acid and amino acids. It is indicating your compounds alkalide class compound contains this. The nature of oxygen is present lactam and lactone V. Now our job is the nitrogen atom present in your compound, in what kind of the nature is there. So this alkalides, we know that it is basic in nature and it contains the nitrogen. So it is a primary or secondary or tertiary nature of nitrogen. It can be detected by some general reactions which put over here. So if it is considered as a primary amine is there, so NH2 group is there. So this group less commonly find in the alkalides. So because I already told you that is these tertiary nitrogen is almost there. So if it is primary amine, so RNH2, so it reacts with the nitrous acid in formations of the alcohol and the nitrogen as an gas. This is the expel the nitrogen as an gas. If the second reagents, we use the acetyl chlorides, the formations of diacetyl derivatives. And third reaction, that is the, if it is compound treated with the methyl iodide, is formation of quaternary salt. So these are the reactions which will be indicate that the primary amine. If it is your compound contain the secondary amine, so this secondary amine group, it is reacts with the again HNO2 groups. It is formation of nitroso compound, which is the especially is yellow in color. And secondary amine group is treated with the CS3COCl group. So it is formations of monoacetyl derivatives. And third one is the this methyl iodide. It is reacts with this your secondary amine. It is formation of the quaternary salt. So above this, these two first and second reaction, it will be indicate that the your compound contain the secondary amine. Next one, if it is compound contain tertiary amine, so this reacts with the methyl iodide directly and formations of the quaternary salt. So these are the special taste for this amine identifications of amino group primary, secondary, and tertiary. So it gives the amine oxides with 30% H2O2 for the special taste of this tertiary amine. If it is reacts with the H2O2, so it is formations of the one of the somewhat different compound like amine oxide, and this will be indicate that your compound contain the tertiary amine. This is very basic reactions which will be used for the identifications of the nature of nitrogens. If your nitrogen contains the methyl group, so it is called as the N-methyl group, and it can be detected or estimated by these reactions. So it is reacts with the HI, and some temperature is there, so that is 573 Kelvin, and it is formation of methyl iodide. Again, this methyl iodide compound is treated with the silver nitrate, and it is formations of this precipitate of AgI. So this is the compound AgI. It will be indicated that your compound contain the N-alkyl or N-methyl group is there. And with that, it is estimated the how many number of this NCS3 group is there. So it is also calculated, some do the calculations, and we can calculate it. If it is 1 mole of AgI is calculated, then 1 mole of indirectly NCS3 group is there. Now this N-methyl group can be estimated by some distillation methods. Again, methylamine, methylamine, trimethylamines indicate 1, 2, or 3 methyl group attached to the nitrogen, because nitrogens having the capacity to attach these 1, 2, or 3 groups, right? So if it is contain 1 methyl groups, it is the distillated with the KOH, it's formation of methylamine. So this is the particular and the unique product which is giving the informations or the clear idea about the 1 methyl group is present on the nitrogen. Second one, if your compound contain the 2 methyl groups, it is distillated with the KOH, it's a dimethylamine. Likewise, this trimethylamine. So these are the reactions, simple reaction giving an idea about the how many number of methyl group present in your nitrogens, right? So if your compound nitrogen is free, so it means NH2 is there, free amine, so it gives the ammonia as a gas. So this is the simple reactions gives an idea about the how many number of methyl group is there. Now the nature of heterocyclic ring. So nature of heterocyclic ring present in the molecules can be determined with the some degradations methods. So different degradations methods we are using. So Hoffman exhaustive methylations, this is one of the major this is commonly used as an degradation methods. And last one, this is these imidase degradation and Van Braun methods. It is the somewhat the different or the spatial compounds used for the degradations to identify the nature of heterocyclic link. One by one, just to try to understand what is the nature of heterocyclic ring. So as I told you, this Hoffman exhaustive methylation is commonly used. So in that methylations or degradation methods, there is some steps is there, like hydrogenations, methylations, and hydrolysis and dehydrations. So you know people, this hydrogenation and methylations and hydrolysis and dehydrations. So this methods is used to identify the what kind of the nature of your heterocycle present in alkalides. This is the method is repeat till the N nitrogen is completely detached from the ring, and this is unsaturated compound form determine the nature of heterocyclic ring is present in an alkalides. So some of the examples over here. So if you consider as a pyridine, so pyridine because it is considered as a heterocycles or this nitrogen containing heterocycle. So first of all, it is reduction process. So H2 in presence of nickel, it is gives the piperidine. Then the second one, that is a methylation CS in presence of the reagent CS3I, and it is formations of quaternary ammonium iodide. So these quaternary ammonium iodides can be moist with this Ag2O. So it is the giving the quaternary ammonium hydroxides, and this quaternary ammonium hydroxides can be removed of these water molecules under some temperatures, and it is giving, so detach the nitrogens over here, and it is giving the one this in compound is there like double bond. Secondly, this is the fourth step is there, but your compound is not detected and it is not giving the time. Therefore, this process is repeated again. CS3 the methylations and Ag2O. Now this is the formations of quaternary ammonium hydroxide, and now again it is the under some temperatures it giving the 1,4-pentadiene, and the nitrogen is detached from the methylide. This is the final product, and this final product, it will be indicate that your compound contain the heterocyclic nitrogen present in the heterocyclic ring, and it is what is the nature of heterocyclic ring. It may be, so this is the 1,4-pentadiene, so it is compounds giving the nature of this heterocyclic ring. Now the second method, that is the MDAS degradations. So when beta hydrogen atom is not available in the heterocyclic ring, then this method is useful. Okay. So here we take an examples of isoquinoline for our sake of understanding, because this compound is does not having the beta hydrogen atom. Therefore, we are taking an examples of this one. So now we reduce this compound isoquinoline, and it gives the tetrahydroisoquinoline over here, right? So this tetrahydroisoquinoline, again it is methylated, it gives the again same product, that is the quaternary ammonium iodide, and it can be again dehydrated, that is Ag2O. So it is giving the quaternary ammonium hydroxide. This is the process is okay, like your exhaustive methylations. Okay, Hoffman exhaustive methylation. But now here is the questions. So no detachments after this one, because this no beta hydrogen is there. So it means that here we somewhat change the process. So now it is pyrolysis, and then we detach the nitrogen from this uh, carbon atom, this carbon atoms, one and second carbon atom. Now this formations of the in and this detached nitrogen, again the process is repeat with the methylations and this this reductions, again the formation of quaternary ammonium iodide, and this quaternary ammonium iodide, so after the reductions, this reduced product of this quaternary ammonium, this hydroxide, and after the methylations, this final product we got, it is the methylamine and this 2-methyl styrene. So this will be indicate that your compound contain the nature of heterocyclic ring, that is the like isoquinoline. So this is applicable to the compound which are not degraded by the Hoffman methods, and therefore that is the reason is beta hydrogen atom is not available. So some other nature of heterocycle present in your alkaloids, and therefore we cannot be able to find out the about two methods which is also already mentioned. Therefore we adopt the third method, that is the Van Braun methods, which methods used for the heterocyclic ring containing like secondary and tertiary amines. So this is here an examples of piperidine, right? So this piperidine, again it is the benzylation. So now it is benzylation, it give the product on this nitrogen COC6 H5. Now then it is giving, after the brominations, it is giving the product of brominated product over here on the ketone compounds or ketone moiety. Then vacuum distillation, so directly we give the 1,5 dibromopentane. So this is the final product. It will be indicating that your nature of the nitrogen or the heterocycle present in your compounds. So it is like a 6-membered heterocyclic link likewise, right? So this is the simple methods to identify. These are the 3 important methods to identify the nature of heterocyclic ring. So brominated secondary amine. This is the methods which use for the N-methylated piperidine. So tertiary amine is there. So this is the N-methylated piperidine. This is an example. So with the help of the cyanobromides and again is boiled with it and the hydrolysis, then it is a decarboxylations. Final product will give brominated secondary amine, and it will be indicated that your heterocyclic ring nature having this, it is the 6-member ring, but it is the N-methylated compounds, because the final product it is coming the secondary amines like this brominated secondary amine compound which is contained in methyl group. Next one, this some miscellaneous processes is there, right? Reduction degradations. So if it is pyridine is there, so reductions, it gives the piperidine, and this with it is reacts with the hydroiodic acids, it formation of pentane. Again, it is given indication the 6-membered heterocyclic ring. Then oxidative degradation. Some of the oxidizing reagents we are using to the oxidize your compounds, and again it is giving the nature of your the ring, heterocyclic ring. So, for example, we take an examples of the ephedrine. If it is oxidized with the KMNO4, it gives the benzoic acid, and it will be indicate that your benzene ring is there or benzene compound is present in your alkali. And this is our nicotine is taken an examples, and if it is oxidized with the this oxidizing reagent K2Cr2O7 in presence of H2O2. So nicotinic acid is the final product, and it will be indicate that so nicotine compounds or this alkalis contain the pyridine ring is there. These are the methods to identify the nature of heterocyclic ring present in alkalis. Next one is the spectral analysis. With the help of spectral analysis, like this spectroscopic tools as an analytical tools. So NMR, C13, UV, IR, X-ray, mass spectrometry. So on the basis of this spectra, we can easily identify the structure of alkalides nowadays. The last one, this identified compounds, it is confirmed with the help of their synthesis in the laboratory. So some of the methods or some of the alkaloids, it is very difficult, or it is complex structure like your razor pine, papaverine. So it is a complex structure, and it gives this is simple method. It did not work very well. Now we have to take this spectral analysis. Nowadays we generally take an help of this one. So move towards our spatial reference compound, that is the nicotine. So what is the constitutions and these, how to identify these alkaloids? So this class of nicotine, just we previously previous slide we discussed this class of alkaloids, and it is the class of pyridine and pyrrolidine alkaloids is there. This is the class which having the molecular formula that is C10H14N2. This occurrence of this compound, it is present in the tobacco plants, like in presence of this some salt. Isolations of this from the nicotine tobacco, and so these are the properties which is theoretically observed, or this property is mentioned in the theoretically, that is colorless liquids, it becomes brown and exposure to air due to the oxidations. So it is having the boiling point plus minus 246 degrees Celsius. It is soluble in water and having unpleasant smell. So it is because it is salt form, so it is soluble in simple water. So it is optically active. It is in pure form is levorotatory. This, if it is formed in salt, so it is dextrorotatory. This nicotine compound having the highly poisonous, but it is sometimes it is used an insecticide also. It's affect our central nervous system because it is above their lethal levels. So it is used as an insecticide, and it is used for the low concentration. Now, the constitution of nicotine as like of the general structural elucidations of the alkaloids. So, determination of molecular formula on the basis of mass spectrometry, that is coming out the C10H14N2. Now, the presence of dietary nitrogen atom. So, ditertiary nitrogen atom is there because this is the compound which is having the two nitrogens, and it is a ditertiary nitrogen atom. So this can be identified with the simple methods with the treated with the HCl, and it is formations of dihydrochloride salts. So nicotine requires 2 moles of CSCI to form a dimethyl derivatives, and it is indicating that the ditertiary base or it is ditertiary nitrogen is there. So therefore, it is cannot be acylated or benzoylated because of it is already tertiary nitrogen is there. So it is cannot be the giving the product with the acylated or the benzoylation. Then presence of pyridine ring or the pyridine nucleus. Your nicotine compound is contained. So contain this pyridine ring, and therefore it is the pyridine pyrrolidine class of alkaloids. So nicotine is oxidized with the simple reagents like the KMnO4. It is given the nicotinic acids. So nicotinic acid, it means that here you see the nicotinic acid means the pyridine 3 carboxylic acid. So the third positions of this ring, pyridine ring, having the side chain as an the carboxylic acid. So this nicotinic acid product after the oxidations with the KMnO4 and this K2CR2O7 in presence of H2O. This will be indicate that if the pyridine ring as a nucleus is there, right? The next one is presence of double bond, 3 double bonds. So nicotine is having the 3 double bonds. So pyridine ring having the 3 double bonds. Therefore, this is a very important things to identify 3 double bonds. So nicotine on reductions with the sodium and amyl alcohol, it gives the hexahydro derivatives, and it is indicated the presence of 3 double bonds. So this, and the most important thing, it's also indicate that the side chain is saturated. Okay, so it means that this is the reduction process, it gives the hexahydro derivatives. So it means that the 3 double bond present in the pyridine ring and the side chain, it does not having any the double bond is there. So that is the saturated ring or saturated side chain is there. Okay, so now our job is what is the nature of the side chain. So this is, if you see, this is the pyridine ring, and if you consider the remaining the C5H10N, this is the side chain is saturated nature in your alkaloids. So this can be identified some different methods. When nicotinic zinc chloride salt is distilled, then a mixture of pyridine, pyrrole, and methylamine is formed. This product is indicating that, so pyridine is already we identified. So the next one, that is the second one pyrrole, and third one is the methylamine. So it means that the nature of the side chain C5H10N, it is the pyrrole and the methylamine, right? So this reaction indicate that the side chain is pyrrole derivatives and the methylamine pyrrole derivatives is there, right? Now the presence of N-methyl group is there. This N-methyl group is identified with the help of simple reaction with the treated with the concentrated HI at 150 degrees Celsius. This is the well-known reactions. Then this methyl iodide is obtained, and which indicate the presence of N-methyl group is there. So thus the side chains having the N-methyl pyrrolidine. So there are 2 possible structures of the nicotine. So it means that, so if it is the nucleus is the pyridine ring, so there is the possibility, 2 possibilities there. This side chain is maybe present on the third position or maybe present on the the pyrrolidine ring is present on the third position or present on the second positions, right? So here is the 2 possibilities, this structure 1 and structure 2, which are having the position 2 or position 3 respectively. So these confirmations of the structure of nicotine with the help of some reactions like the Pinner's evidences support structure 1. Nicotine on treatment with this bromine in presence of HPR is followed by the heating with the BaOH by 2, giving the nicotinic acids, then malonic acids, and this the methylamine. So these three product, it will be indicate that the possible structure 1 is correct, right? So this is a very important things. But what about the second structures? If it is second structure is there, the second structures, if it is there, then this is again confirmed with this some reactions. So oxalic acid and methylamine. So second, the treatment with the Br2 in acetic acids forms bromoderivatives, and this treatments with the H2SO3 followed by the heating with the mixture of H2SO3 and H2SO4, giving the 3-acetylpyridine, right? This then the oxalic acid and the methyl, right? So it confirmed the 3 substituted pyridine ring and structure 1 for the nicotine is confirmed. So this possibility of this second structure, so this is substituted, the second possible, this possibility is the neglected, right? Now this Kerr works is 1926, presence of pyrrolidine ring. So nicotine on treatment with the HI acids giving the nicotinic hydroiodide, which on further treatment gives the with the CS3I gives nicotinic nucleotide. So again it is nicotones and the N-methyl. This is the heroin. So this compound is again confirmed the pyrrolidine ring is attached to the pyridine by positions 2 and structures 1 for these nicotines, right? So these are the some methods to identify the nicotine compounds, their structure, and now it confirmed with the synthesis of the nicotine in the laboratory, right? So simple starting material, that is the nicotinic esters, is treated with the diethyl succinate, and it is formations of this the adduct, that is this which is present on this the third positions as CO. So COC2H5, it is reacts with this diethyl succinate. And again, further reactions with this 5% of this reagents, then it is remove of this C2H5. Okay. So again, it is formations of the simply commonly acids, and again this decarboxylation with the some temperature, it is formations of the single acids, right? So this is the compound. It is treated with the C2H5 is ethanol, and in presence of HCl, it is formations of this. This adduct is reacts with this methylamine, and it is formations of this again next compound, and which is reactions on this carbonyl compounds, and then these reductions, after the reductions of this compound, it is formations of NH and CS, right? So this reductions after the hydrolysis gives the your compound this ring closing over here, and this after the ring closing, it is reduced with the lithium aluminum hydride, which is the reduce this double bond as well as this ketonic compounds, right? So these formations of this nicotine compound after the resolutions with the tartaric acid, it is formations of the your pure compound, which is the neurotatory nicotine compound. So this is all about the methods to identify the nicotine as an the reference compound for these alkaloids. This is the vast class of alkaloids, and we are taking some simple examples of this. Thank you very much. If you have any questions, so you can ask. Yes, anyone? I know this is the very basic chemistry, but it is very important for two identifications of alkaloids. And everyone know of this one, so nobody have the questions.
Good afternoon, sir. Sir, wonderful presentation.
Yes. Yeah,
Sir,
thank you.
basically, I was working in the natural product chemistry. I found these molecules, alkaloids, more pharmacologically more active than terpenes and terpenoids. Sir, why they are more more active on different cell lines? When we go for their pharmacological activities, alkaloids molecules show more activity.
More activity, alkaloids.
Yes. They show, if we compare them with terpenes or other oxygen-containing molecules, these alkaloids show more activity against different cell lines, cancer cell lines.
Yes, it is more active, showing the pharmacological activities. But I think I don't have the answer for this one. Why it is more active than that of the terpenoids and other class of these natural products? Because I think it is more heterocyclic compound is there, like nitrogens and other heterocyclic compound. That one is a possibility, or something. There is some